And are you talking?
No, I haven't started talking just yet.
All right, cool.
Get, Getting ready to. Take a couple sips of coffee. I'm not quite awake yet. Had the fortunate activity of waking up at 4 o'clock this morning with my son. He's only 1 year old, but decided to wake up and he decided he wanted to play at 4 a.m. So it's been a long morning.
It seems kind of miserable right now, but trust me when I tell you, cherish every minute of that. Everyone will tell you, and you'll on an intellectual level, you get it, you understand. But
Hmm.
when they're 17 and they want to go hang out with their friends, and you're an afterthought, it really matters. So definitely cherish that.
I will keep that in mind. I will try to keep that in my mind. I appreciate that. So kick things off. So we left last night, finishing up Lab 4, and that was creating logic for a pump, or hot water pumps, to run um, based on conditions met um, with outside air temperature in comparison to a set point. Now, I haven't done the rest of the labs yet, so I'm going to do those while I go through the review. So if you're still working on a few things, trying to wrap those up, you're more than welcome to just listen in and continue to work. But if you're still working on lab 5, by the time I get to lab 6, I would ask that you just or if I get to a lab that you haven't started yet, I would ask that you just take a moment and watch so you can see what I'm doing as we're going through the review. Because there's some things within the lab, if you haven't gotten to it yet, that are going to be important for the test. The main thing about these labs for the logic is to kind of give you just a basic understanding of how the fundamentals of creating logic works within Niagara. Each lab introduces something new, and it's usually about one or two new things within each lab that's important to remember, not only for in the field, um, but also for the test on Friday. And I will point those out. Like I'll make it clear as day that hey, this is going to be on the test because I want to prepare you guys. Um, and it's usually stuff that's important and you want to keep in mind. Be mindful to use out in the field because you'll probably run into a scenario where you're going to want to use some of these components. So I'm going to kick things off. I'm going to start lab 5. I went ahead and renamed my pump freeze protection, or my T-stat object of pump freeze protection, and I have renamed my pump freeze set point to just pump freeze set point. There's a couple other things that I need to do, but right now I'm just kind of getting my building blocks put on the wire sheet here, mostly from memory, because we're only really setting this up to either run off a schedule and then have a freeze protection override if the outside air temperature drops below, that threshold, right, that we set for the set point. So I went ahead and relabeled everything. I know I need to go back to my freeze protection T-set object. There's going to be a few things that I need to change in there. But first, I'm going to go ahead and throw the pump schedule in because this is a key important element here. This is like the schedule is the backbone to just about any logic that you'll build in a BAS project, because we can formulate all these complex logic to run an air handler or a piece of equipment. When we take into consideration enthalpy or whatever more advanced engineering ideas. Um, but really, the most simplest and most important thing that really falls back down to the schedule, because this is what dictates. This will generally dictate when your equipment runs on a daily basis. Um, So understanding how to properly use a schedule um, is pretty important. It's as trivial as it sounds. Um, so I created a Boolean schedule. So we found that based off the lab, we found the schedule palette here. And like I said yesterday, there's going to be a lot of things. Majority of which you're going to find that we're going to add to our system is going to be from some sort of palette. Um, and you can, find these various palettes just by coming to the Open Palette button and using the uh, filter box here and find exactly what you're looking for. And if you hadn't figured it out already, and I failed to mention it to you guys yesterday, just like with our recall facets, where we can recall facets that we've used previously, we can do the same thing with palettes. So this drop-down box right here, if you hadn't figured it out yet, you can look at all the palettes libraries that you've already previously opened. So that's pretty handy when you're kind of jumping around a bit. Um, and you need to go back and forth between multiple palettes instead of needing to open multiple palette windows to keep track of these different libraries. You can quickly just jump back and forth um, with this drop down menu, so that's pretty handy. So I'm going to really highlight on this section of the lab the importance of schedules. So the first thing, so we added the Boolean scheduler, right? So what a Boolean schedule does is it determines when something's going to be on or when something's going to be off. We can also determine whether something's occupied or unoccupied. So again, Boolean is one of two states. Typically, it's on or off, true or false. So that's how I want you to think about Boolean schedule. It's going to be one state or another, and typically you will see a Boolean schedule used for either cutting equipment on or cutting it off, or setting an occupancy or an unoccupancy, and you can tie these together. Um, you can tie these to other systems as well. So I can create a pump schedule in this wire sheet, but I can also link back to this pump schedule to other wire sheets that might be using the same schedule. So I don't need to create a new schedule for every piece of equipment or wire sheet that I do for logic. Um, and this is actually something that you'll do on Friday. We'll actually have you just create a folder in your nav tree, and we'll list all of your schedules in just a folder. And then in your logic, your wiresheet logic for Friday, you'll reference back to those, and we'll see how we can do that in the upcoming labs here. So we created the Boolean schedule. It's pretty simple to set up. So the first tab that we see is the weekly schedule tab. And the weekly schedule tab, this is where you set the condition on, off, or true or false, or what have you, and the time block that we want that condition to be either on or off, um, and whether or not we want the default value uh, to be on or off. But for this case, we want to just, I believe, so I don't get too far ahead of myself, because I have a habit of doing all of this out of memory, and I tend to miss something. Um, okay. So first it wants us to go to the properties, and we're going to change the facets. So all we're really doing is changing the true text and the false text to something else other than true and false. So our true text we've changed to pumps on. Pretty simple, right? So we can assume when the condition is met as true, or when we've set it to true, we want their pumps to be on, and when it is returned to false, we want our pumps off. Okay, we can see how the default value here has changed. And within the properties tab here, so we have 4 different tabs at the bottom of the screen. Right now we're in the properties tab. And we can see that we can change the default value if we wish. Right now, for this one, we want to keep pumps off as our default. So we only want to declare when we want our pumps on. But you can actually, change this in reverse if you ever need to, where maybe you want your default to be pumps on or whatever doesn't have to necessarily deal with pumps. Um, and then if you've noticed, there's this little null checkbox next to that, to the default value. Now this is used for when you have another logic block um, outside of the schedule dictating what the default value for um, the schedule might be. And this holds true to other types of logic blocks as well that can be written to. So for example, if I don't know, let's say I have some sort of just binary something, and it dictates what, the default value is going to be. This isn't a really good example. This really starts to make more sense when we do like a numeric schedule. And with the numeric schedule, I don't think we tie into a numeric schedule within these labs here. Um, but a numeric schedule, we can set obviously a number for a certain time or date ranges within our schedule. Now, maybe we want our default output or default value for our numeric schedule. Let's assume that's a set point, right, for a room. Maybe during 9 a.m. to 5 p.m., that's occupied hours. Maybe we want our set point to be 70 degrees. And maybe it's winter, so we want our fallback value. So during unoccupied times, right? So when nobody's in the building, or probably isn't in the building between after the hours of 9 and 5, we want our set point to fall back to maybe 65 or 68. Now we can set that default value within the schedule itself, but maybe we have a logic block that holds that set point value that determines whether it's winter, summer or winter, um, and that dictates what the default value is for the set point. We can look at that more, and that's something we'll cover later when we go through like the full class review and I show you some extra stuff. Um, we'll go over that more, just kind of give you an idea. But we do that here in the properties tab. Now let's jump back over to, I believe, the weekly schedule tab. So this is where we actually declare the date and time range for a typical week. Now, if we wanted to get specific about specific days within a month, um, that's something we can set up for special events, or and that's typically something we would do within a calendar schedule. That's where you will dictate certain special events if you needed to have something outside of the normal Monday through Friday or Sunday through Saturday type of schedule. So to simply declare a time range within your weekly schedule, all we need to do is click within the click inside with a time range within a day. So I think it wants us to do 8 to 5. So I can really click anywhere, and I can edit this time range that I've actually dragged in here, and we can see that I'm actually declaring, for pumps on, for the states of pump one. And I can change this in the event output down here if I needed to. But you can also, when you click within that time block that you created, you can actually edit it by a numeric field down at the bottom here to event start and event finish. Here I can easily just set this to 8 a.m. to 5 p.m. Now I've done that, and I don't necessarily need to drag and click the same thing over and over again within our weekly schedule. I can simply click this one time slot that I've already created and apply Monday through Friday, or I can copy and paste it on Sunday and Saturday as well. If I have different time blocks for different days, you can just as easily adjust those after they've already been set by either um, grabbing a handle on the top or bottom of the time slot, and you can even adjust it like this as well. Um, but you can also use the number fields down here at the bottom, the event start and event finished, to better adjust the time range that you want to use. So it doesn't all have to be the same time ranges. You can do some custom time ranges depending on your building needs. So we have that. That's pretty much the basics of a Boolean schedule right there. Um, we want to save this. Now there's the special events tab, and we'll come back to this when we make a calendar schedule when we declare. I think it's New Year's. New Year's Day is going to be our holiday that we're going to set up as a special event. Um, but we'll come back to that when we make that. So we've got our Boolean schedule. We've saved it. We've set the time and date range from Monday to Friday between 8 a.m. and 5 p.m. We want the pumps on, right? So now that we have that, we can come back to our wire sheet, and I'm going to come out the outsource. I'm sorry, the out slot, not the outsource. So the out slot, and I want to tie this into the in slot 16 of my hot water pump controls. Now remember, these different in slots are it's a priority array, right? So we report on. I'm going to move the schedule. So if you hadn't noticed, the lines can get a little confusing depending on where you lay your logic blocks. But so remember, there's a priority array built in with each of these points or these logic blocks. And when you're writing to one of these points or logic blocks, each of these slots from 1 to 16 has a priority. 1 being the highest priority, 16 being the lowest priority. And remember, and we'll go over this more, later in class. But remember, there's a few reserved priority blocks for emergency overrides and overrides in general. So there's some priority slots that we can't write to. So if we can take a look here, we have our freeze protection logic here that we had set up, which is now our freeze protection logic. It's writing to a priority of 5. So on each of these. And our pump schedule is writing to the lowest priority, which is 16. I think we're actually writing to 16, right? Yeah. So our pump schedule is writing to the lowest priority within the pumps. So what that means is as long as there is not a condition met where we need to have our freeze protection logic cut the pumps on to prevent the pumps, the pipes from freezing maybe. Our lowest priority is our pump schedule. What this is typically how you would set up, how you would have your pumps, or I'm sorry, your schedule right to a given point. Typically, schedules tend to be one of the lowest priorities. You leave space for overrides and or safety logic. So anytime our freeze protection isn't calling for our pumps to be on, when our pump schedule says when it's Monday through Friday, 8 a.m. 5 p.m. Our pumps will cut on, right? And then anytime outside of that window, the pumps will be off unless the freeze protection overrides that and cuts them on. So there's a few other things that we need to do here. So we've set up the pump schedule. I think I need to go back through into my freeze protection and freeze protection set point and change a few things. So give me a minute just to look back at my lab book here because I've done all this through memory so far. Make sure I didn't miss anything. So change null and max. Okay. Okay. I think that's something I really needed to change there. Okay. So now that we have that, so when the pump says, "Hey, cut the pumps on," it's gonna write to that. And if you look at the slot that it writes to within the pumps, we can see that the current status for that slot is on, right? So we can have two different logic points writing to these pumps controls at the same time. So imagine the pump schedule is saying that, hey, conditions have met in the schedule that we want the pumps on. So we can see in the in slot 16 that the status is currently for on. or it's writing on to our pump controls here. Now, if our outside air temperature or our freeze protection condition is met, and it also writes to on and writes to in slot 5, the priority 5 for the pumps, even though both of them are technically calling for it to be on, um, freeze protection in slot 5 priority will obviously take priority, and both will command on. But let's say the freeze protection has the pumps running on and the pump schedule has it running on. When the pump schedule reaches 5 p.m. and goes off, but our freeze protection is still on, the pumps will remain on. So that's kind of how that priority array works as well. So that's the basics of that. So the next thing we want to do now that we have running it off a schedule and a freeze protection, the last part of this lab is adding in the calendar schedule. So it's another type of schedule. And something to keep in mind here, and I like to point this out. So I'm going to expand my palette window here. So these 4 pump schedule selectors at the bottom of your palette, you will not use in this class. It's I don't can't really think of a use that you'll use it out in the field either. It's kind of a niche use. It's using when you have multiple schedules, and you might be bounced between different schedules based on certain conditions or reasons. And you can write up logic to determine which schedule will be used, and that's what these selectors are for. So we're not using them in this class. If you find a niche or if you find a use for them out in the field, that's the time that you'll be using those. But for now, I want you to focus on using the Boolean schedule, the enumerated schedule, numeric schedule, and the calendar schedule. Yes, now we only use the Boolean schedule and calendar schedule for these few labs here. We will look at the enumerated schedule when we get to the lawn labs later this morning. Um, but these are the only schedules that I want you to worry about for this class. Do not use the Boolean, or do not use any of these schedule selectors. I've seen people on occasion drag these into their wire sheet, not knowingly, um, not knowing there's really a difference. So don't use the selectors. So again, we're using the Boolean schedule right now. That's dictating when we want something on or off or true or false. And the next thing we want to do is add our calendar schedule, because this is going to dictate our special events or our holidays. And I believe we are naming this holidays. So you add this, and we're actually not going to make any sort of link with this calendar schedule, because we're actually able to reference this holiday schedule within our Boolean schedule. And we can do that with any type of schedule. All schedules have this special events tab. And this is how we can make a reference to a calendar schedule. And that's important to note, and we'll dive into this more too. You never want to link one schedule to another schedule, like a physical link, because all that's going to do is override the current schedule, and it's not going to override it in the way that you want it to. So, for example, if I go from my outslot of my holiday calendar schedule, and let's say I write it into my pump schedule, notice how I was calling my pumps to be on. But now, since I wrote my holiday calendar schedule into the in-slot of pump schedules, now my pump is saying pumps off. Because what my holiday, making a link from one schedule to another schedule, all it does is override the schedule, no matter what that schedule is supposed to be doing. So this is why we do not make physical links between 2 different schedules. We reference other schedules if we need to do that. And when we reference those schedules, we actually write out conditions to be met for that override to happen, or for the special events. So we do not want to link one schedule to another schedule. That's a big no-no. So we'll go into our calendar schedule real quick, and when we get into our calendar schedule, this is what we see. So here we can add or edit or rename, whatever, various special events. For this example, we're making a holiday schedule, so we're going to add certain holidays that we know that our building is going to be unoccupied. No one's going to be in there. Or you might have special calendar events for various maybe some fluctuation within your schedule. Maybe you have extended hours or shortened hours during certain days, and you can create a calendar event for half days, extended days, what have you, night shifts. You can create these calendar schedules for certain conditions, um, or certain events, and then we can reference back to those schedules. So when those dates do come up, it will, you know, reflect that within our booleans or various other schedules that we reference to. So let's go ahead and just add the. I believe we're doing New Year's Day. Yeah, so we're doing New Year's Day as our holiday, which we all know is January 1st, no matter what day it falls on. And we're going to set this to any year. So January 1st of any week of any year, that we're going to have this holiday. And we know that our building is probably going to be unoccupied, so we want our pumps to be off. So with that set, that's all we have to do here. We're just declaring the day of the event. So we're going to save that, and we can go back to our wire sheet and come over to our pump schedule. And now we're going to make a reference. So when we get back to our Boolean schedule, if we come down to our special events tab, we have this add button down here. There's a couple.
Excuse me, Brandon.
Yeah.
Uh, if let's say we want to add another holiday, need to keep on adding, like on our holiday schedule,
Yes, you can
having
add
made
as
for the
yeah. So you're saying like you want to add, a list of holidays here, right?
maybe May 1 or
Yeah.
yes, a list of holidays. Yes, that's what I'm trying to say. Yeah.
Yes, you can add as many holiday schedules or as many holiday days or dates in here as you wish. And we can do more than just one day. We can block off an entire week. We can block off a section of days.
Okay.
And we'll go over that here in just a bit. But that's when we get into you can hit the add button to add additional days or uh,
Yeah. Yeah.
time slots.
Okay.
And we have this drop down here. It says type. So this one just says date, but we can say we can set a date range, set week and day. We can go in custom and have a custom event, several days or whatever. We can do all that here. But yeah, so
Okay.
the thing to
Thanks.
keep in mind for this is um, you want to group your calendar events or your special events that are going to have the same outcome. So you don't want to have all your holidays, or let's say the entire day is going to be off. You don't want to link your half days or your extended days in those calendar schedules. You want to have separate calendar schedules for similar events. So all the days that the building's going to be closed, you keep all of those holidays or events within that one calendar. So I'm not going to save that. Go back. Boolean schedule. We'll come to the special events. When we come to the special events tab, we need to add a reference. So we hit this add button down here towards the bottom of the screen. And when we do that, we have the option to actually create the event in the special event tab if we wanted to, but that's not really useful unless we have a special use for it. Because if I'm making a time block for January 1st, and I'm doing it in this schedule, and I have several other schedules that I need to do January 1st, instead of having to go to each of those schedules and input each individual holiday, which you can do if you need to, um, we can also just reference a holiday or calendar schedule that we've created. So we want to change in doing this within the Boolean schedule, special events tab, hit the add button.
I
And then,
I got a quick question.
yeah,
So yesterday I had to switch from my work computer to my home computer, and I'm looking at my I finished up this lab 7, but it's disappeared.
Just disappeared.
Yeah. So like when I was working on it, I was on lab 7. My whole blank, my screen went blank, and then I refreshed, but now I don't have anything.
Which station are you?
Station number 1.
Mhm. Let me sit in front of your machine real quick. I mean, what I'm looking at right now is I see a lot going on there.
Yeah, but my boiler points are gone. My chiller points I'm working to restore right now, but
Okay, could you do me a real quickly? Just cancel that what what you got.
mhm.
Double click the boiler control IO folder, boiler control, the one down below that. Okay, now it's double click heating pump IO.
Double click heating pump.
Okay, there's your heating pump points. Expand that folder for us there. I think those points are there, so
Yeah,
you're
those
good
are
there.
those
The
were
boiler, see the
that was
boiler
great.
control, I don't know.
The boiler
So
control disappeared, and
okay,
the chiller is got
I tell
some
you, let's
points,
do
but
this. Let me do this in effort to keep the class going. I'm sitting in front of your machine. Let me drive your
mhm.
machine just for a few minutes, and I'm gonna let
Okay.
go ahead and let Brandon continue with the class, and I'll jump back in. That way, I can help you out kind of one on one without holding everybody else up. I'm gonna look at a
That
few
works.
oddball screens real quick, but I'll I'll jump back in. But just give me a mouse and keyboard, and Brandon, you just
Oh,
kind of keep on.
All right. Okay, so to make a reference, we have to add the reference into the special events tab within any given schedule. So this works the same way, whether it's a Boolean schedule, enumerated, numeric, or what have you. The only difference would be a calendar schedule. So there's not really a need or the ability to link one calendar schedule to another or reference one calendar schedule to another because it's like type. So after we hit the add button, we want to just change the type to reference. Now it's going to look for any calendar schedule that's currently within your wire sheet. And I believe it'll reference any calendar schedule that might be within your entire station. So if we had more than one calendar, it would be listed here. Now, something important to keep in mind here. So we have one schedule available to us, or calendar schedule available to us that we can reference, which is the holiday calendar schedule that we created. One thing to keep in mind, though, we have to make sure that we actually select it. I don't know. We're not really sure why it doesn't have one just selected by default. If that ever is a question that popped in your mind, we've talked to the developers about it, and they seem to think that there might be a special case use that you might not want any calendar schedule reference, even though you're adding a reference. So yeah. So what we're going to do is make sure that we have our calendar schedule that we actually want to reference in our schedule selected. Um, and if we don't have it selected, which I will show you what that looks like, but I'm going to go ahead and add this one so we can see what that looks like. So we see the event, the reference, and it shows the slot of where that holiday schedule is. Now, if I go through and add and do a reference, but I don't select anything, what I will get is a event and the summary will be reference null, meaning we're not actually referencing back to any calendar schedule. So for Friday, keep this in mind. You will create a calendar schedule on your test on Friday. And you'll need to reference it into multiple schedules that will be creating on the test. And you want to make sure that you actually have a reference selected, a calendar schedule reference selected. And the clue there is if you're not If you're not sure, if you see that reference null in your summary, then obviously you didn't reference the calendar schedule properly. And you can easily, even though I have this reference null here, I can just as easily go into it, double click it or hit the edit button and select a calendar schedule. So this can be used to switch to a different calendar schedule that I might have as well. So it's an easy fix. But I'm gonna go ahead and delete that one. So now that we have our calendar schedule reference, now what do we want our Boolean schedule to do when a special event actually happens? So this is where this little time block here comes into play. Now notice I need to have my event actually selected, because you can have multiple events tied to your Boolean schedule or any of your schedules. So you can have multiple calendar events or calendar schedules referenced to your schedules. And you can set up different date and time or time blocks based on each of these individual calendar schedules that you might have added. So you want to make sure that we actually have a calendar schedule selected first. And then we want to just simply right click the scheduling tab here, or not the scheduling tab, but this time block here. We want to right click it and just say it's an all day event. And we want to change the event output from pumps on to pumps off. So what we're saying is during this holiday, any of these holidays that we input into this holiday calendar schedule, we want the pumps to be off, right? Because nobody's going to be in the building. Now, if you're creating a calendar or creating a special event and you want it to be, let's say we're creating as a calendar schedule for extended days, maybe the days start at 6 a.m. and they go on till, I don't know, 9 p.m. or something like that, something crazy. We can create a special calendar. We can create a calendar schedule to, reflect extended days, and we can come in, reference that extended day calendar, and then come and set up the time block. And we don't necessarily want the pumps off for that type of, scenario. We actually want the pumps on. We would just change the event output here. Now notice when I click off of my event here, the reference event, this returns to a default of nothing like unscheduled. But if I click back onto my calendar schedule reference, we can see, the customization here. So I can easily just, return this to an all-day event, pumps off. You can right click it, you can clear the day, you can change, you can delete the event, you can change everything you need to in here. Now, if you were to create a calendar or an event within a calendar schedule that maybe is a date range, so let's say winter holiday break, right, for school, or even maybe even office, and we know there's going to be a date range maybe from December 23rd till December 26th, just throwing some random days out there. So we know we have like 4 or 5 days that the building's going to be unoccupied. We would set that up in the calendar schedule, but it would look the same setting up the time block. So we're not setting up a date and time block here in the reference. We're just setting the time range. We're setting up the date range in the calendar schedule, if that makes sense. So that's a little bit about schedules. We'll see more on schedules as the class progresses. When we get to lawn, we'll look at enumerated. And I think, do we touch on numerics in any of the labs? I can't remember. Right. Yeah, so I'm gonna go and take a minute and show you what a numeric schedule looks like, because we actually don't have a lab that includes a numeric schedule, but you will see enumerated. But numeric schedule is pretty simple. So I'll just go and drag this out here. I'm gonna leave it numeric schedule. Actually, no, let's have a purpose for this. So I'm gonna rename it and just call it set points schedule. So our set point schedule here, it's a numeric schedule. This is a classic use of a numeric schedule, is creating set points. And so if I go into this numeric schedule, it looks pretty similar to the Boolean schedule, right? What the key difference here is the properties and the event output, right? So right now it's currently all set to null. But if I go over to my properties and I'd say I changed my fastest to degrees Fahrenheit because I'm setting up a set point. And I want to change the default output. This is currently null, giving us the option, by default to write a default set point number or a default number in here. So we want our default output, let's say off hours, we want the set point to be 68. We can do that, we can hit save. And if we go over to the weekly schedule, we can see that our default output is currently set to 68, Sunday through Saturday. Now we can just as easily, let's say we want our occupied set point to be 70. Actually, I have to just drag it in. So let's assume it's, Monday through Friday, 9 to 5, right? Typical office work schedule. So 9 to 5, and now that we actually have a time slot created, now we can actually input that we want it to be, 70 degrees is our occupied set point temperature. Now we can actually take the schedule and link the schedule to our set point or any other type of numeric point that we have that we want it to take this set point change from the schedule. And we'll look at that in just a second. So, Monday we want it to 7 degrees. Now you can set up different numeric values for different time slots. So maybe, in the 9 to 5 we want 7 degrees, but maybe we want to set up a warm-up time. Maybe we want to go from 6 a.m. to 9 p.m. or 6 a.m. to 9 a.m. We can drag in another time slot within the same day and change that value. I don't know, maybe it's cold and we wanted to have a warm-up period. Maybe we set the set point to 72 from 6 a.m. to 9 a.m. and then have our set point drop back down to 70 from 9 to 5. So we can do that kind of thing, within a numeric schedule. And we can copy it just like we did in the Boolean schedule. And if we need to edit it, and maybe we don't want to have that happen on Tuesdays or maybe Friday, we can, delete that little bit of event. We can adjust any of them with any time block. So you have a lot of control over, your date and time blocks here. And you can change these values if we need to. Maybe we don't have a warm-up time on Fridays, but we want to change the value to something else. Whatever we need to do, you can do that here within the numeric schedule. And that's really the key difference here between numeric and Boolean. A lot of the setup is the same, but the purpose is different. We want to take into consideration what we want our fallback number to be and what have you. So assuming that we're actually writing these values out, how would that look? So if I jump back into our wire sheet and we have this numeric schedule, maybe we have our freeze protection set point. I'm just using this as an example because it's numeric writable. So currently the fallback is set to 55, right? So fallback is the absolute lowest priority. It's not even really a priority. It's just the default value when nothing is currently writing to that point. So nothing's currently writing to our numeric writable set point, freeze protection set point. But if I go from my out slot, which is currently saying 70 degrees based off the time slot that we created for Tuesday, for this time range, is 70 degrees. Now our current set point is 55 degrees. I can write this to, let's just say, in slot 16, and we're going to see that our set point, our set point here changes to 70 degrees. So now imagine this is our set point for a piece of equipment, or maybe it's a set point like block for a thermostat or a temperature sensor within a classroom or an office building or what have you. discharge air temperature sensor, or not sensor, but discharge air temp set point for an air handling unit. We can dictate what that temperature would be based off of this numeric schedule and tie it into that numeric point that is going to be our set point, right? So it's reading 7 degrees. If I came in here and adjusted the numeric value for that time block, or I adjusted that time block and it is outputting a different value, that would reflect into this as well. Now, something to also keep in mind, we can do this in reverse as well. So let's say I delete this. I've got this returns back to 55 as default value. Now, what I'm going to do here is just duplicate that when we're just going to have, we're going to call this default set point. So I've created a default set point, and I'm going to actually set this to be, yeah, we'll leave it at 55 because it's a drastic number that we can actually see a difference that we don't have set up here. So I'm going to go from my set point, default set point that I've just created, this numeric writable, its out slot to the end slot of the set point schedule here. Now, what I'm going to do here is go in here, go to the properties, and I'm going to change the default output back to null. So now that I can have an additional block right to create, I can have my default set point or default value of my numeric writable being written from another point within my logic as well. But in order to do that, we'd have to come through here and change the default to null. So it's just another thing you can do if you had somewhere in the logic that dictates what the fallback value would be for a numeric schedule. So that's numeric schedules. Pretty simple, right? All right. So that is lab 5. So that was lab 5. So I'm gonna go ahead and save my station, and then we're gonna jump right into lab 6. We're gonna go ahead and get through that. So while I get ready prepared for that, does anybody have any questions about schedules? Because that was the big takeaway from lab 5. Okay. All right, so what we're going to do next is in this next lab, we're going to do some more rearranging, and we're actually going to do some setup to have our pumps run on a lead lag system, where only one of our pumps is going to be running at a time based off of runtime. And how we do that is we're actually going to use an extension. So if you remember from the slideshows yesterday, the extension is a way to extend the properties or capabilities of a point. So by default, most points are very bare bone. Out of the box, they're very simple. But if we want to extend the functionality of any given point, we'd have to add extensions to them. So that's what we're going to do in this lab, but we need to do a little bit of setup. And I believe we're just rearranging some things here. So let me just go through here. So select the link between the pump schedule, blah, blah, I'm breaking those, okay. I'm gonna be going back to my kit control. So bear with me while I just get my setup going. All right, so we broke our pump schedule from tied into our pumps because we're gonna rearrange some things here. We're gonna have our schedule tied into our lead lag object that we're gonna drag in here. So that's the first step that we have to do here. So if we go back to our kit control palette and go to the HVAC folder or HVAC folder, we're gonna look for a module called lead lag runtime. And and I found that here within the the HVAC folder. And just like everything else within the palette window, dragging it into a wire sheet and just drag and drop it. When I drag it onto an empty space, it's going to prompt me to rename it. So I'm going to name this pump LL for pump lead lag. And this logic or this function is going to help me dictate which pump will run when a condition either by the schedule or the freeze protection, or when the schedule dictates that the pumps need to run, rather. So we've added the lead lag object. We've renamed it to pump lead lag. We need to go to its property sheets, and if you remember, all we have to do is double click the point within the wire sheet to get to its property sheet. There's a few things we need to change. First being, we're going to change the facets from the true text to the on off. We're going to change the number of outputs. Actually, it's number of outputs is currently set to 2. But we're going to leave that at 2. We're going to look at its max runtime. It's currently set to 6. We're going to change it to 5 per the instructions in the lab here. And then the feedback delay is 10 seconds. So if we scroll down a little bit further, we see that's currently set to 5. We're going to change that to 10. We're going to save that. All right, then we're going to go back to our wire sheet. And we are going to go from our pump schedule, the outside of our pump schedule, and we're actually going to drag that into the end slot of our pump lead lag. So this will be one of the conditions or one of the things that our pump lead lag will look at to determine when the pumps need to come on, or when the pumps need to come on. Now it's you might get an alarm, or you might see an alarm on one of these, and that's perfectly fine because we don't have it completely set up yet. So just ignore that. So we're going to go from the out slot of A, and we're going to connect it to in slot 16 of pump 1 control, and we're going to go out B from pump lead lag into the in slot 16 of hot water pump 2 control. So now we have 2 different slots that will control the pumps individually, at least based off the schedule, per when the schedule tries to cut the pumps on or run the pumps. Now, currently it's still set up, and I believe we leave it this way, that our freeze protection that we have set up will still override and run both pumps, regardless of what this lead lag system is trying to do when the freeze protection condition is met. So now we're actually going to use our statuses, our pump 1 and pump 2 status. We had created them, we dragged them to the bottom of our wire sheet, and we ignored them for the past couple labs. But in order to use them, we need a little bit more functionality from the logic to dictate which pump is actually on. So we're going to need what's called an OR block. So if we come to our Git control palette and we look for a logic folder, we'll expand this here and collapse HVAC, we can find the OR block. These are mathematical functions that we can use within our logic here. So we're going to drag the OR block onto our wire sheet, and we're going to name this pump status OR. What this is going to do is going to look, it's going to switch between the two depending on which one is on, and it's going to report which one is on to our lead lag block up here. So we're going to go from the outside of pump 1 to NA, and the out slot of pump 2 status to NB, and then the out from the pump OR to the feedback slot of our pump lead lag. So what this is going to do, whichever pump is commanded on, this kind of gives like a feedback loop to our pump lead lag system to verify that, yes, that one pump is on. So we're going to do a few more setup here. Double click, okay. So we're going back to the property sheet of the lead lag. We are going to set the feedback property to true and save changes. So we can see that our feedback is set to false, okay. Can't actually do anything within the text field right now. Whenever you see this double arrows here, this is how you would change the value for something like that. Because typically, we have this drop down box here, and we can set it to true, save, and go back. If we need to, we can clear any alarm states. So clearly I have an alarm on the out slot A. This might have been an alarm that just popped up during the setup, but I can right click this object here, go to actions, and clear the alarm state, and it should clear it. All right, so we've got all of that set up. We got our pump status or set up, and I believe there's just one other thing we really need to do here, and that's when we're going to start actually looking to extend a given point here. So we're going to look at the first extension that we're going to use in this class. We'll see extensions more as we progress through the class, different types of extensions. But again, to keep in mind, extensions is to extend, it's in the name, to extend the functionality of a given point. That's what extensions are used for. So what we're going to look for is a discrete totalizer extension, and we're actually going to add it to our hot water pumps. So if I look for, let's see here, should be a folder called extensions under the control palette at the top here. We're looking for the discrete totalizer extension. Now, the easiest way to add an extension to any point is to add it to its to the point in the nav tree. This is the easiest way, the more foolproof or fail-proof way to do it, because when you're trying to drag it, you can't drag an extension onto a point within the wire sheet. Yes, it gives me this plus icon saying that I can do it, and it'll be like, okay, yeah, but then I'm gonna get an error. It's gonna say drop failed. It doesn't like when we try to drop things on top of points in the wire sheet. So there's two ways of doing it. The easiest way, obviously, is to drag it onto the point. So we're dropping it on the hot water pump 1 control, as well as pump 2 control. But the easiest way to do that is to just drag it and drop it on the point in the nav tree. Now remember, we have to drag it onto the name of the point itself, not to the empty space next to it, even though it's highlighted in blue. We have to drop it on the actual name, and we can see the name gets highlighted when we hover over it. So we do that, we get a name prompt saying, hey, here you go. What do you want to name this thing? We're going to name it runtime total, I believe. So we're renaming the extension to the purpose for it. And that's something we're going to get in the habit of doing here, for the rest of class too. Anytime we add an extension, 9 times out of 10, we're going to rename the extension to its purpose. Because a lot of different extensions, we have the option for customization, and the generic name of the extension can be quite confusing, especially to the end user who doesn't quite understand what a discrete totalizer extension is. But they might better understand what a runtime total is, right? So yeah, so we added the runtime total extension to our hot water pump 2 or hot water pump 1 control, and now we actually want to set it up. So I said there's two ways of doing it. I'll go ahead and just show you the other way. So if we really wanted to, we'd go to the property sheet of our hot water pump, and we can see our runtime total extension that we've added here. So you can assume that we can drag this discrete totalizer extension to an empty spot within our property sheet, and it'll let us add it. The problem is some points or modules have a large list of properties, and finding an empty space within the property sheet to drag it onto can be quite difficult sometimes. I believe you can also drag it onto the name at the top of the property sheet, but the quickest and easiest way to do it, at least in my opinion, is to just drag any type of extension that you're adding onto the point within the nav tree itself. But after we've added the extension, we want to go to its property because we want to change a few things. We want to set the extension up to act in the manner that we need it to function. So I'm going to click this runtime total within the property sheet. I could do the same thing if I expanded hot water pump one control, we can see this runtime total extension added to the point. And now something to note here, if we're all looking at our hot water pump 1 control point in the nav tree, notice when I expanded it, there is also an extension on there called proxy extension. What that means is this point is a proxy point and it is extendable. So most points have this. Most points can be extended. If you're ever in question whether or not a point is extendable or not, that can take extensions, it has to have this proxy extension already added to it. It's there by default. So when you see the proxy extension, you know that that point is extendable, and you can add further extensions to it, if that doesn't confuse you. But most points are extendable, so it's just a little for your information there. So back to our runtime total. We have at the top, we have the change of state count transition. When it's currently set to both, it's going to make it's going to keep track of when it changes states from either on or off, or active to inactive. But that's not what we want to do. We actually want to just keep track of when it cuts on. So we actually want to drop this down and switch it to active. So we want to count when the pump goes to active. We don't want it to count when it goes off, or when it goes active, and then when it goes back to inactive. We just want it to count the times the pump cuts on. So we're going to change the change of state count transition to active. Catch up to where I am on lab. Okay, I believe that's the only thing that we're actually changing in here. All right, sorry about that. I was discussing something with Damon. He brought up a good point. So if you look here within the extension, and this is going to be something to keep in mind for Friday, we see that we have an elapsed active time and elapsed active time numeric. Now, there's a key difference between the two. Now, fundamentally, they're used for the same purpose. But so elapsed active time numeric is actually milliseconds. So it's counted or read in milliseconds, where elapsed active time is broken down into hours, minutes, and seconds. And we're going to have, I believe, we're going to have a show that the time count on the point itself within the logic. And what we want to make sure that we expose is the elapsed active time, because we want to see that number in hours, minutes, and seconds, not in milliseconds. But when, if this point or extension is used for any sort of math calculations, the software uses the elapsed active time numeric. It calculates that in milliseconds. So we'll see that in just a second, but keep that in mind. We want to use elapsed active time, and you'll see in just a second, and a few seconds why. All right, so we've got this set up. We've set the count transition to active. We already have this extension set up. Now we can actually just copy and paste this extension that we've created onto pump 2 control. So we don't need to add discrete totalizer extension from the palette back up to the other pump and do all this setup. We can actually just copy and paste this onto our hot water pump 2 control. And if we go into its property sheet, which it did change over, we can see that the setup is exactly the same as we have set up for pump 1. So now that we have that good to go, so now we have an extension that's going to keep track of any time the pumps transition to on, and we're going to keep account of that. We go back to our wire sheet. So just like an internet browser, you can just keep hitting that back button, get to where you previously were. So the next step we're going to take is it's called Composite Editor. And the Composite Editor is how we can expose slots from our extensions. So we have pin slots, which expose slots within a given point. And then we have a Composite Editor, which allows us to expose slots within extensions of a point. So there's a difference there. And it's going to be kind of hard for some, it's going to be hard to remember the difference between the two until you actually go through the process of doing it. So we want to expose a couple of the slots from our runtime extension. We want to show, the current active count of how many times the pumps have gone on. And that's where I brought up the elapsed active time versus the elapsed active time numeric. We just want to expose the elapsed active time. So we'll click on a point, just like we did with pin slots, but we're going to go to the composite editor. So click on a point, the pump point, right click it, and towards the bottom, we have the option for composite. Now, when we do that, we need to expand the window a little bit so we can see everything. Composite editor looks like this, and if we expand our hot water pump one control, we can see our two extensions. This one's here by default. It doesn't actually do anything other than let us know that it is extendable. It does have some properties here, but we're not using those. We're actually looking for the runtime total. That's the discrete totalizer extension that we added. And we are looking for two slots that we want to expose, two properties within the extension. And those two are the elapsed active time and so elapsed active time here. And what's the last one? And reset elapsed active time. So we're looking for these two here. Now, it's easy to, you'll be doing this again on the test on Friday, where you're going to add this exact discrete runtime or discrete totalizer extension, and we're going to use it for runtime on the test. And we're going to have you expose these two slots using the composite editor. And keep in mind that we want to use the elapsed active time, not the elapsed active time numeric. If you pick elapsed active time numeric, it's the wrong slot. It's going to show the count in milliseconds. That's not what we want. We want to show in just the elapsed active time so we can see hours, minutes, and seconds. So once we've done that, we don't want to press OK just yet. We've had them selected, but we actually need to add these two slots. Once we've done that, once we've added these to this window over here, we can actually rename them something more recognizable when we're looking at the points, the slots on the point within the wire sheet. So we have the elapsed active time. Let's select that. That's at the top here. And we can, once we have it highlighted within this window here, we can hit rename. And we're actually going to rename elapsed active time to just runtime. So at a glance, when we look at it on the point and the collection of hours, minutes, and seconds, we can see that this is the runtime collection for that pump. So we're going to set that to runtime. Then we're going to select the next slot just under there, which is the reset elapsed active time. We're going to rename that to reset runtime. Select OK. And we're going to press OK after that. And then we can see that our runtime and our reset runtime slots from our extension are now exposed onto the point within the wire sheet. So when this runtime actually increases, that count will actually reflect here within the runtime. So we need to do the same thing for hot water pump 2 control. So we'll right click it, go to composite, expand the point. So this is where I said you need to probably readjust the size of the window so you can see everything. We're selecting the elapsed active time and the reset elapsed active time. We're going to hit the add button. This is important because it's easy to select these and hit OK thinking we've added them, but we haven't. We need to select them and then hit the add button. And then we can come in, select the lapse active time, rename it to runtime, just like we did for pump 1. Select the reset, select it, hit rename, change that to reset runtime. Press OK. We can see those points exposed, or those slots exposed now. So now our logic will, when the calendar schedule, or when the schedule has deemed, once the cut the pumps on, based on the time and date slots that we've set up, it's going to send that command over to our pump lead lag object. And based off of when the last pump had ran, or the highest run count on a pump, it will determine which pump will be cut on next. So it does a comparison. And this, the extension helps keep track of the runtime, and the status here is kind of our feedback and lets us know which pump is currently actually running. But our freeze protection logic that we had set up here is still in play for our pumps, and it actually overrides all this logic that we had written down here for the pump based off schedule. So that's lab, I believe it was lab 6, and that was the last of the hot water pump logic. Before we jump into the boiler control logic, last lab that you guys did for last night. Does anybody have any questions about lab 6?
Yes, I have a question. In fact, it's maybe it's something that I did wrong. If you can look at mine, um, the hot water pump control 2, number 14. In the runtime, I have it exposed on both ends, left and right. I was trying to connect it to the pump lead lag,
Oh,
but it gave me those things showing that it's exposed. It's not forming the line.
right. So that's completely normal. So I'm assuming you're talking about these little nodes here.
Yeah, on the for the hot water pump 2 control, runtime, on the runtime. So the runtime has that exposed slot on the left hand side. So if you connect on the right hand side, connect it back to the pump lead lag, runtime B, right? It doesn't form a line. It doesn't construct a line.
Oh, I missed a step. So I see what you're saying here. This is what I get for doing it out of memory, right? So yeah, I actually needed to, and I see what you're saying. So I'm gonna go ahead and do this step, and maybe this will make it a little bit more clear, and I'll explain it. So the runtime out of pump 1, I'm gonna drag over here, and I kind of have to do like a big old U-turn out here to connect it to runtime A. And if I go from runtime for water pump 2 and bring it to runtime B, there's a good chance that it's going to just create a node. So
Yes, exactly.
it's still making a link. So everything's perfectly normal. Everything's fine. It's still making a link. It just doesn't have a path, a clear path to write a line from one slot to the other slot. But if you ever want to check and see the connection, there's 2 things you can do. If it's a connection within a block, within the same wire sheet, you can select it and it'll highlight red, and you can see where it's connected to. It's also highlighted in red. Let's see if I can zoom in on that. So we can see that both nodes are highlighted red. Now, if I make a link to an object in another wire sheet, we'd also get this sort of node. And what we can do with that is, let's say I have, and we did this in the next lab where we made a link mark from our pump schedule to our boilers, and it also created that little node there. if we were to, and we'll see that more, and I'll do it when we get to that point as well. But if we ever want to double click on that node, if it's linked somewhere else in another wire sheet, it'll actually take us to that object it's linked to, with that node also being highlighted. So it'll jump us to another wire sheet and it'll show what it's linked to. So it's perfectly normal. It's fine if it just doesn't have a clear path. Now, if you wanted to, you could rearrange all these things, take your time and rearrange all these object blocks to find where it can find a clear path, and it will write that line. It'll draw the line for the link, but it's not necessary. You can confirm that the link is actually made by seeing these two dots or these nodes highlighted when you click it. But yeah, thanks for bringing that up. That was a good point.
Okay, thank you. Thanks.
I've got a really quick question in regards to the lead lag portion.
Sure.
What parameter inside there? So from what I'm looking at, it looks like this thing is going to change lead lag every 5 minutes. So how does it know, like, when you're going to change it weekly, monthly, or each time you cycle? Where in there can you see that parameter that'll tell you that information in the property sheet? Does that question make sense?
Yeah, and this might be a better question for Damon. Do you understand the question, Damon?
There we go. Hey, wait, am I unmuted now?
Yeah.
Good. Okay. Yeah. Sometimes I have a button on my headset and a button on the screen, and they get out of sync. Yeah. What it does, and I don't know for sure. I haven't actually run it through its exact paces. So what it does is every time that it starts, it says, I need to start in this case, I need to start a pump. Let me look at the runtime of each pump, and whichever one has the least amount of runtime, I'll start that one first. Okay. Now, because we're getting feedback, the pump status gives feedback. If that one fails, then it says with the lead one, then it start the other one. Now, as far as if it's running, let's say that it's run for a while, the property max runtime, I think
What
it's max runtime is the one that says once it's run this amount of time to try
switch?
because you could have the lead pump start and run for days. So you
Right.
might go,
Okay.
well, I don't want to run for days. How about let's say if it runs for 4 hours, then rotate to the other guy, so to speak. I'm
Got
pretty
it.
sure that's the way it does it. But I tell
That
you,
makes
Brandon,
sense. Yeah.
this might be a good time if you want to show them how to find help. Drop down help and search for help. Might be a good time to how do I find more help on this thing? So
Right. And this is when
you might be a good opportunity for that one.
we would come to the help document here.
Yeah, it'd be a good opportunity for that.
And you can have a guide on target. So let's say we need to select our pump lead lag, right? So we want to make sure that we have something like this selected. I believe this is the way that works, right, Damon? Or you have the item selected, and then you go load help. So with that lead lag object selected within our nav tree, and we went up to help and selected help guide on target. So it's saying, hey, go to the help document, but pull up anything you can find, or pull up something that has to do with the item that I have selected here. So we can see that the kit control lead lag runtime objects, we can scroll through here and get a better understanding of what each property does. And if it has anything related links to it, it'll be down here. I see there's not a whole lot of information on this one.
Actually, it's perfect. If you scroll down, it says max runtime, and that's the exact explanation that Damon gave. So that's perfect. Thank
There
you.
we go.
So I got it right. All right. It's funny, sometimes when you're teaching, sometimes there are certain properties objects you look at and you say, well, I'm pretty sure it does this. You never actually follow up to say it actually does do this. So I'm glad that they did show it. But real quickly, the load help button, it's a little mystery what that is. Basically, Niagara is made of modules. You hear what are called jar files, and each jar there's a jar file for everything you do. One for BACnet, graphics, lawn, drivers, blah 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 blah. Each module has its own package of help documentation. So what we do in Niagara is that when you first open up help, if that help documentation hasn't been unpacked yet, you hit load help and it goes through all the modules and makes a virtual help document. And that way, we don't have a single help document. We have a virtual one, and it's based on the modules you have loaded. So it's always you always have the help document available to you in Niagara. But that's what load help means. Load help basically means the help's available, but we haven't unpacked it from the modules yet. You unpack it, and then you got your own virtual help document.
Yeah, so as we've seen firsthand, the help documentation is actually pretty handy. So if you ever have a question, that was a perfect example. You can find a lot of your answers within the help documentation. All right. Any other questions about Lab 6? Key takeaway there
About,
was go ahead.
about the help on guide, did you, because it took you to the lead lag, did you
Right.
use the palette, the discrete totalizer, and then you hit
No,
every
so it's the on target's gonna go. It's gonna look for the last object or item that you selected. So we can see that I've got 2 items selected here: the discrete totalizer extension and let's say the holiday.
Yeah.
It's going to guide on target the most recent object or item that you've selected. It's whatever's in the locator bar here. So, for example, having TSTAT, we'll look at TSTAT and we'll go up to help and guide on target, and it should pop up kick. And now it says the kick control because this item originates from a palette, so that's why it's showing the kick control portion in its title here. But you can also see that we have the discrete totalizer extension highlighted in the palette right now, and so that's why it. But if we wanted to look up something in a palette, we can do that as well. You know, double click on the discrete totalizer extension, we go up to help, guide on target, and it'll load up help documentation on that. So it's whatever you're currently looking at. Very handy. So the big takeaway from Lab 6 is adding the discrete totalizer extension. I believe you'll do a similar setup come Friday to this. Not this extensive, but something similar, where you'll have something like a lead lag and you'll have a discrete runtime extension, or discrete totalizer extension added to a point and using the composite function to expose it and renaming it and so forth. Those last couple steps that we just did. You'll see that on Friday. Okay, so that was, if nobody has any questions about the heat pumps logic, we're going to jump into the boiler logic, and then we're going to take a little break and then jump into the next portion of the class. So the boiler logic is pretty simple. Again, this is just another rundown of some basic logic here. I believe we don't even use the return sensor, so we'll just get that out of the way for now. All right, so lab 7. So task 1 in lab 7 is we need to pin some slots for our boiler controls. So remember how we did that? That's easy. So we select our boiler controls one at a time, right click it, go down to pin slots. Now this is all the slots that are available for this point. And something to bring up, not that it has anything necessarily to do with the class or anything you need to know for the test, but it is possible to make links to slots that are not currently exposed within a point. To do that, you would have to do the link mark action. And if you got through lab 7, you'll have briefly seen how to do a link mark between 2 objects. And that's what we did between the schedule from the pump schedule and the other wire sheet and linked it over to our boiler control. So that's possible to do that between 2 different points without actually having to expose the slots. But for this class, we require you to expose the slots so that we can actually see the work being done, particularly for the test. because if you make a link mark on slots that are not exposed, and while I'm grading the test, if I don't actually physically see the slots being linked, might not necessarily know that's there. I might assume that you didn't make the link. So for this class, we require you to actually pen the slots out that we're going to be using. So much like we did with the pump controls, we're just going to pin the slots of 5 and auto. And this is just going through the steps of actually showing you, going through the process of pinning these slots out. I don't think we actually really going to use the auto slot or anything like that, but for the lab, but we're going through the process of just pinning out some slots, going through the paces. So I'm going to just expand these just a little bit. All right. So I've pinned out the slots of in slot 5 and auto on both my boiler controls. And then I need to go down to my kit control palette. I'm going to look for my HVAC folder or my HVAC folder. And what I'm going to be looking for is a loop point. So I found my loop point in the HVAC folder. I'm going to drag that into my wire sheet, empty space in my wire sheet. And I'm going to name this guy boiler control. Expand it a little bit, keep uniform with the sizes of the other points that I have in here. All right, so now that I have this in my wire sheet, I actually need to do some setup. So I need to go to its property sheet. We can do that by double-clicking the boiler control object within the wire sheet itself. And then here there's a few things that we need to change. The first being the facets. And this one's actually going to be a percent. So what we need to do here is hit the double chevrons because we haven't set that one up yet, or at least I haven't set it up yet. So I need to click double chevrons and then click on the ellipsis button, which is these 3 little dots right here, the top left of my screen. Now, the percent sign, I believe, is contained within, yes, within the miscellaneous category of our engineering units. So I go ahead and select that. So there's this facets here, and then we have what's called an input facets. And this is like the only instance I think that we see that we have 2 separate facets for within the labs that we're doing here. So this one is actually going to be the input facets is going to be degrees Fahrenheit. Now we know we've done that one, so we'll hit this facet recall button or the facet history button here, and next to the input facets, and we're going to select our degrees Fahrenheit. We need to change the loop action to reverse, so we're going to find that loop action. So just kind of scroll through here. It's about halfway down the screen. It's currently set to direct. We actually want to set that to reverse. So a rise in input causes the output to decrease. Then we need to look for our proportional constant and change that to 5. There's a proportional constant. We'll change that to 5. Look for a bias. We'll change that from 0 to 50. And change our ramp time to 1 minute. Now, again, this is what I like to point out. There's some good information within the lab books itself if you take a little bit of time to just read it. So if any of you are, wondering why exactly we're changing these different properties, we have written in parentheses next to each property that we adjusted why, as a brief description of why. So for example, the facets, with the percent sign, it defines the facets to identify the output signal out slot. Loop action reverse is, we're saying that a rise in input causes the output to decrease. We're changing the proportional constant to 5. It's a ratio of output over input. Now, this might not necessarily make sense to you, but as we kind of put this logic together, be able to better explain why or how these properties come into play here. Set the bias to 50. It's an output value when input control variable set point match. And then the ramp time maximum speed output can increase the minimum output to the maximum output when loop point is first enabled. So all that was confusing to you, it might make a little bit more sense when we start putting these building blocks together. It's the same as when we set up like the tstat object or the lead lag logic together. It starts to make more sense as the building blocks come into play here. So we have our boiler control object here. We've got that all set up. We're gonna hit the save button, and then we need to, I believe, pin open some slots on the boiler control because we have a bunch of properties that we just changed and enabled that we want to use, and we actually want to see that on our point now. So to do that, just like we've done many times before so far, we'll right-click our point, come down to pin slots, and we get to this very familiar window. We're going to look for a few things to pin out. So the first one being loop enable. It's the third option from the top of the list here, and we'll just go down the list and select the slots that we need to pin. So we got loop enable, controlled variable, set point, loop action. We're going to pin out the bias, and then we're going to look for maximum output and minimum output. Select those two towards the bottom. Select OK. Again, useful information within the lab exercise book. There's some blue text just under there explaining the reason to pin slots is to make them visible on the wire sheet. In some cases, you expose them to make it easier to link in. In some cases, you expose them to show information of an object for convenience. So not only do we pin slots just to make it convenient to make links within our logic between different points, but we can also use it as a means to see information within the point. So, for example, if we wanted to see what the loop action was, or the bias, or what we have the maximum output or minimum output set to, instead of having to double click into the loop point to see that information in the property sheet, we can see it firsthand just within the point itself within the wire sheet. So with the boiler control loop point object set up, we want to add hot water temperature set point. So we just need to create a numeric writable for this. So to create a new numeric writable, if you remember from the previous labs, all we need to do is right-click an empty space within the wire sheet, hover over new, and then come down over to numeric writable. So we're creating a new numeric writable just by right-clicking within the wire sheet. Pretty simple, right? And when we do that, it's going to prompt us to name it. And we're just going to name this guy hot water temp HWT underscore set point. So with that created, I'm going to adjust the size of it just for uniformity here. And so we have a set point object here, but we need to actually set the set point up. So we'll double click our set point, and we're going to set the fastest degrees Fahrenheit, but we're also going to set a min and a max value. Now remember yesterday I had mentioned that there is this min and max value available to us when setting up a degrees or some facets, most notably degrees Fahrenheit or Celsius. So we have a min and max value. By default, it's set to minus infinity, plus infinity. If it's a point that we've scanned in from an actual live controller, this min and max value might be set to an actual value by default, and sometimes it's wild numbers like negative 1,000 something to positive 20,000, something completely random. It's whatever was put into the controller itself by default, but we can adjust those here within the by default when we're creating new points within Workbench. The default values will be minus infinity, plus infinity, but we have the option to change that min and max value to within especially for set points, within a working range. So what this does is it limits how far this limits within a range that the user can actually adjust the set point. So that's what we're doing here. So we're setting the minimum value to 100 and the maximum value to 200. So that means that a user will not be able to change the set point outside of this range of 100 to 200. And again, the little bit of information there is in more detail in some blue text in the lab exercise book. So setting the minimax value and degrees Fahrenheit for its facets, we're just going to hit save. We're going to come back out to our sheet. We need to set a fallback value for our set point. So if we remember how to do that, we'll right click our set point, go to actions, go to set. So we're setting the default or the fallback value. And we want to set this to 165 degrees. And we can see that change in the out slot of our hot water set point. Now, if you wanted to, now we've done pen slots for availability of information and for making links. So if we really wanted to, and I can't remember if we actually do it in the lab, but this is something good to have because I know we asked you to do it in the test. If you want to go to pin the fallback of any point, you can do that as well. So I went ahead and did a pen slot for a hot water temperature set point, and I did pen slots. I came down and found the fallback. So selecting this, I can now actually see the fallback value or the default value of this set point that I created now at a glance, just looking at the point in the wire sheet. And I believe we asked you to do this as well on Friday. So any given slot can be penned for various reasons, whether you want to make a link or information that you want to see. So we have set the default or fallback value for the set point. Now we need to make one more numeric writable, and this is going to be our hot water supply temp. So right click empty space within the wire sheet, come down to numeric writable, and we're going to name this guy HWSTEMP, so hot water supply temp. So we're going to go to the property sheets, and we're going to change it to degrees Fahrenheit for its facet. But remember, we don't want to use, for this instance, we do not want to use a min and max value. We want to set it to the degrees Fahrenheit with the minus infinity plus infinity. We don't want to give it a min and max value. Or save. Majority of the time, if you're ever going to be setting a facet with some sort of range, it's going to be something that has to do with being a set point, usually. When you're limiting the the range. All right, so we're going to make a few some links here now that we got some building blocks available to us. So we're going to go from our boiler supply temp sensor, which is up here at the top, and we're going to tie that into our hot water supply temp numeric writable that we just created. As you can imagine, we're going to do something very similar like we did with the hot water pump logic, where we create a simulated object, and we're going to tie both a faulty sensor and a simulated object into our hot water supply temp, or our our block here. So we've made a connection between the sensor to the hot water supply temp, and then from the hot water supply temp out, we're going to connect it to the control variable of the boiler control here. So it's going to do something similar like we've done in the previous labs, where we're going to have we're going to compare two values, and that's going to determine what our boiler control object does, or what our boilers do. So from our set point, we're going to link that to our set point slot of our boiler control. We can see the changes taking effect here. Move these just to make it a little bit more clear. It can be a little confusing when the lines or the links get kind of crossed. All right, so we've got this set up. There's a few more steps that we need to take to have this work in the in the way that we want it to. So from our kit control palette, we're going back to our kit control palette here. And we're going to stay in our HVAC folder, but we're going to look for something called a sequence linear. We're going to drag and drop the sequence linear into our wire sheet, and we're going to use this to stage the boilers. We're going to call this boiler staging. Expand this. Now that we've added this, we need to go into our sequence linear, set up a few things. I know that we're going to set the units to degrees Fahrenheit. We're going to go to the number of outputs. It's currently set to 3, but we only need 2. We're going to set the delay to 10 minutes. It's currently set to 1 second. So we're going to make sure that we zero out that second mark. But looking at the lab here, we're going to go ahead and set this to 30 seconds for testing purposes so that we can actually see a change while we're going through this review. And then we want to set the rotate time to 1 hour. Click save. Okay, so now that we have that, we're going to pin a few slots on the boiler staging. Goodness. Same old song and dance we've been doing for the last few labs. It's kind of repetition, teach you how to do it, see it multiple times, it kind of sinks in after a while, right? So we are going to pin out the min and the max. We're going to pin out delay, action, and rotate time down here towards the bottom. With that, we're going to make a few more. That's it. We're going to make a few more links to kind of wrap this up. So we're going to go from the boiler control out, we're going to go to the boiler staging in. Just like that. And then boiler staging out A. It's going to go up to in slot 5 on boiler 1 control. And out B, it's going to go down to in slot 5 of boiler 2 control. So similarly, it's a similar setup as we have like our pump control, but with some differences here. So instead of determining which pump will cut on based off of runtime and stuff in similar fashion, we're actually going to have our boilers stage on based off of demand. So for example, if we have our hot water temperature set point set to 165, depending on how low our current hot water supply temperature is, will determine whether 1 boiler comes on or 2 boiler cuts on. And this is where the logic between the boiler control and the staging start to interact. So it'll do a comparison, and this is what will determine whether 1 boiler is needed to heat the water or 2 boilers are needed to heat the water. And I'll give a better example here in just a second. Once I add after I add the simulated object here. So like the ramp object, we're actually going to add a sine wave object. It's used in a similar manner. So we are going to, from the kit control palette, open the util folder. We're going to find the sine wave. We're going to add it, and we're going to name this hot water temp simulator. Or hot water HWT_sim. Drag this up towards the top of the screen, make it a little wider. And we need to go to its property sheet because we need to change its amplitude and offset. So we need to change the offset to 160. You need to change the amplitude to 25 over a period of 2 minutes. Change the fastest degrees Fahrenheit without the minimax value set. And then we're going to leave the interval to 1 second. So remember, if you need to reflect back to how we got the amplitude and offset, to get the amplitude. Remember, it's the maximum value minus the minimum value, and then divide that by 2. And then we take the amplitude and add it to the minimum value, and that'll give us our offset. And that is located on lab 4 for your reference, and you'll need that on Friday, remember. Okay, so we got this all set up. So we're gonna hit save. We're gonna go back. We're gonna link our out from our hot water supply sim into inslot 16 for hot water temp, and now we can actually see some numbers changing here. And then we want to actually make a link mark to our pump schedule. So in order to do that, there's 2 ways we can do this. We can either go back to the wire sheet for our heat pump IO and right click on the pump schedule itself, or I can go into my nav tree here. It acts in a similar manner. I can select my pump schedule just from my nav tree. I can right click it and I can select link mark. Right. And then I can come over to my boiler control, right click my boiler control, and I can select link mark from the pump schedule. So from here, what I want to select is I want to select the out slot for my pump schedule, and I want to select my loop enable on my boiler control. So the pump schedule will control when the loop is enabled for the boiler control. So to kind of better explain how a loop works and how it the sequence linear kind of operates to stage the boiler. We like to use the comparison or the analogy of or the comparison of a what's it called? What's it called? I'm drawing a blank. You're not even paying attention. Cruise control on a car. Yeah. Yeah. Cruise control. So if you ever set a cruise control in the interstate, right? You set it to, let's say, 70 miles per hour. And so what that's doing is it's gonna compare your current speed to what you set your cruise control to. So your cruise control set is your set point. So we set our cruise control to 70 miles per hour. So that's our set point. And then whatever our current miles per hour is on the speedometer is our control variable. So think of that as kind of like our hot water supply temp here, right? So our cruise control, well, is similar to our boiler control and our staging here, or loop. So as long as we, well, if we fall below our 70 mile per hour set point on our cruise control, the accelerator will kick in and will speed us back up to get back to that 70 mile per hour set point that we have set for cruise control. Now, how far away we are from 70 miles per hour will dictate how much acceleration the cruise control puts on the car. So it's if set point is 70 miles per hour and we're going up a hill and say our speed drops to 60, we're going to need more acceleration to get back up to that 70 mile per hour set point. So the same thing can be said for our hot water loop point here. So the further our temperature, our hot water supply temperature falls away from set point, will dictate whether or not we need both boilers or just one boiler to heat up more water to bring it back up to that set point. And the same thing can be said referring back to our cruise control. If we go above our set point of 70 miles per hour, the cruise control will let off the acceleration, so zero acceleration, and will wait for it to slow back down to come back to our 70 mile per hour set point. Same thing can be said for our boiler control. So if we go above our 165 degree water temperature set point, both boilers are cut off, it'll let it even itself out or cool itself down, back down toward the 165-degree set point. So that's, in a sense, how that loop works or operates.
Can you demonstrate that one more time? Because I think I lost myself there.
Sure.
I was trying to do the one where you click on it and do the mark, not off of the um, heating,
hmm
and yours is a little bit easier. So if you could do that again.
Sure. So just like the comparison to how the loop works.
No, the way you move the pump schedule
Oh, yeah,
and
yeah,
you
of
did
course.
the link mark.
So there's two ways we can do this. In our nav tree is probably the easiest way, so we don't have to change our view window. If you right-click your pump schedule, so open up your key pump IO point folder in the nav tree, so where you see the pump schedule. Right-click your pump schedule and select link mark. So we're wanting to link this to something else. Okay. Once we've done that, we've link marked it. Then we're going to go to our boiler control within our boiler control IO wire sheet. The same thing can be done if I wanted to right-click on the boiler control within the nav tree and do the link mark from the pump schedule, but this is just as easy. Right-click my boiler control and select link mark from pump schedule. And when I do that, it'll pop this window up, and I'm selecting which slots from the pump I want to link to the slot and the boiler control that I want to link. So for this example, it was the out slot from the pump schedule, and we're going to link that to the loop action or loop enable. So mine's not going to show up because it's already connected. We're going to select the loop enable slot on our pump control or our boiler control. So it's making a link just like we did in the wire sheets from the pump schedule all the way to the boiler control. But since it's in separate wire sheets, we get this little node here. And if we double click that node, it'll actually take us to the boiler or the hot water pump control wire sheet. And we can see on the pump schedule, this node is actually highlighted over here. So it'll take us to where it's linked to. Make sense?
Yeah, it makes sense.
All right, cool. All right. Does anybody have any questions about Lab 7? Okay. The key takeaway here is all right, so the key takeaway here is using the loop. I think, hold on a second. Yeah, so the key takeaway here is the loop object here, the loop point. You'll be using that on the test to compare two values. Whether you're going to look at a control variable, which is something like a temperature, versus a set point, and it'll change an object. So key takeaway about the loop point is it's going to compare two values and it's going to output something based on the comparison between the two. So, all right. So if nobody has any further questions about 7,
We need the tag on that one, or I didn't actually add it on mine. On I guess the lab it says D. You're adding a hay tag, or haystack tag. Are we doing that or no?
we haven't been, but yeah, we should probably go ahead and add that tag because I know we need the set point tag. So if you haven't already, go to your hot water, go to your supply. I'm sorry, go to your set point block and add the set point tag to your hot water temperature set point, and go ahead and go to your pump freeze set point within heat pump IO and set the set point tag to that as well. And then once you've done that, go ahead and we're going to take a 15-minute break. So yeah, we're just going to round up. So we'll be back here at 11:15. So go ahead and add those set point tags to both your set points and both logics wire sheets, and then go ahead and take a 15-minute break. We'll be back here at 15 past the hour. All right, everybody. Hopefully everybody is back. So we've looked at some logic. The next thing that we're going to hop into is look at another integration type. So we've integrated BACnet. We added a BACnet over IP device, which is our chiller, and we added an BACnet over MSTP port, and we created 2 offline devices for our MSTP network, being the hot water pump system and our boiler. The next integration that we're going to look at, and it's much simpler. The next 2 are much simpler. The first one we're going to do is Modbus. So, and depending on where you're from or what kind of industry you tend to work in, you may or may not see Modbus at all, or might not see it very frequently, or you might work with it all the time. That tends to be the way the ratio that I've seen based off of the students that we've had come through the class. I've made the mistake of saying that you'll hardly ever see this, and I've had some students come through that do a lot of industrial work. They say they see it all the time. So I've corrected my statement in saying that you'll either rarely see it or not at all, or see it all the time. That's kind of been the poll there. So Modbus, it's an easy integration to the Niagara system. And just in the way that we added the BACnet system or network to our driver by dragging and dropping a network from our pallet into our driver under our station, that's what we're going to be doing here. One of the key things here is we do not need to set up the network at all. We simply add the network to the driver, and it's ready to go out of the box. Now, Modbus works in a little bit of a different fashion, whereas we actually don't have the option to discover Modbus devices. We actually have to create the devices, give these devices a unique address that actually matches a device out in the field. So we have to be specific with our addressing. It has to actually match the addressing and the addressing type. So that's another thing about Modbus, without getting too deep into it, is there's also unique addressing types within Modbus, whether it be decimal or hexadecimal, what have you. If any of that makes sense to you, then you've obviously worked with Modbus before. If it doesn't, just know that we just need to provide a specific addressing scheme for the devices that we have to create to match up with devices that are out in the field. So for those of you who feel confident with doing this integration lab 8 on your own, feel free to do so. Just listen along. For those of you who want to do it along with me, we're going to do it step by step. So the first thing we need to do is actually open up or find our Modbus TCP network. So we need to find that within our palette window. So let's go ahead and hit that open palette button, that folder icon at the top left of our palette window here. So we get this open palette window with the filter option at the top. And what we're going to be looking for is called the Modbus TCP. So Modbus is actually lowercase. So we can just type in Modbus, and we see that we have several different versions or several different Modbus drivers, depending on what you're using. What we're looking for is the Modbus TCP. So when you found the Modbus TCP driver within the palette window here, just select OK. And what we're looking for is, in that folder, is the Modbus TCP network. Should be the top option for you at the top of your palette. And just like we've done with the BACnet, it's pretty simple adding the Modbus TCP network. All we have to do is drag our Modbus TCP network that's located in our palette, and we need to drag and drop it onto our drivers under our station. And we have to make sure that we actually drop it on the name drivers. Remember, we can't drop it onto an empty space within the nav tray. So let's go ahead and do that. Let's go ahead and grab our Modbus TCP network from our palette and drag and drop it all the way up onto our drivers. So if you don't have it opened up this far already, go ahead and do that now. So open up your station, expand config, which is already be expand drivers, and this is where we find our Niagara network, our BACnet network, and soon to be our Modbus network, Modbus TCP network. And once you have your drivers expanded, you go ahead and go down to your palette window and drag that Modbus TCP network up to your drivers. And really, that's all it takes to add or integrate a Modbus network into your system. Now, obviously, we need to create devices to match up with real field devices. So we're going to simulate that here. So the default view to Modbus TCP network is the same as our BACnet network default view, which is our device manager view. This is where, for Modbus at least, we can create our Modbus devices. And similarly, if we needed to, we could make a points folder, or that's the points manager. I'm getting ahead of myself. So at the bottom of our device manager, once you've added your Modbus TCP network to drivers under your station, double click your Modbus TCP network to get to the Modbus TCP device manager view. Once we've gone there, then we're going to go and create the new device. So we've seen how to do this with the BACnet MSTP. We created an offline device. That was our MSTP heating system. We're going to be creating a device in a similar fashion, but it's going to be a completely different setup. So you'll see when we hit the new button, we're going to get a different looking window. So let's hit that new button at the bottom of our screen. And the new window that pops up, it asks the type that we want to add, the number of devices we want to add, and what the starting address we want to add. So we can add multiple devices, multiple Modbus devices at one time. So since we have to create our Modbus devices, we can't scan them in. We can add up to 100 or 255 devices at one time. Not that you would necessarily want to do that in one go, but you can. So we can add multiple devices at one time, and we can actually declare what we want the starting address to be of these devices. And it would if we're creating more than one device at one time. So let's just say we're creating 4 devices, right? And I want the starting address to be 2. So the first device that we're creating, it'll have the address of 2. And the next device out of the 4 that we're creating is going to have an address of 3. And so on. So we're declaring what we want the starting address to be. And if we're making creating more than one device, sequentially, it'll increase in the numeric number for the address. So we're just creating one though. We're creating one device, and it's going to be a Modbus TCP device. And we're going to have the starting address be 1. So we'll press OK. And this window should look similar to what we've worked with before. So the first thing, the top of the list here, we're going to change the name from Modbus TCP device 1, and we're actually going to name this power meter. So PWR METER 01. So power meter 1. And there's only a few things that we need to actually check here. So we need to change the name, and then we just need to confirm, input the IP address for this device. Now, in the instructions to say this may vary, check with the instructor, but I can tell you that we're all going to be using this IP address, so scroll down into your window if you need to scroll towards the bottom, second to last option, your IP address for the power meter that we're adding. The IP address is 10.10.11.28. So at the bottom of our new device screen here, after you've changed the name to power meter 1, go down towards the bottom of the screen, second to last option, IP address, and input 10.10.11.28. And this would be the predetermined IP address for the device that we're trying to match up with. Once you have that, let's go ahead and press OK, and then we can add proxy points to it. So it should show up in your database now. So if we were to double click on this power meter device that's in our database, it will actually take us to the point manager view of the device that we just created. So let's double click. Actually, I was wrong. And we need to double click the power meter in the nav tree because this takes us to its property sheet. So actually, we need to double click the power meter under the Modbus TCP network. And I'm just leading you astray today, aren't I? So actually, we need to expand the power meter device. This is what I get for not reading instructions. So we need to expand the power meter device that we created. So we got to expand Modbus TCP network, expand power meter device. We're going to find that points module that we all know so well by now. And we're going to double click the points module, and that'll take us to the points manager. And just like we've done with the other devices that we've created, we're going to make a points folder for it. Now remember, this is not required for you out in the real world or in the field. If you don't want to, you can actually add or discover all your points in the points module if you wish. But in this class, we require that you use a points folder just to keep things clean, and we know where to look, especially for test day. So to do that, we need to be in the points manager first. And while we're in the points manager first, we actually need to hit this new folder button in the points manager. We can't right click make folder because that will make a normal folder. It's not what we want. We want a points folder. So we have to do that within the points manager view. So we'll click that new folder button. It's going to ask what we want to name it. And we're going to have a simple name here. We're just going to name it control. So now that we have our control points folder created under the points module, now we can double click the control points folder within the database. Or we can double click the control points folder in our nav tree. Either one will take us to the points manager for our control points folder. We want to make sure that that's where we're actually working in because we want to add these points to our point folder that we just created. Now, if you ever make a mistake and add the points to the points module outside of the points folder, it is possible to either copy and paste them into your points folder or actually Control X, cut the points and paste them into your points folder so you don't have to recreate them. If anybody stumbles across that, accidentally adds points in the points module instead of the folder. So we made the new folder. We're working within the new points folder called control, and this time we're gonna shake things up, and we're actually gonna throw the tags on these guys because we're actually on time today. We're not having to rush through and get to logic. So we're actually going to follow the lab instructions here, and we're going to go into tag mode because the 4 or 5 points that we're about to add all have very similar taggings, -1 tag. So we will have to go back through and edit tag for each one and add an additional tag to each of them. But they have 3 tags in common, and so this is where it is handy to go into tag mode when you know all a group of points have similar tags. You can knock those out fairly quickly. So I'm going to go ahead and hit tag mode, so which is that tag button in the toolbar section at the top of our screen here. We're going to select that tag icon. So that's going to put us in tag mode. When we're going to manually add tags, we want to make sure that we're working in the correct dictionary. So I know that we're going to be working in the haystack tag dictionary. So in the drop-down menu on the top of our screen here in tag mode, I need to change it from Niagara to haystack. And then on the right drop-down box, I need to change it from best only to show all. To get into it a little bit more, when we get to the tagging lab, when you're filtering through tags, best all, the tagging dictionary, when you're trying to add tags, it tries to filter out best related tags. So it'll try to show you tags that are probably, the tags you're going to want to use related to the type of point that you're adding. But for this instance, in this class, especially, we want to just show all the tags because we want to, if you're looking for a specific tag and you have best only selected as the filter option, it will not show you that, it might not show you the exact tag that you're looking for. So in this class, at least, we use show all so that we can see every single tag because we might be looking for something specific here. So we have haystack tag dictionary selected in the top left drop down. We have show all selected in the drop down menu. And then from here, we are going to scroll down in the lab and we can see a table of the 5 points that we're going to be adding. Now, all 5 of these points are going to have the tag area, electric, and meter. And there's a couple other common tags amongst, 2 or 3 of them, but in this instance, at least for me, for this tag mode, I'm gonna just tag area, electric, elect, and meter. So we need to collapse tag groups because we're not working within tag groups. We're looking for individual tags. And if we're gonna select multiple tags at one time in tag mode, remember we can't use the search bar at the top of tag mode. We actually have to scroll through and select the first one, which is area. And then we have to scroll through the list until we find elect for electric. And when we find it, we have to hold down the control key and left click the electric. And then we need to scroll through even farther to find meter. And then we need to hold down the control key and left click the meter as well. And then if you need to double check and make sure that those other 2 tags are still selected, you can scroll up to be sure that they are selected if you need to. So once you have those 3 tags selected, now we can just add all 5 of those points at one time, and they're all going to get these 3 tags, and then we can add the additional tags after we've created the points.
The second tag?
Meter. Second tag is electric, or elect, E-L-E-C. The last tag is meter that we're doing in tag mode, if you're following along.
Thank you.
So once we have that set up, then we can go ahead and add our 5 points. So again, Modbus, we have to actually add the points itself. We can't do any sort of discovery. So within tag mode, if you chose to do tag mode with me, have those 3 area, elect, and meter pre-selected. And then we're going to come down here and select the new button at the bottom of our screen here. When we do that, we're going to get this window. Now, we have a few things to consider. Now, looking at the table in the lab book, I can tell you, and we can see that all 5 of these points are going to be numeric points. So the type that we're going to add, we can change at the top drop-down menu from Boolean writable to numeric point. The next option here is number to add. We're going to be adding 5 points at one time. Now here's the next thing. So this is where it gets a little tricky if you're not familiar with it. So we're going to do the starting address, but we also need to change the address type, the data address type. So right now it's set to Modbus. We actually want to change this drop-down menu from Modbus to decimal. So we're using a decimal addressing scheme. And this is dependent on which type of devices, Modbus devices you're using, and the addressing scheme that those devices use. So it's dependent on the type of Modbus devices, the type of addressing scheme that Modbus devices use that you're using in the field. So you'll have to check, if you're using Modbus, you'll have to check the actual device and see the type of addressing scheme that's using. Some are flexible, some are strictly use one type of addressing scheme. At least in my experience. So we're changing it to decimal. Now, if you look at the data address field in the table here, we'll see that our addresses for these points, the data address for these points, start with an XX and then a number. So that's how we're going to use our starting address. But the XX is going to actually represent our workstation number, I believe. Yeah, so workstation number. So for me, I'm 18. So my starting address will be 180. If you're workstation 1, you'll be 010. If you're workstation 12, you'll be 120. So if you have a single digit, you'll have to use that leading 0. So what this is going to do is we're creating 5 points using a decimal addressing scheme, and we're starting with the first point address is going to be 0, but it's going to include our workstation number. So we're setting the starting address is going to be whatever our workstation number is with a 0 at the end of it, and that's going to be the first one. So then obviously the second point that's created through this process will be, for example, mine will be 181. If your workstation 5, yours will be 051 and so forth, and it'll go all the way up until the 5 devices and go ahead and number those for you. All right, so with that said, so numeric point, number to add 5, starting address using the decimal scheme, and starting it with your workstation number plus 0 at the end as the starting address. I think that's all we need to set up here, and we'll select OK. And we get this screen here. So this looks fairly familiar. We need to go from the start, from the top of the list here, compare it to the table. In the lab book. So the lab book can be a little confusing the way we have this table set up. So the first point, we're actually looking for the point name in the table, and it's the 4th column in this table, in this lab. So the first point that we're going to name is demand. And there's one other thing that we need to change, or 2 things we need to change in here other than the name. So we name it. We already set the data types. That's fine. We actually need to change the register type, and this is important because if we do not change this based off of what we want it to do, we might not get the correct value or reading from this point. And we would see that when we set up graphics for this thing. So we want to change the register type from holding to input. And we're going to be doing that for all 5 of these points here when we get to it. And then lastly, we need to change the facets. Now, this facet, remember, again, we're not using device facets, we're just using facets. And this one is going to be, if you look at the table, you'll see in parentheses, this one says power, and then it says kilowatt next to it. What that means is we're looking for the category. Now, if you remember, if we go back to the facets here, hit that double chevron, and then the 3-dot button, the ellipsis, we get this window here. Now remember, the first drop-down box on the left is the category. So in the parentheses in the table, power is the category that we're looking for. So we can scroll through alphabetically and find power. Now we find power on the left, and once we have power selected as the category in the left drop-down, we can then find on the right side kilowatt, and that's the actual facet that we're using here for our demand. So again, left drop-down box is the category when we're selecting a new facet. And the category we're looking for this point is power. And the actual facet from the power category that we're looking for is kW, or kilowatt. Once you have that selected, go ahead and press OK. Now, this is since we went ahead and added the area tag to everything. A later step in this lab is wants us to come back to each individual point and set the area tag value of the area tag to 1000. Since we're already in creating this point, we've already added that tag to these points. We can actually set the value for this area tag while we're in the point creation window here. So at the very bottom, you can see the 3 tags that we added, and there should be a field box next to area, and we're going to set it to 1000. We'll go over this more when we get into tagging, but there's several different types of tags. There's marker tags, and then there's what's called value tags. And value tags, you can enter a value into them. And that's all we're really doing here, showing you that there is a thing called a value tag and that you can input a value into it. And this will make a little bit more sense when we get into tagging labs later. So we'll go to the next point, which is next point in the list here. That should be the point with the address ending in 1. And we're going to name that consumption. We need to go about halfway down the screen, change the register type to input. So change the register type from holding to input. Then we need to come down to the facets. Now, this one is going to be from the energy category, so we need to hit the double chevron next to facets, hit the ellipsis button. Left drop-down box is categories. We need to find the category energy. So go down to E, find energy. Once you've found the energy category, then we're looking for kWhr, which is kilowatt hour. Find that in the right drop-down box. Press OK. And then after you set the facet, come down to that area tag at the bottom of the screen there. And change that from 0 to 1000. Yeah?
I've got a quick question. I'm getting it with squared. I don't see on your energy consumption. Can you just go back really quick to that facet you were at?
Yeah, sure.
Or yeah, there we go. So yours says energy. I don't have energy. It says energy consumption, but I don't see energy by itself. There it is. Never mind. Sorry.
It's all right. Not a problem. Okay, so we'll set it to kilowatt hours. We'll change the area value to 1000.
Sorry to ask you, that 1003, it's not, what is that, HS area?
Down here at the bottom, yeah, HS area, we
Yes.
just set it to 1000.
I don't have that on mine.
Oh, it's
the
actually, yes,
points.
it's 10,000. Did you might not have actually added the area tag.
Okay.
So you may have accidentally deselected it during the tag mode process.
Oh,
Since
okay.
it was the first one. So it's tricky. So if you control click the first tag and then you control click the next tab, I think it will deselect the first one. So you have to like just normally left click the first tag and then control click the rest of them.
Oh, okay. So I have to do that again. Okay.
Yeah, so we can do
Oh,
that like after we've added the rest of the points, we can come back because we have a couple other tags that we need to add
okay.
that the other points
Okay.
don't have. So we'll have an opportunity to do that.
Okay.
So after we've done all that, so actually the area value, not that it really matters, but the area value for your area tag is actually 10,000, not 1,000. But it's not really important. You don't have to necessarily go back through and change it. We're not going to use that value tag necessarily for anything. It's to just show you what a value tag looks like for later. So we'll go down to our next point, and that's the point with the address ending in 2. And this one's going to be called volts A. So the next 3 points are going to be volts A, volts B, and volts C. They're all going to be set up the same. They're going to have the same facets. So after you set up the facets for volt A, we'll be able to use that facet recall button to quickly assign the other 2. So let's go ahead and rename this one volts underscore A. We need to change the register type from holding to input. We need to go to our facets, hit the double chevron, hit the ellipsis button, which is that three dots button. That from the left drop-down menu, which is our categories, we need to look for called elect potential. So it's actually electric potential. It's not abbreviated in the category itself. So you're looking for electric potential. And then once you found electric potential category, we're just going to set our facet to volts. Once you set it to volts, we'll press OK. We'll go down to that area tag towards the bottom of the screen, set it to 10,000. And from here, it should be fairly easy and quick to just go to the next 2 points, rename it volts B, change the register type, use the facet recall button to select volts, and change the area tag. It's volts underscore B. Register type set to input. Excuse me, sorry, I had to sneeze there. Yeah, change the register type to input. Change the facets so we can use the facet recall button here because we've used volts before now. Select volts, and then all we got to do is change the area value to 10,000. And then go to the last point, name it volts C, volts underscore C. Change the register type to input, just rinse and repeat here. Change the facets to volts with the facet recall button. Change the haystack area tag to 10,000. I'll leave it there just for a few more seconds there for anybody who's trying to catch up. And then after that, all we're really doing is we're not going to take the step where we go to the wire sheet and reconfigure the points. We're not actually going to do any logic with our Modbus wire sheet. So we're just going to skip that step. And all we'll have to do after that is go to each point, right click, go to edit tags, and add the tags for the individual points that were not uniform to the other points, right? So I'm going to go ahead and press OK. It's going to create those 5 points for me. Now your output value, if might be a little different, or it might show some sort of error or maybe a fault. It's known to happen sometimes in the past. It's not a big deal. There might be some of the equipment that we have in here, especially at the Modbus devices, are have aged a bit, so it's not uncommon for the inputs for those points to be a little wonky sometimes. So ignore the output value if yours is weird, reading something weird. All right, so let's if you're at the point where you've already created your points now, it's in the database. We just need to go to each one individually and add any tags that we're missing. It should only be one tag unless you missed a tag during the tagging mode, which just double check that you have all 4 tags for each point. And have your area tag set to 10,000. Again, that value isn't going to take us anywhere. We're not going to use that value anywhere else. It's just to show you what a value tag looks like. So we're going to right click demand, and we're going to go up to edit tags, which will open the edit tag window. Want to make sure, if it's not already, the drop down menu on the left at the top there is set the haystack, and the drop down on the right is show all. If you had used the search function on the last use of edit tags, it will show the last search that you had done. So you might have to just go into the search bar and delete that out. Now I know for my demand point, I need to add the power tag. So I can quickly and easily just type in power in the search bar at the top here, find the power marker tag, double click it. I can confirm that it's added. I can see all 4 of my all 4 of my tags added to the demand point. I got my area, I've got my electric tag, my meter tag, and my power tag. So I know this one's good. And it's as simple as that. Once you've done that, go ahead and press save, add any tags that you need to. Each one has 4, just refer back to the table. So we're going to consumption.
So there's power, I'm sorry, there's power, meter, electric, and what's the 4th one? 4th tag?
Area.
Area, okay.
Okay. So yeah, for consumption, all we need to add is the energy tag. So right click your consumption point, go to edit tags. All you should have to do is go up to the search bar here, type in energy, or start to type energy. You find the energy tag, double click it, press save, rinse, repeat. Go to the volts A, and this should be volt. The last 3 points, you're just adding the volt tag. So right click volts A, oops, go to edit tags, and just go to the search bar. It's pretty simple at this point. Look for volt, double click it, click save, rinse, repeat. Right click volts B, go to edit tags. This is so I should still see the volt tag in my search bar. Double click it to add it. Confirm that it's added to the direct tags. Press save. Do the same thing for C. Double click volt. Click save. Good to go. All right. So refer back to the table if you're still adding the last couple tags. And we'll give you a minute or two to kind of.
So which one was the one that had power included? That's the only one that I missed.
Demand.
Okay.
So be your first point. right, so go ahead and try to wrap that up over the next minute or two. So integrating Modbus, pretty simple. Yeah, the Modbus TCP network to your driver, and then you need to get the IP address for the devices that you're going to be adding that are the IP addresses for the devices out in the field or the ones that are going to be out in the field. So it takes a little bit of prep work when you're adding the Modbus. And then you need to, it's usually like some sort of table or something that has an array of the different types of points that are contained with the controller if it's pre-configured. This is where those decimal addresses come into play. So depending on the type of controller or device rather that you might have, it depends on the addressing scheme within that device or controller. That refers to the points contained within it. And as you can see, once you set those up, it matches up with the controller, matches up with the points inside the controller, and then we get the values for it.
So I had a couple real quick questions, and I'll keep them brief.
Sure.
So I've dealt with Modbus on the Siemens side, and it's completely way more difficult than this is. So my question is, for MSTP. So if you're bringing in Modbus via MSTP, is it similar to what we just did minus the IP address? That would be the first question.
That is actually a good question. I don't think I've ever done that. I'd imagine because I'd imagine so. Yeah, because so that would be a different type of integration network, I believe. So this is the TCP integration, so that uses IP. That might be. I've never done it before, so and Damon, of course, is on a phone call, so I can't
All
ask
right,
him
no,
at the moment. But
yeah,
yeah, I
no
would imagine it's another Modbus integration network that you would add, and it might be the Modbus master or
device.
slave.
Okay. And then the other one was so when you're doing that, like you were describing the different point types. So you got the C and yeah, I forget H holding and input and all those. So that part seemed pretty easy. But one of the things when we were doing that is the offset, meaning some manufacturers start with 0, some manufacturers start with 1. Would you just set that address on our starting address? Is that how you make that correction, or is there a way to globally change everything like to offset the addressing? I don't know if that makes sense.
Um, that's a good question. As far as my knowledge goes, you would set that offset when you're starting the address.
Got it.
Um,
Okay.
I'd imagine that you can go back and edit the points after you've added them if you needed to make an adjustment.
Right. Okay. This is really good. I'm excited about it. Not that I like doing Modbus, but this is way better. And I'm sure people say that a lot. This is a way better way of doing it than I've done in other systems. So kind of cool.
Okay, good. Yeah, so like I've said before, like I haven't used Modbus a whole lot um, in my career when I worked in the field. Um, so my experience is very limited, and most of the experience that I have is from a teaching perspective. Because every once in a while I would link up with something like a humidifier for an air handler, something that would be communicating on a Modbus or something. I have rarely, if not ever, done like a full network of Modbus. So my knowledge is a little limited there, but yeah, hopefully I was able to answer a few questions on that one.
Yeah, absolutely. Just this is I can't even express how much better. You just don't understand. This is awesome. So
That's good. All right, how are we making out? Everybody just about done? So that one's pretty short and sweet. The next one, so it's gonna be a little bit of half and half. So the next one's the lawn integration. It's just as simple, a little bit different setup. Um, so we're gonna do the first. So what we're gonna do is we're gonna integrate the lawn network, and we have to add a lawn network um, device. And so we can with the lawn network or for lawn, we can actually add what's kind of like a template device from our palette. So it's like a pre-loaded template of a device, and it's already got points contained within that template that we can reassign and rename. So we're setting up our LAN devices offline like we did with the MSTP, but we're actually using like a template of a device that we're going to link up with later. But we'll do the first one together, and then the second one you'll be able to do on your own, and then that'll lead us up into to lunchtime. All right, so I think everybody should be done at this point with getting the last couple tags on there. This is we won't really do much with this power meter that we just created. The graphic lab that's associated with it tends to be an optional graphic lab. So you may or may not see this again, but we're going to go ahead and hop into LAN integration. All right, so LAN integration is just as easy as adding the Modbus. There's really no setup required after adding the network itself. One of the major differences is that kind of sets LAN apart. You have to add an additional LAN network for each LAN network that you have. So like with BACnet, we were able to add multiple networks under the BACnet ports, right? So, and we could add just an additional port under that network each time we wanted to add an additional MSDP port or network or something like that. So it's common that we'd see maybe 2 or 3 or maybe 4 MSTP networks under a BACnet system. Consider a network per floor or per 2 floors or something like that, or maybe a wing. So we would only need to add an MSTP port to the network each time we added an additional MSTP network. Now for LAN, on the other hand, we have to add an additional LAN network for each additional network or communication network for LAN itself. So since we only have one for this class, we're only adding one, but if we had an additional LAN network, communication line, we'd have to add an additional LAN network for that one. So a little bit of difference there, if that made sense to you at all. So we are going to make sure that we can see our drivers, right? Because we're going to be adding that LAN network to our drivers module under station. So this is where we've been working, this is where we're going to continue to work. And now we need to actually find the LAN network that we're going to be using. LAN networks, depending on the type of LAN network that you're going to be using, might have variable options. But just like we've done with the BACnet and the Modbus, we need to go to our palette window, and we need to go to that Open Palette button. So bottom left of your screen in the palette window, hit that palette button, which is that folder icon. And then within the filter section, we're going to type in LAN works, so LONWORKS. So this is the Niagara LAN works module. Double click it. And that'll open up the LAN works palette, our library and our palette window here. And what we're going to look for is obviously the LAN network should be at the top. And we're just going to drag and drop it onto our drivers. So once you have LANWorks palette open up, select the LAN network at the top and just drag it onto your drivers. It's going to ask you what do you want to name it. We'll keep the default name LAN network. Now, if we were adding additional LAN networks, remember we have to have one network, an additional network for each communication line, additional communication network. We would maybe then want to name it LAN work, whatever the network number is. Maybe it's 1000, whatever it might be.
I have a short question about that.
Sure. Yeah, go ahead.
So on those Jace 8000s, can you I guess theoretically add a extra lawn expansion onto the end of the other one, or
Um, that's a good question. I think so. Hey, Damon, because I haven't worked with those much. Stuff. He's over stuffing his face.
Oh.
Eating lunch before lunchtime.
Dang it.
I can hold him. He says you can do, I think, up to 3.
Okay, yeah, I have no idea. I've only ever used one expansion module on those, so and you were talking about adding more lawn networks, so I wasn't used to that. So,
Yeah,
thank
no,
you.
I haven't seen it myself. But yeah, he's worked with more lawn than I have in the past. But yeah, so according to Damon, we can add. It looks like he's going to chime in here, so I'm just going to let him pull your mic down. Yeah, I don't think he was actually.
I mean,
Oh well, okay.
so did I answer the question? I think.
Yeah, were you going to expand on that?
No, just I know that when it comes to the JC8000, if you look at the literature, it'll tell you how many of what type of expansion modules you can add, and I think with the lawn, I know you can do at least 2, but I think you can do a 3rd one.
Yeah, I had no idea. So thank you for that.
All right. Yeah, watch him fumble around with his mic for like 2 minutes. I wasn't sure if he was actually going to chime in or if he was just getting on a Teams call or something. All right. All right, so we've added our lawn network, right? So, and that's pretty much the end of that little lab there. So it's as simple as that. Again, just to reiterate, you add an additional lawn network for each additional lawn communication network that you might have. According to Damon, your JC8000 can potentially take up to 8 additional 8 additional modules, 3 modules, because you have to have the expansion modules on the JC8000s for the lawn network. So yeah, that's as easy as it is. Drag and drop, plug and play, lawn network. The real work comes into play in the next lab is when we add the lawn devices. So we're going to be adding these kind of like lawn device templates. And they are templates created for specific types of devices or controllers that are already, out there or available, whether that be some sort of like lawn Honeywell controller or lawn Distech controller, and what type of controller that would be under that manufacturer. We have access to those types of templates within the palette library, and we can go ahead and add these template devices and go ahead and preset them up, prearrange them, so that when we do connect to our Jace tomorrow afternoon, we get our station running on our Jace, we can actually do a match up with an actual lawn device, and it'll sync up with that device, and we'll sync our station or our template device with an actual device. And yeah. So for lab 10, we're going to look at how to add a lawn device by adding offline devices from a palette. This is just one way of doing it. Obviously, this isn't the the end all be all way to do it. Like, you can scan in devices and so forth. But since we're working predominantly offline for this exercise, we're just going to use the templates. So there's a little bit of setup for this. Going through here, the lab actually asks you to do 3 air handlers. So that's what we're going to be creating. We're going to be creating air handlers. We're actually only going to be creating 2. So for those of you who are working ahead, or for those of you who do get ahead of me, we're only doing 2. If you've gotten so far ahead of me, you've created 3, well, then I guess that's good practice for you. But yeah, we're only doing 2. We're doing a Schneider controller, and I believe we're doing a Distech controller. We're skipping the third one, which I believe is a Honeywell. So it's a little bit of a different setup between the two, but ultimately they're going to be the same, give or take maybe 1 or 2 points. So to start things off, we're going to go to our friendly palette window down here in the bottom left of our screen, and we are going to look for we're gonna it wants us to go to the device manager first. So if we double click our LAN network under drivers, it's going to take us to the device manager view. We're all pretty familiar with that view at this point. It's the default view for every network that you add, and this is how we add or discover devices depending on what type of network integration that you're doing. For LAN, we have the option to either discover or create new devices. So in the palette window, now that we have our device manager available here, because we're going to look up these template devices and we're going to drag them into our database. So go to your palette window in the bottom left of your screen here, and we're going to select that Open Palette button. Once we've opened the Open Palette folder icon button, in the filter section, we're going to type out LON CB. So LON capital SIEBE, which for those of you, thanks Damon, the little history lesson is Schneider used to be CB. A little legacy content there for you. So we're going to select LON CB. Again, that's lowercase LON capital SIEBE. And when we open up the LON CB palette or library, we see that we have a list of different device templates for us. And you have to carefully read through because it can be a little confusing reading. They're all kind of similar, but what we're looking for is an MNLRR2 device. And I say to keep in mind, keep an eye on it because there's the MNLRR3, MNLRS2, just kind of. So once you find the MNLRR2 device under the LON CB palette, we're simply going to drag and drop it into our database. So our LON device manager database here. So just drag and drop. And it's going to ask what we want to name this thing. We're going to name it Air Handler 1. So the first of 2 air handlers that we're adding here. We're going to select OK. Okay, so from here, all we need to do is, I believe we could double click our air handler. Nope. Got to go through the nav window again.
So we make that 1 or 0 1 or we're not doing any wire sheets on it, right? Because
we're gonna do a wire sheet on it. But I mean, we're not gonna do much with the wire sheet, but we're gonna do a points folder. I forgot to put the 1 on my name. You can do 0 1 or just 1 for the air handler. It's up to you. I'm just gonna do air handler 1 without a leading 0. So in the nav tree, expand your LON network if you haven't already done so to find your air handler 1 that we just created. We need to click the device in the nav tree to get to the, or we need to expand it to find the points module. Similar to what we did with the BACnet and what we did with Modbus, we find the device, we expand it, we find the points module, we then double click the points module so we get to the point manager. We'll then click the new folder to create a points folder because we've already done it for all the other ones. We might as well keep the tradition here. And we're just going to name this control, I believe. Yeah. So we've stuck with the habit of making points folders for this class. We're going to continue it on. So again, in your nav tree, expand LAN network, expand your air handler one that you just created, double click on your points module, click on the new folder icon at the bottom of your screen in the point manager view. We're going to be creating a new points folder. We're going to name that control. After we've done that, we'll see our points folder added to the database, and we can double click that control points folder either in the nav tree or within the database here to take us to the LAN point manager view of our new
I
point folder.
think I missed this
Okay.
because I am not seeing under the local LAN device the other network, the air handler one.
Okay. So did you drag the MNLR2 device from the LAN CB palette into your LAN network database?
That's what I didn't.
Right, you said that's what you didn't do. Okay. Yeah, so it's simple. Just double click your LAN network device manager view, drag that MNLR2 from your palette window into the database, and then you have to open it up, name it air handler 1, open it up in the nav tree, go to your points module. Okay. All right, so once we have our air handler created, we've got our points folder called control created. We want to double click on our control points folder to make sure we're working in there. Remember, we have this locator bar at the top of our screen here, that dark bar. This will let us know where exactly we're working to make sure that we're actually working within the points folder that we created, because we can see that we're working in the control folder. So now we're going to discover the points contained within this template device that we just added. And we'll actually have to go through a list of names that are going to pop up to discover. So once you've got the points folder created, working in the points manager view of the control folder, go ahead and at the bottom of the screen hit discover, and then you're going to get this fun window of confusing text. So these are abbreviation and names that are given to the points within the device template. So these were predefined when this device or controller was loaded with this, or the database was created for this device. So we actually have to compare it to a table that we've created and add specific points. So I believe there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different points that we have to add. And some of these points are contained or nested in other points. So if you see this plus icon, some of these points are going to be that we're going to be looking for are nested within other points. It's just the way that the database was built for these devices. So one trick that I like to do for this one is at the top of the screen in the discovered window, you'll see the tab target name. If you click that once, it will put these items in the pseudo alphabetical order. Makes it a little bit easier to navigate through this list. And you have to carefully kind of pick through it and look for your points one at a time. So we'll start with the point at the top of the list. So hopefully everybody's gotten to this point so far, where they've gotten to their control folder and have done a discover and have now see a list of points that are available within this template that we've added. So either follow along with me or go ahead and do it at your own speed, but compare to the lab book, the table in the lab book on page 55, and go through each of them one by one, find the correct point. Now, I will say that there will be, like I said, there will be a few of them that will be nested in other points that you have to expand. So, for example, this NVO occupied schedule maybe I have a point contained within there. I'm gonna have to open this up. The thing to look at when comparing it to the table is actually the element name. So if there's something that might be nested into something, it's compare it to the element name, and the element name is similar to the underscore. So within this table here in the lab book, we see like an NCI set points here, and then an underscore occupied cool. This occupied cool will be an element name within here. And this is the second row of the element name. So you have to really kind of pick through and find exactly what you're looking for. But starting with the top, so NVO sat level disk 1, right? So we just need to scroll through this list of discovered points until we find what exactly we're looking for. Now, I highly recommend if you haven't been already, definitely reference the lab book over just watching me go through it one at a time, because you might lose track with me because we have a lot to fish through. So NVO sat level disk 1 is the LON or SNVT point that we're looking for. Once we find that what we want to add to our database, all we have to do is either drag and drop it or select it and hit add. But we have our database down here at the bottom of our screen, and we can simply just drag and drop it to the bottom here in our database. And we have to be careful here because we not only do we have to change the name and set up the point, but just like it did with the BACnet, we can only change the data type once, and it's when we initially add the point. So unlike the discovered points that we found in the BACnet over IP, the chiller, where the data type matched the table, all the data types by default in this LON database template are going to be enumerated point or something other than what it probably needs to be, just because all these points were created en masse. All the data types may or may not have been set to something close to what it actually is. So for this example, this is actually a cooling coil that we're adding. So the name is going to be cool, and by default it's set to an enumerated point, but we obviously want to set this to a Boolean point based on what we see in the table here in the lab. So we definitely, if anything, we want to double check the point type compared to the table, because we cannot go back and edit the point type. We can edit everything else except for the point type. If we mess that up, we'll have to go back through and add it all over again. So keep that in mind. If you mess anything up, just don't mess up the point type. So we change this to a Boolean point. And then, looking at the table, we want to set our facets to on-off text. So we'll just come over to our facet recall button here within this add window here, and we will find our on-off text, because remember, any facet that we've created or used in the past within this station will be available to us in this facet recall button. And then after we've done that, we can press OK. Now you have two options here. We're going to go ahead and go through the process of adding the tags for these. It's up to you whether you want to use tag mode and select all the tags for each individual point that you're adding ahead of time, or if you choose to right-click edit tags after you've added the point already to your database and just add the tags that way. That's up to you. For me, I'm just going to use the edit tag function since I'm adding in points one at a time. So what I'm going to do here is I'm going to right click my cool point that I just added in my database. I'm going to hit edit tags. I want to make sure that I'm at least working in the haystack, tag dictionary at the top left, and make sure that the filter says show all. And then I can simply type in each of the 4 tags that are listed in the table in the lab. Find them pretty quickly just by typing out one at a time. So the first one is AHU, air handler unit. type that in the search bar. That should be the only option that I have. I can double click this, see that it goes down to my direct tags here. Go back up to that search bar, type in cool, find the cool tag, double click it, confirm that it's down here in the direct tags. Go back up to the search bar, type in equip for equipment, double click that, add it to the direct tags. And lastly, the HVAC tag. Just type it in the search bar at the top, find it, double click it, add it. I've got all 4 tags I'm looking for added to this point. All I need to do now is hit save. If you prefer tag mode, you're more than welcome to just do that. Preemptively or pre-selecting all the tags for that individual point. It's up to you. So that's the first point, NVO sat level disk 1, which we've changed the point name to cool. We have changed the point type to Boolean point, changed the facets to the on-off text, and we've added 4 tags to it, the air handler tag, the HU tag, the cool tag, the equip tag, and the HVAC tag. When you finish with that, we're going to the next point in the list, and it is if you changed it to alphabetical order on the target name in the list here, yours should be the point should be right under the one we just used. So that's NVO sat %1. So I'm going to drag and drop that into my database. It's going to ask what we want to name it. This one's going to be heat, so this is going to be our heat coil. Or maybe it's electric heat since it's binary or a Boolean. So remember, we changed the name to heat for the table, and then we need to change the point type. So currently, by default, it was set to numeric point. We need to change that to a Boolean point. After we change that Boolean point, change the facets to on off. Again, we can easily select that from our facet recall button here. And that's all that we have to do set up for this, other than adding the tags to it real quick. So again, the name is heat. It's a Boolean point, and we've changed the facets to the on off text. Press OK. Now we'll see this pop up in the database now. And again, if you had these points are going to come in as fault because they're offline. They're not actually tied to anything yet. So it's completely normal. We're not actually going to see any value on them yet. So I'm going to right click my heat point that I just created. I'm going to go to edit tags. Now I already know there's 4 tags I need to add to them: AHU, equip, heat, and HVAC. When you go back to the edit tag window, it's always going to show you the last tag search that you had done if you had done a tag search. So I can work a little bit backwards here if I want, because I know it's going to get the HVAC tag, and that's still showing up from my last search. So all I have to do is double click HVAC, go back up to the search bar, look at my table, working backwards if I want to. I know that my next tag is heat. So I go to the search bar at the top, type in heat, double click heat to add the tag to the direct tag section here, to add it to the point. Go back up to that search bar, type in equip, so EQIP, add the equip tag. And the last tag we need for this guy is the AHU tag. So we go back up to that search bar, type in AHU, see the tag, double click it to add it to the point. After that, I've got all 4 points. Press save. All right, so the next point that we're adding is called we're looking for is NVO sat switch 1 underscore state. So we can assume that the underscore state is an element name. Typically when you see an underscore, it means it might be nested into something else. So let's go and find this NVO sat switch 1. And it is a couple placeholders down under the sat %1 that we just added. So I see a NVO sat switch 1, but the element name is value. That's not the one that I want to add. So it's got a plus icon next to the NVO sat switch 1 point. And if I click that point, that plus icon, I see that there's an additional NVO sat switch 1 with the element name state. This is the one that I want to use. This is what I'm looking for. So NVO sat switch 1 with the element name state in the next column. We're going to drag and drop that into our database. And we're going to do the same process as we've done before. We're going to look at the table in the lab book. We're going to make sure that we name it and correctly. So this point's name is going to be fan. And we want to make sure that we change the type from enumerated point to Boolean point, because it is a fan, it's not a variable fan, it is an on-off fan. Once you've changed the point type, we just need to come down to facets, change it to the on-off text with the facet recall button. We've done that, we'll press OK. That's all the setup that we need to do for that, other than adding the 4 tags real quick. And to do that, and if you didn't use the tag mode, we just need to edit tag. So I'm going to right click my fan in the database. I'm going to go up to edit tags. And I can see that my air handler tag or my AHU tag is still shown from my last search. And I know, looking at the table here in my lab book, that it's also going to be getting the air handler tab. So I can just start from there. I'm going to double click AHU to add it to my direct tags. It's also going to get the equip tag, so I can go back up to my search bar here in the edit tag window, type in equip, EQIP, EQUIP. Once I found it, I double click that, add it to my direct tags here. Go back up to my search bar. I'm going to look for the tag called fan. After typing it in the search bar, I find the tag called fan, double click it to add it to my direct tags down here at the bottom. And then lastly, I need the HVAC tag. So I'll go back up to that search bar, type out HVAC, should be the only tag available. Double click it. I see the 4 tags I needed to add down in my direct tag section, so I know I'm good. I'll leave this here for a couple more seconds. All right, once we have all 4 of those tags added, we're gonna hit save. And then now we need to add our damper point. So what we're looking for is NVO sat %2. So I believe this is one of the points that's a couple places up from the fan that we just added, the NVO sat switch 1. So a couple spaces going up, we find the NVO sat %2. We find the NVO sat %2 point. We'll just simply drag and drop into our database. We'll go through the same process of naming it, setting its point type, and setting the facet. Pretty simple. So we'll change the name to damper. It is a numeric point this time. For me, mine was set as a numeric point by default. For this one, lucky lottery chance there on that. So it's a numeric point. If it isn't for you, go ahead and double check and make sure that it sets a numeric point, but it should be.
I'm only seeing 7%1, not 2.
You should be there, just below it. If you added the correct device. Let me walk over to you.
I found everything else except for that one.
It looks like you might have added the wrong device. Judging by what I see in your palette. The one that's highlighted in your palette window, is that the one you added? The MNLRF2?
Yeah, that's correct.
Okay. So that's the reason why, yes. This is the MNLR2, which is towards the bottom of your list there. Scroll up just a little bit more. A little bit more. Yeah, that one. That's the one we want to add to our lawn network. All right, it's no big deal. You'll be able to catch up on that. So what we'll be doing after we set this first air handler up, you guys will be setting up the next one on your own. And during that time period, we're going to also take a lunch period. So it'll be like an hour and a half period where you guys get to do what we call a lunch and lab. We give you a lab assignment, and we're also going to take a lunch period during that time frame. So you'll have more than enough time to get caught up on those 3 points that we've already added and do the next air handler as well. So just follow along with the lab book, or if you want, go to the next point that we're about to add, and you'll just have to go back to the other 3 or so points and add those back in later if you want to work alongside me.
That's fine.
All right. So yeah, so we've added the NVO stat %2. We're adding it rather. It is a numeric point. The facets for this one is actually going to be a %. So we need to go to our facet recall because we've used it once before. So we're going to look for the units equals % sign in the facet recall button. And that's all there is to that one. Then we just press OK. And I think this is the last point that has like 4 different tags to it. The rest of them should just be like 1 tag. So we'll right click our damper point that we just created in our database. We'll select edit tags. We're going to go through this whole same process that we just did. We're going to add HVAC tag because it's already there for us. Go up to the search bar. We'll type equip. Double click equip to add the tag. Go back up to the search bar. Add HVAC. No, see, I already added that, so I got to add myself. But it's a good point to show you though. If you see, so if you already have added a tag to a point, it won't allow you to add that tag again. Fun little fact there for you. So the next tag that we're looking for is actually damper. So go back to the search bar at the top of your edit tag window, type in damper. Once you find it, double click it to add it to your direct tags. And then lastly, for this point, we're going to look for the AHU tag. Go back to the search bar at the top, type out AHU. Double click it to add it to your direct tags. once you have all 4 tags added to your point, you can hit save. Now, it doesn't matter the order in which the tags were added, if anybody was wondering that. Um, it has no impact on the point whatsoever or the tags. The tags can be added in any order. So once you have all 4 tags, we'll just hit save. All right, so the next few points should be a little bit quicker because we don't have to add so many tags. But I think the next couple ones are a little bit harder to find. So at least the set point ones are. So we can collapse anything that we may have opened. So the next one we're looking for is NVO space temp. That one's pretty simple, right? So a couple places down from where we just were, NVO set %2, we'll find the NVO space temp. We're going to add that point by dragging it into our database or highlighting it and press add. Same process we've been doing. We changed the point name to space temp underscore SNSR. Again, this is one of those times where the naming convention is important because later on we will be doing something where naming convention is specific and we're going to use it for something else. So space temp sensor. So space temp underscore SNSR. We want to confirm that the type is set to numeric point. We want to change the facets to degrees Fahrenheit. Make sure when we go through and change the facets to degree Fahrenheit that we're not adding the degrees Fahrenheit with a min and max value set. Because remember, we did that in the boiler section where we set a min and max value of 102 and 200. We do not want to add that because that will mess some things up. So we want to make sure that it's the minus infinity plus infinity one.
So even though on the table it says the min and max with the 55 and the 85, so you're saying leave that in infinite?
That's for the set points. So this one's for the space temp sensor. If you're on the point where you're adding the set points, then yeah, follow the table and set the min and max value to 55 and 85.
Man, I'm having one of those days. Sorry about that. I got you.
It's all right. That's all right. So yeah, so we'll add the space temp sensor again. Make sure it's a numeric point. We'll change the facets for this point to degrees Fahrenheit with the minus infinity plus infinity. All right, so once we've done that, we need to give set a tag group to the space temp sensor. So we will right click our space temp sensor, point that we added to our database. We'll go to edit tags. We'll clear our search bar at the top and we'll type out zone. So it's lowercase z zone. And you can either scroll through the tag groups that have shown up or you can continue to type out air temp sensor if you want. I'm just going to look for the one I'm looking for. So it's zone air temp sensor under tag groups. Remember, tag groups are going to be adding a collection of tags contained in that tag group to the point. So once you find the zone air temp sensor tag group, we'll double click that. Now notice it looks a little different. We'll go over this more when we get into the tagging lab. But what this is doing is it's referencing back to this tag group that's created back in the tag dictionary service. And it's going to retrieve the tags that are contained within this group. So the zone air temp sensor tag group. Once that's added, we'll hit save. That one's good to go. All right, we're almost done with this air handler. So the next one is the NVO effect set point. So we're setting the effective set point. So we're looking for NVO effect set point. So we might have to scroll up a bit here, alphabetically. And I found mine. So again, it's towards the top of the NVO section if you reordered the target name to be alphabetical. It's just below NVO CO2. So the NVO effect set point, we're going to go and drag that into our database. We're going to rename it effective set point. Set point is abbreviated with SETPT. We want to confirm that it's a numeric point. So the data type is set to numeric point. Now when I say data type, I mean the type just under the name. Set to numeric point. We want to set the facets to degrees Fahrenheit. Now, if you hadn't already noticed, when you look at the default facets that was assigned to any of these numeric points, you might have noticed that they were in Celsius. So the default engineering unit for temperature within lawn devices are Celsius. But we're changing the facets for at least on the workbench side to read in Fahrenheit. So this will do the conversion for us, no matter what this device might be reading, whether it's reading it in Celsius or not. Our workbench, since we set the facets to degrees Fahrenheit, our workbench will do the conversion for us. So we're set it to degrees Fahrenheit, and we'll press OK. We'll find our effective set point that we just added in our database. We need to add one tag to it. I believe it's just the effective tag. So we'll right-click effective set point. We'll go to edit tags, top of the window. In the search bar, we'll just type effective, EFFEC. Once you find that effective tag, we'll just double click it. It's the only one that it gets. Press save. Once you do that, now this is where it gets a little interesting. So we're looking for our occupied cool set point, unoccupied cool set point, occupied heat set point, and our unoccupied heat set point. Now these will be nested in a group. So we'll have to find it and expand it and make sure we drag the right ones in. So what we're looking for is NCI set points. And then the underscored section is the element name. So what we're looking for initially is NCI set points. So if you scroll up a bit, you should find it eventually. So alphabetically, NCI set points. It should be a little plus icon next to it. Now again, remember the underscored section of the point name in the table in the lab exercise book, that represents the element name of what you're looking for. So once you find NCI set points, hit that plus icon next to it. But the first one is actually the default one that has the plus icon next to it. This is the one we're adding. Now, it might seem counterintuitive because some of you who are used to nested points or what have you, you would think that adding this NCI set points with the element name occupied cool, since it's the top of the list and it's got the plus icon, you think adding this would add the rest of them, but that's not the case in this scenario here. Each of these are individual points. These just happen to be nested under there. Adding what looks like the parent doesn't add these nested points into your database. So we have to drag them in individually. So the first one is NCI set points, but the element name is occupied cool. That's the first one. That's the one with the plus icon next to it. Well, with it opened up, it's the minus icon next to it. But we'll grab that. We'll drag it into our database. And this one's going to be called occupied set point, but we're going to use abbreviations here. So the name will be capital OCC, type out cool set point. We want to make sure these are writables because these are set points. They need to be programmable. They need to write to something, and they need to be written to. So we need to make sure these are writable, numerical writables. Now this is where we set the facet, degrees Fahrenheit facet, with a min and max value. And the min and max value is going to be 55 and 85. So again, this goes back to restricting the range at which we can set these set points for. And this more or less ties back to the range that a user can change this value from. So a user won't be able to set the set point value any lower than 55, and they can't set it any higher than 85. And we can further restrict this, obviously in the real world, depending on what it is and what kind of restrictions you want to put on it. But in this scenario, we're just going to have it 55 to 85. So we can, if we want to just quickly find our degrees Fahrenheit, we can use the facet recall button, select the degrees Fahrenheit facet, and then come to the double chevron icon, and we can change the minimum from minus infinity to 55 and the plus infinity to 85. Now, in doing this, this doesn't overwrite our previous facet with the plus and minus infinity. This creates a new version of that in our facet recall as well. So this is a quick way of having to do this instead of having to hit the ellipsis button up here and having to navigate categories and find the temperature or the Fahrenheit facet that we're looking for. So again, it's degrees Fahrenheit with a minimum value of 55 and a maximum value of 85. And to quickly do that, we can go to our facet recall button, select our units equals degrees Fahrenheit, and then change the min and max value, and it will create a new degrees Fahrenheit facet for us with a min and max value. Okay, so with that set, we have the occupied cool set point. It's numeric writable. We changed the degrees, the fastest degrees Fahrenheit with 55 and 85 is the min and max. We'll press OK. This thing only gets one tag, so we'll go ahead and quickly do that. We'll right-click occupied cool in the database, the point we just created. We'll go up to edit tags. We'll go up to that search bar at the top. We'll type in cool. We'll double click the cool tag to add it to our direct tags. And that's all there is to that. Once we've done that, we'll press save. And this is when we go, if you haven't already, this is when you can expand the NCI set points. And we need to find the NCI set points with the element name that we're looking for. So for the next one, we're actually looking for the NCI set points unoccupied cool. So you can check the element name in the this icon, this row here, or column rather. You're looking for the unoccupied cool NCI set point. So when you find that from this drop down here, we want to add that to our database. And the same procedure as we've been doing. This one we're actually going to name unoccupied, so a little bit of abbreviation here. So UNOCC, cool set point. Want to confirm that it is a numeric writable because set points are programmable points that we need to be able to write to or write from. They're not read-only. We need to be able to set them, so we want to make sure that they're writables, so numeric writable. And then we need to change the facets to the degrees Fahrenheit with the min and max value of 55 and 85. Since we've already done that, we can quickly find that in that facet recall clock icon here. It should be at the top of the list for us. Quickly and easily change that. So unocc cool set point, numeric writable, change it to degrees Fahrenheit with a min and max value of 55 and 85. Press OK. We need to add the cool tag to this guy. So we're going to right click it within our database, down at the bottom, go up to edit tags, go to the search bar, give it the cool set point, or the cool tag rather. And again, it's the same steps we're taking over and over again. It's the same steps you're going to be doing when you add the next air handler. You're going to go through the same process. It's a little rinse and repeat. It gets kind of repetitive, or it is repetitive. So you might be a little bored doing it, but it's just it kind of sinks in though after doing it for a while. So the next one we're adding is the occupied heat. So if you've had the unoccupied cool set point already, the next one in the list is the NCI set points with the element name occupied heat. So when you find that, we'll go ahead and drag that into our database, or you can highlight it and press the add button. We're just going to name this occupied heat, so OCC heat set point. Remember, we want to make sure it's a numeric writable because it's a set point. It's a programmable object or programmable point. We need to be able to set it value. And then we just need to change the facets to degrees Fahrenheit to 55 and 85, min-max value. Press OK. Need to add the heat tag to it. So once you've added the point to the database, right-click Occupied Heat Set Point, go to your Edit Tags, go to the top search bar, type in heat, if you spell it correctly. Type in heat, double-click that tag to add it to your direct tags. We'll press save. We only have a few more tags or a few more points to add here. So we're looking for the unoccupied heat. So we're still looking within the NCI set points point name here. And then we're looking for the state or the element name of unoccupied heat. So I believe it's the last one in this little drop down list here. So NCI set points unoccupied heat. Drag and drop that into an empty space within our database or within this header bar here within the database. Or you can highlight it and press the add button at the bottom of the screen. It can be a little tricky once we start having a list going if you start running out of empty space, but you can resize the database window to give yourself a little bit more room. So we're going to name this unoccupied heat set point. So UNOCC heat SETP. Remember, we want to make sure it's numeric writable. And then we just need to change the facets to units equals degrees Fahrenheit with that min-max value 55 and 85. Press OK. And then we just need to change or add the heat tag to it. So we'll right click our unoccupied heat set point, go up to edit tags, should still be within the search window from our previous search. Double click heat. Make sure it's added to the direct tags. Press save. And we got 2 more points to add. So the next one is NVI occupied schedule underscore current state. So what we're looking for on the left side is a point called NVI OCC schedule. So alphabetically, we know we're going to scroll down a bit. So NVI OCC schedule. So I found it. It does have a plus icon next to it. So there are other additional NVI occupied schedules nested in it with different element names. But the one we're looking for is current state, and that should be the top one here. So all we need to do is grab the one that says NVI occupied schedule or OCC schedule with the element name current state. Should be the first one. And then add that to our database, just like we've been doing so far. Rinse, repeat. And we're going to name this occupancy command. So occupancy CMD. Now this one is actually going to stay an enumerated writable, enum writable. So for our air handlers, we're going to use an enumerated schedule. So it's going to have different enumerated states to choose from. And this occupancy command is going to link up with our schedule and have one of various choices to pick from, or that'll be the options for the command. So enumeratable, it says see step 8. Now we only have to do this once, and you'll be able to do this from the facet recall button for the air handler 2. So this one can be a little tricky. So if you're following the directions, you can either watch me as I do it or go down to step 8 in the lab book. But what we're going to do is we're going to go to the facets, the double chevron for the occupancy command here. We're going to hit the double chevron and then hit the ellipsis button like we've been doing to find a particular engineering unit. And then when we do that, we'll have this window that just has a double chevron box. I'll have to click that as well. So we're going to go through all these, and this is where we get to the enumerated enum box. So I'll give a couple seconds for people to catch up there. So you're hitting the facet, the double chevron in the facets section. You're then hitting that button that's got the 3 little dots on it. It's going to pop up another window that just has 2 double chevrons in it. Click that, and that'll take you to this enumerated box here. And when you get to here, what we need to do is we need to select this checkbox at the top. And it says use frozen enum in range. And then in parentheses, it says module name. So what we're saying is we're going to use an enumerated range that's already been preset from a module, a specific module that we're going to look for. So we're going to select this checkbox. When we do that, we get this drop-down box right under it. And this is where the fun begins, because then we have to hit this drop-down box and we have to look for a specific LON module that we want to use to be our enumerated, to dictate what our enumerated states are. And the fun part about this is we have to scroll through this very long list of things. Luckily, it's in alphabetical order. But what we're looking for is LON works, LON occupancy, enum. So there's one of 2 ways we can go through this. We can, or one of 3 ways rather. We can either mouse wheel scroll through this entire list. We can grab the handle here on the right side of our screen, and we can scroll quickly down to about the L section because we're looking for LON works, right? And it is alphabetical, so but it's down here. So however you get here, we're looking for LON works, LON occupancy enum. Wait a bit to scroll through. I think I passed it. Yeah. So go and scroll through that drop-down menu. So you find LON works, LON occupancy enum. Now it is also possible to select somewhere, kind of hover over somewhere within the drop-down menu, and you can start to type out LON, and it'll jump you down to the LON section. But if you try to do that when you're hovering over like an empty space within the list, it doesn't always work appropriately. So sometimes it's just as easy to grab the slide bar handle on the right of the window and just scroll down, drag it and scroll it down. So once you find the LON works LON occupancy enum, we're going to go ahead and select that. And these are the enumerated states that our occupancy command is going to work with here. So once you've done that, we're going to go ahead and press OK. So now that we've done all that fun stuff, it's preset, and just like all the other facets that we've used, when you get to air handler 2, when you're creating that one on your own during the luncheon lab, you'll be able to quickly just add the facet to the other occupancy command, and it'll look like this. It'll be range equals lawnworks colon lawn occupancy enum. So you can quickly, add that to your other occupancy command for your other handler unit. So with that set, we have a couple more things to do. So hopefully you were able to set that facet with no issues. Then we'll press OK, and that's going to add the occupancy command. I think I missed a letter there. And if you ever mess up the spelling or something, or mistype something, or need to rename something, you can always right-click the point and select rename. I missed a C in occupancy. Not a big deal, but so with that, once we've set the facet, let's right-click our occupancy command because we just have to add a tag to it real quick. And the tag we're adding, so right-click, go to Edit Tags, go to the top search bar, and we're just going to type out OCC for occupancy, the abbreviation for occupancy. We're going to add that. We're going to confirm that we've added it. We can see it that it's in our direct tags here. We'll press save. Okay.
Is that occupancy indicator or just occupancy?
You talk about the tag?
Yeah.
It should just be OCC. Yeah, so it should just be OCC. Just the abbreviation for occupancy. All right, we got one last point to add, and then we need to set our set points, default values for our set points, and then we can move on to the next air handler during the luncheon lab. And I'll release you guys to work on that on your own, as well as take a lunch at some point during that time period. So let's go ahead and look for our NVI outside temp. So we're in NVI aux schedule, so we're going to stay within the NVI, just a couple spaces down, 2 spaces down. I find the NVI outside temp. So NVI outside temp here. I'm going to add that to my database by dragging and dropping or selecting it and hitting the add button. We're going to rename this guy OA temp. And we want to double check the data types. The type, we want to make sure that it says numeric writable. And then we want to change the facets to just degrees Fahrenheit. Now we have a couple different versions of the degrees Fahrenheit now. We want to make sure that we're adding the degrees Fahrenheit that has the minus infinity and plus infinity. And once we've done that, we're going to go ahead and press OK. So the name is outside air temp, so OA temp, the numeric writable, and it is the facet is degrees Fahrenheit with no min or max value. We'll press OK. We'll see that it's added to our database. We'll add one last tag. We'll right-click our outside air temp, go to edit tags, and up in the search bar at the top there, we can start by typing out outside. So the word outside, and what we're looking for is outside air temp sensor. You can find that, and that's a tag group. So find outside air temp sensor under tag groups. And we're going to double click that to add it to our direct tags. When we've done that, we're going to press save. And after you have that all set and the tag added, we have all the points that we need for our air handler 1. And then the the lab has us go through to the wire sheet and set action on set the fallback action for some of these points. So we'll go ahead and do that real quick. So we can go from the points manager view over to the wire sheet view if we want. We can quickly do that by just going to the view selector, as long as we are looking at our control points folder. If we go to the the point manager, this drop down menu here, the view selector, go to AX wire sheet. This will take us to the wire sheet for our air handler that we just added. Now we're not actually going to be creating any logic necessarily for this, because since this is one of the special ways that Lawn tends to work when you're creating these device templates. This device already knows how to, pretty much has like pre-assembled logic already within it. We're defining and declaring certain points and renaming them, but since they were already existing points with point names, and that these points within the device itself, or this device template, already knows how to interact with each other. They've already got some logic created inside of it. And all we're really doing is taking those points, renaming them, maybe changing their point type or changing its facets. And that's all what we're really doing here. So we don't have to do we don't really have to do any logic here. I think we do a link to a schedule, and that's about as far as it goes. So this device knows how to operate. And we can set some parameters, but for the most part, the logic's already done in the background for us. So if you want, you can kind of just rearrange these a little bit, however you want them. But what we're going to do here is just change the fallback on a few things. So move my occupancy command. These are my set points. You might want to rearrange them however you want. Select these and make them bigger. So you can do this within the wire sheet view, or you can open up your nav, the control points folder in your nav tree. You can do it, either way to set the action. So it depends, how you want to view it. So I'll do the first one within the nav tree. So I'm going to look for my unoccupied cool set point. And I can find that quickly in my nav tree here. And I can right click it. I can go up to actions, and I can select set, which this allows me to set its default value. And it's only going to let me set my default value or my fallback value within the range, the min and max range that we had set in that facet for the set point. So we can see that here. I can only set it between 55 and 85. But what I want to set my unoccupied cool set point to is 80. So I will set that here. So again, that's right click the unoccupied cool set point, whether in the nav tree or within the wire sheet. And you can even do that within the database view of the point manager if you're still looking at that view. It's up to you. Either way, you have to click on the point, right click the point. So unoccupied cool set point, we're going to set it to 80. We're going to go through each of these set points and give it a fallback value. So we start with the unoccupied cool set point. We're going to give it a fallback of 80. Next, we're going to the occupied cool set point. So right click that. I'm going to do mine in the nav tree again. So right click, occupied cool set point, go up to actions. It's the same steps, no matter where you right click it, whether it's in the database, the wire sheet, or the nav tree. You right click it, go up the actions, go to set. You get a pop-up window. We're setting this to 76. Just to mix things up, I'm going to do the next one in the wire sheet. So the next one is occupied heat set point. Select it, right click it, go up to actions, go to set. Look at the lab exercise book. It says that we need to set it to a fallback of 72. Do that here. Press OK. And then lastly, I need to set the unoccupied heat set point to 65. Again, you can do that in the nav tree, the wire sheet, or the point database. Either way, you right click the point, go to action, go to set, look at your lab exercise book, and it wants us to set it to 65. We do that, it's good to go. So there's a couple things. So we're gonna pin and unpin a couple slots on our points in our wire sheet. So we can do this one at a time. So we're gonna start off with the unoccupied cool set point. So I'm gonna select it, right click it, go to pin slots, and we know this looks fairly familiar so far, right? What we're gonna do this time is actually we're gonna unpin the in slot 10. So in 10 and under the pin slot menu, we're just gonna select it, and that thumbtack, that pin icon should disappear next to N10. So there should no longer be an N10 with a pen on it. But we want to scroll down and we want to pin fallback. So we went through and set the fallback for all of the set points, and we want to see that on the point within the wire sheet. So we're going to scroll down and we're going to pin fallback. And that's all we're going to do here. We're going to go through each of the set points and do that exact same task. And if you're looking at the lab exercise book, it shows each the point that we're going to do this for. So go ahead and do that. I did miss 2 action sets. You may have missed this, or you maybe were on top of it and were able to accomplish it without me. So our occupancy command, this enumeratable here, we need to set that to something. We need to set it to occupied. So I want to right click. I'm going to go ahead and catch up and do what the task that I've skipped here. I'm going to right click my occupancy command, go to actions, go to set. It should be a drop down menu. I'm going to select occupied, press OK. Easy, right? And while I already have that select, I'm going to go ahead and right select that, go to pin slots, because that's one of the things in the lab book that wants us to pin out fallback. So I'm going to unpin in slot 10. I'm going to make sure I pin fallback. And here on this the occupancy command point block now, I can see my fallback and shows occupied. And then I need to set the action or the default value for my outside air temp, which is over here. Make it the same size as everything else. You don't have to do that if you don't want. But same process. Right click the point, whether it be in the nav tree or in the wire sheet, what have you. Right click it, go to actions, go to set. And this I'm going to set it to a value, and we're setting it to a value of 55. And while I have that already done, or have outside air temp already selected, I'm going to right click it. And I'm going to go to pin slots. I'm going to do the exact same steps that I've just done for the other one. I'm going to unpin in slot 10. And I'm going to scroll down and I'm going to pin fallback, so I can see its default value on the object. And then I just need to do that process for the remainder of my set points. So I need to go up to my occupied cool set point. I'm going to right click it, and I'm going to go to pin slots. It's the same process over and over again. I'm going to unslot, unpin slot 10, and I'm going to pin fallback. Okay, should be able to see my fallback within the point block now. So I have the two other heat set points. I'm going to go ahead and do that same process for. Again, it's the same process. Right click, go to pin slots, scroll through, unpin the in slot 10, and then I want to pin fallback. Press OK. Again, same process for unoccupied heat set point. Right click it, go to pin slots, scroll down the list, unpin the slot N10. It's like no matter what way I say that, it sounds like a tongue twister or confusing. And then we want to pin fallback. Okay, so one last task for this section. We need to add at least for this air handler, we need to add an occupancy schedule or an enumerated schedule, excuse me. Lunchtime's creeping up on me. So what we need to do is, so we go back to the palette window, right? And we're looking for that schedule palette, and we've used that before. So there's this drop-down menu here within the palette window. Right now it should say Lawn CB. If we click on that drop-down window, we should be able to locate our schedule palette from the drop-down list. When we do that, we have our schedule palette here, and we're going to be adding an enumerated or an enum schedule. So we're just going to add it to the wire sheet. And this is the only bit of logic that we're going to do for our air handler here. It's just adding an enumerated schedule to the occupancy command. So take that enum schedule from the palette, drag it onto an empty space within your air handler wire sheet. It's going to ask, what do you want to name it? We're going to name it occupancy schedule, or SCHED. I'm going to press OK. You can resize it if you want. Now that we have the enum schedule in our wire sheet, we just need to go to its property sheet, or its property page, and adjust a few things. So we'll double click our enum schedule. And the first thing we want to do is go to a properties page. So that whole long process of going to the frozen enum and checking, selecting a enumerated states from a certain module, we're going to actually use that here in this schedule here. So what we want to do is hit the facets button, the facet recall button, and we can select that range equals LawnWorks that we used previously. So we'll select that, and we want to uncheck default output. So uncheck the null checkbox there next to default output. And after we do that, we want to hit that drop-down box that says occupied, and we want to change that to unoccupied. Okay, so we have the facets changed to range equals LawnWorks, the one that we went through the long process of finding, but we were able to quickly find it through the facet recall button or the facet history button. Uncheck the null box next to default output and change the default output to unoccupied. We can hit save, and then at the bottom of our screen here, we're going to go over to weekly schedule, and we're going to set up the date and time block, or the day and time block, and we're just doing 8 a.m. to 5 p.m. So pretty simple. So just find Monday or any day that you want to start it at, and just where about you think 8 a.m. is, and end it to where you think 8 and 5 is. Then you can just come down here into the event start time and the finish time. I kind of wish that this time range was a little bit more specific and was easier to easily see each hour. But you know, we have what it is. It is what it is at this point. So we're going to change the event start time to 8 a.m. If you didn't hit it on the nail. We change the finish time to 5 p.m. And we want to make sure that we change our event output here at the bottom left of our screen. We're going to change it from unoccupied to occupied. So 8 a.m. to 5 p.m. Monday through Friday. So we know we can do that pretty quickly by selecting the one we just created, right-clicking it, and apply Monday to Friday. Pretty simple, right? Just make sure that they all say occupied during that time slot, and that the default state is unoccupied at the top of our schedule here. So once we've done that, we'll go ahead and press save, and then we can go back to our wire sheet. And we have one last step to do, and that is just to link our enumerated schedule that we just created into our occupancy command. So what that's going to do is this occupancy schedule is going to dictate what the command is going to be. So it's going to link over to the occupancy command and tell it what which state we're going into. So from the out slot of our occupancy schedule, we're just going to tie that into in slot 16 of our occupancy command. And that's all there is to it. In the lab, it says that you should reorganize all of your different point blocks. You can do that if you wish. Really, all that I'm going to do is, move my outside air temp and my set points off to one side and have my occupancy schedule and command off to one side. That's about as far as you really need to take it, unless you want to be very specific and go through the steps and having it match. So that's up to you. So that's it for creating the first air handler. Before I let you guys go to work on the next one and take lunch, does anybody have any questions about what we just did? Okay, so it's the
Sorry.
same. Go ahead.
You want us to do the Distech or the Honeywell air handler?
Distech.
Okay.
You'll be skipping the Honeywell.
Okay.
Yeah, so the lab it says you'll be doing 3. We'll actually only be doing 2. So the next one we're going to be doing is the Distech. So you're going through the same process. You go to your palette window. You're going to go look up a specific lawn device template that you're going to add to your lawn network. And you're going to go through the exact same process that we just went through. You're going to add a points folder. You're going to do a discover, and then you're going to pick through the point names, looking for specific ones. Now the point names might be slightly different for the Distech controller, but ultimately it's the same process. Adding them to your database, renaming them, confirming the data types, adding facets, adding tags, and then doing this little step at the end as well. It might be slightly different, but ultimately it's the same process. Just double check your the device name. So for this one, it's Lawn Distech, and we're adding the Stat 100 device. Okay. Somebody have a question?
Yeah, Brandon, I had a quick question. Can you hear me?
Yeah, I can hear you.
Okay. I noticed I added the tags when I was creating the points, not afterwards. And I noticed your points in the wire sheet have the end tag group.
Yes.
And I noticed the note in the thing says when a tag group is added in this manner, the tags will be added as individual tags. Does that matter?
No, it doesn't matter. So
Okay.
this pops up. This I think it's a little bit of a bug, right? So if you add a tag by tag mode, a tag group by tag mode, you will not see this tag group slot. But if you add a point and then go back through and add a tag through the edit tag function, it creates this tag group on the point block.
Yeah, it's supposed to. What you see on the screen right there is the correct way. But depending, as Brandon said, depending on how you added it, if you added it if you add it as a group, after the fact, it does it this way, which is the way we want it to be. If you add it per the way the lab was written, it actually takes the group and breaks it up, and we don't intend for it to happen. And they don't want that to happen. They wasn't supposed to do it that way. They just found that out. So, and as far as the class goes, it's not a big hairy deal, but you may see a difference on one station to another because it all depends on how you added the tags. Either way is correct. As far as the class goes, it'll function properly either way, but it should be the way this is. But it's a little bit. We kind of realized that after we started teaching class, like, wait a minute. If I add it one way, it does one way. If I add another way, it looks another way. And as it turns out, it should look the same both ways. But matter of fact, I just talked to the programmer about that. I'm talking not about this. I'm talking about this earlier. So anyhow, so are they gonna are they gonna add the points?
So we just wrapped up air handler 1. They're
Yeah.
about to do a luncheon lab and adding the second air handler.
Okay. Yeah. Go ahead and do that. That'd be good.
All right, so any other questions? Okay, guys, so what you're going to be doing is going to the next section, starting with section D. You're going to be adding the next LAN device, which is the distech controller. You're going to be adding a stat 100 device from the palette. It'll be a different palette. It'll be a LAN distech palette. It'll be going through the same process. You'll be adding that device to your LAN network. You'll create a points folder. You'll do a discover. You'll scan in points, and you'll go through them and compare them to the table and add them to your database by either dragging and dropping them or selecting them and hitting the add button. You'll have to configure them. You'll have to give them a name. You have to double check, and that's the important part, double check the data type. Make sure that it is set to the correct data type that, per the table in the lab book. Because that's the important part. It's the only part we can't go back and change without having to re-add it. Go through and add the tags to them, and then the last steps are setting the fallback values to all your set points and pinning out some slots, and then the scheduled part. So ultimately, it's doing the whole step over again, just with another type of device template. So we're going to do that over the period of the next like hour and a half or so. And that's going to give you guys enough time to take lunch and complete this lab. So we will so we'll reconvene. What's that, 2:30? Or is that an hour? Okay. Yeah. All right. Yeah, because this is quite tedious. All right. Yeah. So we'll reconvene an hour and a half. So that'll be 3 o'clock Eastern. And after I get back from getting something to eat, you'll see my mouse moving, and I'll be going along and doing this this part of the lab as well. But I just won't be walking you guys through it. So you'll be completing this one at your own pace. And we'll be here if you need any help. Yeah, Damon will be here. I'm gonna be stepping out to grab something to eat, but he already ate early. But yeah, we're here if you need any assistance. All right, everybody. We should all be back or just about back from lunch and should have all finished the remainder section of that lab. Now, pretty much it was the same thing as what we had done through creating the first air handler. So you shouldn't really have had any issues. But I'm going to go ahead and take this time to see if anybody has any further questions about how we added the air handlers or lawn integration in general. Or at this time, if anybody has any questions or has had any trouble with the last little bit of that lab.
I'm just finishing up right now.
Okay. Yeah, go ahead and keep on wrapping that on up. We'll be jumping into the next bit here shortly.
I did have a
Uh,
quick question, Brandon.
Sure.
Or did you need to go? Go ahead. I'm sorry. If you had a question.
no, go ahead, go ahead, go ahead.
Can you elaborate a little bit on this that a new or the schedule when we were building that where we ended up with the weird functions and I'm not even sure what we were doing. I just kind of followed the instructions where you added the facet and you went in. I believe it was on the schedule
hmm
on the lawn where it's like a set that was already predetermined. Explain that to me again, 'cause I didn't quite get any of it.
Sure. So um, essentially what we were doing here is we were looking for enumeration. So enumeration is a collection of predetermined states, right? So we have occupied, unoccupied. We might have a standby or something like that, right? So what we're doing here is we were saying we needed to use a frozen enumerated range, but what that really is saying is we're going to use enumerated states that were contained within a module. So we're saying we were going to use a predetermined set of enumerated states from a module that exists within the software.
Got it.
So what we did after we checked that box, saying, "Hey, we're going to go use enumerated states that exists in a module somewhere in the software." And once we check this box, then we get this drop-down menu with all these different modules, and all these different modules have some sort of enumerated state within them. And that's when we had to go all the way down to the bottom to LawnWorks and find the LawnWorks lawn occupancy enumeration. And those were the set of enumerated states that we wanted to use. Now you can create those enumerated states yourself, or you can use, like we did here, use a predetermined enumerated states. But that's what we were doing. We're saying, hey, we want to use enumerated states that are contained within a module. And then we went to the LawnWorks module, and the module name was lawn occupancy enumeration, or enum.
Okay. So that basically saves you time from having to, and it's consistent because you're pulling the same one, so not you don't have to do the work again. Okay.
Yeah.
Uh, and then so that part makes sense. And then I had one more question. I think I got the answer to this, and you can clarify it as well. We were talking about the fact that it's if you had a separate lawn network for each line. So if you
Yep.
had a single MSTP line on the first floor and a separate line on the second floor, you would have to have you'd have LAN networks in your under devices for each floor essentially. Whereas in the backnet, you did the backnet network, and then every network would fall underneath there, just a different port. Am I
Correct.
understanding that right?
Yeah. So any additional line of communication or wired communication. Um, Now you might have an extensive wired communication for, like, let's say a LAN network, and it might span over multiple floors. But it's when you have a separate wired network separated
So,
from the initial one.
so then in our case where we have air handler 1 and air handler 2, so essentially those are the way we have it in our job or in our wire sheet,
hmm
our database rather, they're on the same wire. So regardless of, maybe you're on the roof and the first one's on the north side of the roof, and then the wire goes to the second one on the south side of the roof, but they're on the same network. Is
Yeah,
that what
yeah.
you're
So
saying?
they're on the
Okay.
same wired network. Just imagine that we have a from our panel, we've got an Ethernet cable or Cat5 cable or something like that running through the building. It goes from our panel up to the first one. Maybe it connects to, maybe we hit a switch or a router, probably switch. Let's say we hit a switch first at some point, and then we go into the air handler unit board. And then from there, either from the switch or from the air handler, we'd go to the next air handler. So it'll only be one line network.
Okay.
Now, if pretty much if you need an additional LAN module, expansion module on your Jace, that would require, for each additional module, you would need a separate network for that expansion module. If that kind of clears up a little bit.
That actually does. And then I got two more real quick ones. So this is
go
from
ahead.
yesterday, and I thought we would kind of figure it out as we went, but I still didn't get it. So the one of the question was, when we were bringing the points in, and this is, I now don't understand what I wrote here, but it says, why are there numeric values instead of numeric inputs? Whereas there were, I believe it was the temperature. So in Siemens world would have been an analog input, and we would call it an input. But here we're calling it a value when it was an input. So I was confused by that. And I know it's kind of simple, but I can't explain.
No, fine. So the best way I can explain that, so we had data types, and that's when we declared whether it was a writable or a point and which type it was. And then we have what's called an object identifier. So if I come back up here, let's open our VACnet real quick. MSTP points, and let's just look at this hot water pump 2 underscore status, right? Maybe this isn't the best.
Yeah, it would have to be that one.
Okay, Brandon, let me kind of jump in for a second because this is a little bit of the smoke and mirrors part of this class. On a real job, if you want a real job, that address might fall in line with what you're describing. But
Okay.
if I were to use like analog input in the lab, the point would not work right. I had to
Because
kind
it's
of
not a
fake
real
out
value.
to fake out the station. We had to make it analog value. So in the case of that data type, how we're doing that particular point, you really could probably wouldn't replicate that in the field. But because I tried going the direction you're talking about, the trouble is that the way I had that backnet controller set up, that if I went what really is how you do it in the field, the point would not work properly. So it was a big mess. So I said, well, just to get the numbers that look right, so visually you kind of know what's going on, let me do it this way. But you'd rely on the manufacturer's information and all that kind of fun stuff and set up the way they would say to do it. It's just a little bit different here to make the simulation work properly. But you are correct that probably it would not be analog value. It might be still like analog input or something like that.
And then I guess you would know if you put a sniffer on that BACnet device, it would tell you what was coming out of the device as.
Yeah, well, in general, what you do is you get the manufacturer's documentation, and that because they make the controller, they put the program in it, the base program of it, the core program, and then that tells you what it must be to actually work, no matter who you interface with, whether you take it to I could have an Allerton controller that I'm going to an Allerton front end, or I could be going to a Niagara front end or somebody else's front. It doesn't matter. But in the base controller, the manufacturer said I programmed it this way. It had to be analog value 6 and that type of thing. But in here, it was and it's a few things in the station that we're using that are to kind of support simulation. So it may not be exactly as I do in the field, but in general, like for the BACnet, we just want to show you how to add a BACnet network, how to configure a port, in general, how to add points and all. But when you get to your real job, it's going to have its own little twist to it as well.
Gotcha. Then my last one, and I know everybody else is ready to move on, so let me ask this last one.
Well, I was ready to move on 3 questions ago, but go ahead.
Oh my God! All right.
No, go ahead. We're just kidding. Go ahead.
So listen, he's not even paying attention to what's going on. He's in the back of the classroom watching.
I just thought I'd jump in real quick. No, go ahead. Go ahead.
The last one was when we were going through the schedules, I hit on the schedule and it says special event holiday, but it doesn't say specifically that holiday event I created was New Year's Day. So if I wanted to modify something, Easter or Christmas or a different holiday, when you look at that schedule, how do you know which holiday you got? We just did the one, but it didn't tell me which one I had. So I'd see holiday, but I don't know which of the 12 holidays that was. How do you see that or know that?
So that's when you would so you group up similar special events under the same calendar schedule or holiday schedule, if you will. So any holiday that would have the same output. So for example, let's just keep it simple. Any holiday that would have the building unoccupied, right? No
Hmm.
one's going to be in the building during Christmas or maybe even Easter or what have you. We would group all of those like holidays that would have an all-day event of shutting the building down or being unoccupied under the same calendar. So what that does is the calendar schedule looks at itself and says, "Oh, hey, it's December 25th. It's a holiday. I better go tell the schedule." And so it'll send it out to the schedule will reference the calendar and be like, "Oh, hey, it's the 25th. We're unoccupied today." And we're going to look at the parameters that we set, and I'll show you. Within our pump schedule. So we're looking at our special events here, and when a date falls upon the calendar schedule saying that, hey, we need to trigger an event here, the Boolean schedule is saying, oh, okay, well, what do we do on here on this day? And that's where we set this up right here on the right side,
Okay.
and we set the pumps to be off. So, I mean, we can adjust this. We can fine tune this the way we want to, but we're just, as an example, we're saying that it's an all day pumps off activity or event.
Okay.
So you would group all your similar events or holidays under the same calendar. Now, let's say that you had something like a calendar event for half days. So in that calendar, you would input all the days that you would foresee to have half days or upcoming half days within a building, or extended periods of activity within a building. And
So
then
would
you
it
can
be in a
configure what's
separate
going to happen when,
event?
yeah,
So under summary would be event, holiday, half day, like, and then you would have a
yeah,
whole
we
nother.
can name it whatever that
Okay.
suits your needs. It doesn't have to be holiday. We just named our calendar holiday because we put
Holiday.
New Year's Day in there. Um,
Okay.
so yeah, typically you wouldn't just group all your similar events into a similar calendar, so that when that day comes up, that date or time or date range comes up, and it reports it to a schedule. It doesn't matter, what day actually pops up or how many days it is when it does register an event from a reference of a calendar schedule. Try not to throw anybody off too much. Um, this is where we dictate what happens when that day, that reference comes up from the schedule. And that's how, if we have multiple calendar schedules, so we can have multiple. So we have holidays. Let's say we have a half day calendar. Let's say we have overtime calendar. Whatever. And
Gotcha.
each one has a different effect on the day. We can add multiple time blocks in here and adjust it as we need. But as long as one of those days comes up from the reference calendar, it's going to overwrite whatever what the schedule's trying to do, go to the special events, and it's going to output whatever parameter we have set for that calendar schedule reference for that day.
So is there a way to quickly see what days how do you open that event to see if you had it for multiple days where you could see what days? Hey, in February, what day are we going to be on a calendar or holiday schedule? Could you see that quickly?
Yeah, so if you actually look, so just having this holiday schedule reference, notice how we're on January
Uh-huh.
and the first is highlighted in green.
Ah, got it.
So just at
Okay.
a glance, we can see that we have an event. Now
Got
we're
it.
on the 25th here because this is the actual day that we're on now. So
Okay.
this blue square is saying, hey, today's the 25th. But at a glance, if we have a bunch of days set up or events set up, even in multiple schedules or calendars, when we highlight that calendar reference within the special events tab, we'll actually see little green squares on,
The
events
whole
that have,
year.
yeah.
Okay.
Hmm.
Okay, that answers it. Thanks.
Yeah, no problem.
I just had a quick question. So we're only doing air handler 1 and 2, correct? And then 3 is going to be something that we do at home.
No. So yes, you're right, but except for the last part. So we're doing air handlers 1 and 2. 3 is technically optional, but we're not doing 3. So we're just doing air handler 1 and 2. We stop at section G. Yeah. 3 is just the same. Air handler 3 is the same process we've already been doing.
Okay,
We haven't been doing that.
understandable.
Let me quickly expand. I want to go back to that ENM schedule for a second. There are two things specific about that part y'all were talking about. One is that any enumerated data type. Go ahead and double click on that schedule for a second. This is going to be important for Friday. And also, when you get in the field, it's important to know this. I didn't get this when I was in the field. When you do it, when you have any enumerated object, go to the properties tab for a second, Brandon. Notice if you zoom in for a second, look at his facets. Just do a zoom on there. Notice how the facet key is called range. Any enumerated point, the facet key that it uses has to be range because that sets up what it, what is he called the array. It sets up the array. It's like a table. And any enumerated object must reference a range as far as your facet keys. And where this becomes important is, let's say that you added the lawn schedule. In this case, it should be named it lawn, but you added the enumerated schedule, and all you're going to do is turn something off, turn something on. You cannot define true text, false text like you do in a Boolean schedule. Boolean schedule understands what true text, false text, does for the facet. Enumerated does not. So even if
Got
I'm
it.
just going to turn something off, something on, I cannot define true text, false text like in the Boolean schedule because this guy says, I don't know what true text, false text is. So you have to do that. So that's one thing that's important about any enumerated object. The facet key you must use is range. You may not use like true text, false text, units, whatever. It only recognizes that. And the reason that's important because where he's got unoccupied set up top, notice it's a drop down list. By defining range, it defines the drop down list. So if I would have set the facet to be true text equals on, false text equals off, there would be no drop down list because the
Got
enumerator
it.
says I don't know what you mean when you say two. I can't, so I can't function. So any enumerated point. This will happen on Friday because on Friday you're going to create a enumerated schedule in your test, and you're going to have to make sure that you set it up using the range facet key. Even though all you could do is say cut on and be on 8 to 5 off the rest of the time, you got to set it up that the facet key must be that. And the other thing that we talked about was the frozen enum range. What does that mean? Um, a lot of times manufacturers will you do an integration with their piece of equipment, and they may give you a piece of information that could be one of 45 different settings. So instead of having to manually build that table right there, they'll say, "I tell you what I do. Load my module in your station, and then I'm going to take and pre-build that range suit. So instead of you having to manually build it one entry at a time, just point to the pre-built range, and it saves you a lot of time. So maybe I could have a chiller, and the chiller has an alarm point. It tells me not just alarm, but it might tell me alarm chill water flow, condenser water flow. It may 15 different states it could be in. So instead of me having to manually create that table, they'll take and make the table and put it in a module, and you can just grab it, and it saves you a lot of time. But that's the purpose of the frozen enum. It just manufacturers said, look, to save you time, just go pick the range out, and I got you all set up.
Yeah, and that's what we did here. We
Yeah.
went and found a very basic lawn occupancy enumerated um, facets there for the schedule.
I had a question about for cool, changing
Mhm.
it over from a enum to Boolean.
Yep.
So how do you do that?
Sorry, what do you mean?
So when you make so when I made cool, when I pulled the points, I changed it from an enum to a Boolean, but it
Right.
didn't change for the true text for the facet. How did you change the facet to get it to read on true and false off?
Oh, yeah. So when you change it over, the default facet still kind of stays the same. So then you have to use that facet recall to change it over to the true false. So not all, and correct me if I'm wrong, but the facets aren't necessarily always data specific when it comes to like default values.
Not always. Sometimes what'll happen is that in the driver, and this all depends on how whoever the program was that wrote the driver for whatever you're doing. But typically, if it's an enum point, it's going to default to the range facet. If it's a Boolean, it's going to default to true text, false text. If it's a numerical, it's going to default to units. But it all depends on how the programmer programmed it.
Right.
But the nice thing is that when you like in our case here, I don't know why they do this. I've done a lot of lawn in the field, and I don't know why. I need to talk to a programmer who actually writes the lawn code of it. But I don't know. I don't know why. When I bring it in, it's going to come in possibly, for example, as an enumerated. and the manufacturer's literature says, all right, when you bring that particular snippet in, bring it in, change it to Boolean, and I'll tell you when the heat's on and off. So my question has always been, why don't we just bring it in as a Boolean? Why have I got to change it? But it's just something that you just see happen all the time. So it's important that you get the manufacturer's information, because not line itself is written completely different than what you're like looking at on the screen. It's if you had to look at the code, things are almost everything's an array. That's the thing about it. So it's real kind of strange how it works out. But because sometimes you can bring a point in and you can make it different data types and play with it in different ways. So sometimes it's kind of flexible as far as maybe you don't have to make it Boolean. Maybe you can leave it as numerical. Maybe you can leave it as enumerated. But you really got to be at the top of your game to know how to do those tricks. So typically what you do is you bring it in, you get the manufacturer's literature, and they say when you bring it in, make it enumerated, use this frozen enum list, and I'll show you the multiple states of thus and so, and you kind of follow their lead. But it's kind of weird that sometimes you got to do that. You'd like to think that you just bring it right in, but it's just kind of nature of what it is.
I might have an answer for that, I guess.
Yeah, please.
Like Schneider Lawn, I guess you only have a limited amount of snippets that you can use.
Hmm.
So a lot of times programmers will just use whatever available snippets they have. So they might be, I guess, in this pre-built data list, you might have it as an enumerated point, but you can use it as like a Boolean or numeric.
Yeah, that would make a lot of sense. I probably hadn't thought about that, but that makes a lot of sense.
And there's also the weird cases where you have to use like a sat percent or something like that for a temperature. So in Niagara, you can't really change it to a Fahrenheit, and you have to do some weird conversion because the point will just fault out if you try and change it from a percent to a temperature. I don't know, just weird things that you can do with Schneider controllers and on.
Well, when you bring it in, well, yeah, that's true too. But yeah, each manufacturer's got its own little nuance of how it works out. But one thing that is important you brought up is that let's say that the controller gives me temperature in Celsius. When I change my facet to Fahrenheit, it actually will convert it to a Fahrenheit. Because like in the lawn world, it's all metric. If you could look at a lawn controller, everything's Celsius. But I live in the good old US of A, and I want to see Fahrenheit. So when I change my facet to Fahrenheit, the station will display Fahrenheit for me. It converts it for me. Lot of different variations. And really, this is we teach you the basics of how it works, and then really you have to kind of get out in the field, beat on it for a while. Get with a mentor who's done a lot of it, talk to the factory, and eventually you start picking these little tidbits up.
Cool. All right, thanks for that. Does anybody have any other questions?
Hey, Brandon, I just had one quick one. I don't want to
Yeah, shoot.
dive deep into lawn, but is there a local the local node? Does that play into part, like when we're creating these points, are they like a mirrored network variable? You know what I'm talking about?
Yeah, under there, the local lawn device. What that really is, it's an object in your station that represents. When Brandon was talking earlier about you add when you have your JS8000, you add that lawn module to it, so it can actually you can physically hook a wire to it and come out. That module actually has a neuron chip on it. Neuron chip is the heart of your neuron device, and that actually is that guy. I actually double click that guy. Oh, you can't do it yet because you can't see it. But when you get in the JS, you'll see it actually has a neuron ID. So that's the local device. And there are things you can do with it. You can open up the LawnWorks module, and they have different types of objects you can do. You can actually take a value and shoot it out on the lawn network and whatever. It's some pretty neat stuff. So basically, local lawn device is a lawn device, like all of the lawn devices on the network. It's just the device is the little module that you add attached to the side of the JS8000. And there are some things you can do with it that you can do with any lawn controller.
Okay, but you're familiar with R2, right?
Vaguely,
Okay.
I took R2, got certified, used it for a month, and then 4 years later, I needed a job, and I took a piece of paper that said I'd passed the test and got a job. But
Okay.
and then I did take another class on it later on, but I'll try to see what I can come up with. What you got, real quick?
Well, it was just like anytime, if like in R2, if you created like an analog input, you would bind it like to the controller, like NVO sat to this analog input, and it created. You didn't see it, you didn't have to do anything with it, but there was this local node and you could see it, and every single point under a LAN network, you could see where it was going. Like basically, it was coming out as an NBO, but now it's like an NBI. And with Schneider's software now, you have to manually do that, which is a pain in the ass. So anytime when you take if anything that any NBOs or NBIs that you want to use in programming through Schneider stuff, you have to actually like pick them all and say create your network variable, and then it actually makes a new folder called local node, and then there's a folder structure underneath that. And so if you pick an NBI and create a mirrored network variable, then it becomes an NBO,
I see what
like
you're
the
saying.
same thing. You know what I mean? It's just, but
Yeah.
it seemed like Niagara always took care of that in the background, that you didn't have to do it, and I just didn't see it here. I didn't know whether
Yeah, I
it even
think they
comes into
do.
play.
I think they actually do. I haven't done a lot of it. Typically, you always just deal with the inputs and outputs of the controller itself. But yeah, there's some stuff built in. I toyed with it one time, but you can get real deep on it.
Cool. All right, good questions. Somebody have a question? All right, great question, guys. So we're gonna go ahead and move on. So the next two labs have to do with tagging. The first one's super short. It's a show and tell lab. So it's like what I like to call it. It's a show and tell lab. It takes about 5 to 8 minutes or so. And the lab's going to have you go to this quick search bar up here, which appears anytime you're working within your station itself. And you'll be able to do NQL query searches based on tags, and populate the the search window with all objects that have the set point tag and stuff like that. So it's going to show you a few different neat things like that. And then the second one is you're going to create your own custom tag dictionary. So we saw that we had the Niagara tag dictionary, and we have the haystack tag dictionary that we added. And then so that following lab, we're going to go through the process of creating our own custom tag dictionary. And that's a fairly short lab too. It takes about 15 to 20 minutes. So what I'm going to do is I'm going to give you the rundown, little slideshow kind of intro to tagging, the tagging basics, and how we use them at Niagara4, because I've been talking a little bit about tags here and there throughout the first day and a half or so. So now this kind of brings it home a little bit to explain to you what tags are, how they can be used, and then for the remainder of the week we'll still see tags come into play and how we can use them through various structures within Niagara. So what I'm going to do first is this little PowerPoint presentation. I'm going to give you a little bit of a rundown, which I kind of already have. The next two labs, you guys are going to do that on your own. Like I said, the first one, it's a show and tell lab. You're going to go look at different things and type stuff in the search bar, see what returns. It kind of just get you familiar with how that works. And then the following one is creating your own custom tag dictionary. So let me get this PowerPoint started up. All right, so tags. So we've seen a little bit about tags. We see how it comes into play with points and manually adding these tags into our points within our system. But what can we actually do with them, right? So upon completion of this session, you'll have general knowledge of the principles of tagging, how tagging is used in Niagara4, types of tags, tag dictionaries, definitions, groups, and relations. The difference between a direct and implied tag, NQL entity query language, and NQL syntax is the syntax that we use for searching different tags and returning elements using those tag definitions or those tag names. This is how it really starts coming into play with that metadata that we're applying to our system. So we can search for tag Niagara components. And we'll look a little bit about the haystack project, and that's has to do with the haystack tag dictionary that we've been using for the past day and a half or so. So tag basics, tagging is new to Niagara4. AX had some sort of offbeat version of tagging. It wasn't a standalone system. It was an adapted system that was applied to the AX, but tagging is an actual system within Niagara4. Used in 5 areas of Niagara4. So we can use it for searching for objects. We can use it to build hierarchies, and this is like an actual one of the powerful uses of tags. So if anybody's ever used hierarchies in Niagara4 or Workbench, you know that it can be very adaptive. So we can create this hierarchy scheme within the nav tree or within a web browser, depending on which view we're looking at here. And we can use that as kind of like an index or a navigation tool to go to certain components. And we can use tags to create those indexes within the hierarchy. And we can create tag rules and create them in a way to where we can adaptively add and remove components to be added to that hierarchy list simply just by adding or removing a tag to a component. So pretty nice there. Templates is one of those things that we don't have time to go over in this class. Templates are a very powerful tool, especially when you consider creating a new job and you have a large number of VAVs or equipment to create or to get going at one time. So templates are very powerful there, and we're going to look at a little bit of I mean, we're not going to. Sorry. We don't have time for the templates, but it's definitely one of those labs that if you find yourself you have extra time, even if it's outside of this class, definitely take a look at the template section. It's something that could save you. It's a powerful tool that could definitely save you a lot of time when setting up a project from the ground up. We also use tags in analytics. We have a whole separate class on analytics. It's more of an advanced class. It's looking at metadata and retrieving analytical data about an actual ongoing site, and it breaks it down into various different levels. And then we have graphics, and we have tags that do with graphics. That began with version 4.9, but we do not actually cover any graphic tagging in this class. So tagging is the process of adding metadata to components. And metadata is data about data and how we use that. So basically metadata is characteristics of an object. For example, a point representing a hot water pump is a pump, pumps hot water, is used for heating, has a motor, and is a piece of equipment. Now, if you remember back to the beginning of the week, or at least yesterday, how I told you that metadata is commonly used when doing Google searches. So if you've ever been on the internet, which all of us have, and you've used Google to look something up. Now, what Google does is it takes keywords or phrases and returns a result of websites that have anything to do with what we typed in the search bar. Now, how does it find those websites? Well, it takes the words that we put into the Google search, and any website that has those metadata that has to do with what we search in that bar will be returned. Now, there's other things involved with that and determining which sites show up first and in order and all that other stuff. But the basics of it is if I'm looking up how to put together something, I don't know, like let's just keep it simple. How I want to learn how to bake an apple pie, right, on Google. If I type those keywords in, what it's going to do is it's going to look metadata for websites with that metadata referring to apple pie, baking, maybe how to, tags like that, and that's what's going to help formulate the return result when I go to do a Google search. And we can use that in Niagara4 as well. And this is why we go through the process of adding all these tags to most of these points throughout this last day and a half. So now later we can come back through and use that data for whatever purpose we might need for it, whether it be looking up specific components within our system or using those tags to create a hierarchy index. We'll look at a couple different ways that we can use, basic ways we can use tagging. So the tag dictionary. So tags are contained in the tag dictionaries. Niagara4 dictionary is I think I'm getting ahead of myself there. So in the same way the words we use are contained in dictionaries, tags are contained in tag dictionaries. So tag dictionaries also contain tag groups, tag rules, and relations. We'll go over those in just a bit. The Niagara Tag Dictionary is pre-installed in every Niagara station. It's already pre-installed into the services in every station that you create. It cannot be deleted or edited. It automatically assigns certain tags to certain components. The Haystack Tag Dictionary, however, can be added to the Niagara station. Every instance of Niagara4 has the Haystack Tag Dictionary contained within the palette library. So every version of Niagara4 has the Haystack Tag Dictionary available, but we have to install it into our station ourselves, like we did for the beginning of the integration labs yesterday. We looked up the Haystack Tag Dictionary, we opened up that Smart Relations folder, and we dragged that Haystack Tag Dictionary into our Tag Dictionary service. So it's there for us, we just have to add it to our station ourselves. It cannot be edited, and automatically assign certain tags to certain components, just like the Niagara Tag Dictionary does. And then there's also the Analytic Tag Dictionary, which we don't use in this class, but it's included in the analytics service and is added to a station. So this is something we go over in the analytics class. If you ever find yourself in there, we will add an analytics service into our station, and the Analytic Tag Dictionary is added automatically. It can be edited, and tags can be added to it. You can also create your own custom dictionary, which you all will be doing here in the next lab or so. And you can edit and copy from one station to another. So you can create your own custom tag dictionary that you can take with you, to your company PC or a thumb drive, and plug and play with that with each new project that you start up, or what have you. So tag dictionaries are identified by their namespace. And what that means is the namespace. So if we'll see that in the upcoming lab, but if you had noticed the tags that we had been adding manually to our points, they all started with an HS colon and then whatever tag name we had it was. That's the namespace, that HS colon. So that stands for haystack. And anything that has to do with a Niagara tag is an N colon. So the namespace for Niagara tags are N colon. And so when we create our own custom tag dictionary, our namespace will actually be C colon, so like C for custom. So we have different types of tags. There are two basic types of tags. One's the marker tag. That's the most common tag that we've seen. 99% of the tags that we've added or seen so far have all been marker tags. There's simple tags that just say it's fan, air handler, HU, heat, cool. Those are all marker tags. And then we have value tags, and that's that area tag that we had seen when creating our Modbus, that power meter. That area that we set to 10,000. And all its real purpose is to set a value to that value tag, whatever reason or purpose that you would set, a value tag to a point. Kind of depends on what type of value tag you're adding to it. So value tags can contain strings, integers, longs, floats, doubles, etc. So assigning tags and tagging, you add or assign tags to components can be added in various ways. Can be added manually or automatically. So far, we've seen two different ways that we can add them manually. We haven't really seen how to add them automatically just yet. When a tag is manually added to a component, it is known as a direct tag. So if you remember back when we went to the edit tag window and we went through and either removed or added individual tags to a component, there was two tabs towards the bottom of the window. The first one being on the left that was open automatically was direct tags. And that refers to any tags that we add to that component manually by either the edit tag function or the tag mode. All these tags will be added to that component under the direct tag tab. A slot is added to a component when a direct tag is added. When a tag is automatically added to a component, it is known as an implied tag. So if we think back to that edit tag window, we have the direct tag tab at the bottom, but there's also a tab called implied tags. And this will contain any tags assigned to the component automatically. And it can be assigned to a component automatically by either a tag rule or tag relations. So a slot is not added to a component when an implied tag is added. Implied tags are added via tag groups or tag rules. Tag groups are essentially a group of tags that can be added to a component in one step. We've seen this with our outside air temperature sensor or our zone air temperature sensor group tags that we added to our temperature sensor points in either of our devices that we added. And when we applied the zone air temp sensor tag, for example, it was a collection of tags that were added to it, such as zone, air, temp, and sensor, right? But that's how that works. So it's a collection of tags contained within a group. When we apply the group, it applies those individual tags to the component. When a tag group is assigned to a component, the tags in the group are implied to the component via the tag group. Tag groups are dynamic in that a component relates to a tag group, so that as the tag group is edited, such as adding or removing tags from the group, the tags are also added or removed from the component. So what that means is we can assign a tag group to something, even considering, let's say we make a custom tag group. And anytime we add or remove individual tags within our custom tag group that we've created, it will reflect on all the components that we've assigned that tag group to. The advantage of tag groups is that they can be assigned to many components, and as the tag group is edited, all the components that have the tag group assigned are modified as well. So tag rules. Tag rules are routines that run and automatically assign or imply tags to components. This is what makes tagging much easier. So if we took the start of a job or a project, and we took the time to go and write a bunch of tag rules before even integrating and adding devices and components, having considered that we probably planned ahead of time, what we know what the tags are going to be and what they would be assigned to. Based on the tag rules that we write, any component that we add to our system or our project, if they meet one of the conditions that we set in a tag rule, a tag will automatically be assigned to it. So for example, and we'll see this, if we write a tag group that looks for anything that has a namespace of set point, but spelt like a certain way, like we did in our labs here, we spelled it as SETPT. Maybe that can be one of the conditions that need to be met. And we can set several rules within that rule, that tag rule, to determine which component gets that tag. So for example, we say anything that has a namespace of set point, SETPT, maybe it also needs to be a numeric writable. And maybe it needs to be contained, if we want to define it even further, needs to be within the BACnet driver or something, or BACnet network. So any set point item that we create with the namespace set point in it, it's also numeric writable and is contained within the BACnet network, would get the set point tag automatically applied to it based on the rule that we create. Kind of give you an idea how that works in a nutshell. So can be considered as if they are running continuously. So the custom tag, the tag rules are looking for any conditions that are met to be, to apply their tag to it. Have conditions that must be met by a component, kind of like what I just described earlier. If a component satisfies the conditions in a tag rule, the tags in the tag rule are implied to that component, much the same as a tag group implies tags. So the Niagara Tag Dictionary and the Haystack Tag Dictionary have tag rules that will run and imply tags to components when the dictionary is added to the station. Tag rules are extremely forgiving. So we'll see various uses of the implied tags through the next two labs. The lab kind of points out the various different types of tags that are added or implied to various components. But either way, when writing our own tag rules, tags are very forgiving. They do not impact our a system or station whatsoever. What that means is we can write a tag rule if we didn't get it quite right or didn't work out the way we want it to be, or apply the appropriate tags to the way we wanted. We can simply go in and rewrite that rule or fix that rule, edit that rule, what have you, and try again and see if that works. Or maybe we wrote a rule and applied that tag to too many components that we didn't necessarily want to have that rule. Now those components that obtain that rule, it doesn't affect them, it doesn't hurt them, it doesn't change the way they operate. And when we go back to change that rule or edit that rule to make it work within the parameters that we want, any tag that we didn't mean, or any component that we didn't mean to get that tag, when we change the rules to exclude those points, that tag will then be removed from the points we didn't have intentions of adding that tag to, if that makes sense. So tags are very forgiving. They're very fluid. So if a tag rule is not written correctly, again, it can be corrected and it will be updated and fix any tags that was not implied or tag that should have been implied. So relations are a little bit different. We don't see a lot of tag relations in this class, but relations are logical relations between components. So like links, but unlike links that link the slot of a component to a slot of another component, like we did on our logic. Relations make a logical link from one component to another component. Relations can be manually added or can be automatically added by tag dictionaries. Mainly used in hierarchies to make navigation through stations easier for the novice user. So then we have NQL. What is NQL? NQL is the Niagara entity query language. NQL is the syntax of tagging used whenever a station is using tags. Relatively simple programming language. And NQL provides a simple mechanism for querying tagged entities in a Niagara application. Query filters on markers and value tags. We can primary use of NQL include the search service and hierarchies. So searching using tags, we use NQL to search for various tags within our system. Search by entering dictionary namespace and tag. So if we were looking for a specific tag up in that search bar at the top right of our workbench, like I pointed a little bit earlier, but you'll see in the next lab, we have to include the namespace as well as the tag name of what we're looking for. So for example, if we're looking for the set point tag contained within the haystack tag dictionary, we would have to type in the search bar or wherever HS:SP, which is the set point tag within the haystack tag dictionary. Can use logical and mathematical functions, meaning we can use and or mathematical functions. That's what it means. So we can look up multiple tags that have either or of multiple tags. So for example, if I wanted to do a search, I want to find anything that has the haystack set point tag or has the, I don't know, let's say Niagara or Niagara set point tag, if such as existed. The result would show any tag that had either the haystack set point tag or the Niagara set point tag in my list. But if I use a function such as and, it would look through and require that it had both one set point as well as another, one tag as well as another tag. So for example, if we were looking for an air handler fan, let's say we had a fan tag on it and air handler tag on it, we can do a search saying, hey, we're looking for anything that has a haystack tag of fan and a haystack tag of air handler. And then it will only show fans that belong to air handlers in our system. So how to do a quick search up in that field editor, kind of is located in the top of the workbench menu. It allows somebody to query against the search service in the station. Results are displayed by loading the search service view in the main window. So that's in our view window. So how to use the search service, this kind of gives you a glimpse of going into typing a namespace as well as a tag within the search bar there. And it also shows you what would return. We can see various types of information and points here. The one thing that we aren't on, the one thing that we cannot do with the search tool is, let's say, searching for set points. Let's say we're looking up all the set points for our hot water system or our air handler. One thing that we unfortunately cannot do is edit those set points from this search list. That'd be kind of nice, but there's a different tool out there that allow us to do that. We have different tools that allow us to do things like that. One of which being is the batch editor, which we will see tomorrow. But for as far as tag searching, we have limited use of what we can actually do with that return data. But yeah, the pencil icon opens a compact field editor such as a circular gauge widget. The chart icon opens web chart view. So most of this search function is visual, mostly visual data collection type of searches. So real quickly, what is Project Haystack? It's an open source initiative to streamline working with data from the Internet of Things. Project specifications include a data modeling dictionary, which defines the tag taxonomy for building systems such as networks, energy, HVAC, and electrical distributions. Niagara4 includes a Haystack tag dictionary, which can be used to apply data modeling to Niagara4 applications. We've done a little bit of that so far. We added the Haystack tag dictionary. We've added those various tags from that dictionary into our project. So lab 11, we are going to apply individual tags to Niagara components, distinguish between direct tags and implied tags, apply multiple tags to a component with a tag group, and list tag components within search query. I think that's it. Yeah. So we're going to be doing the next 2 labs over the next, shoot, oh my goodness, it's almost 4 o'clock already. This really shouldn't take any longer than 30 minutes. Some of you, it might take a little bit longer depending on how long you take, looking at lab 11 and how long it might take you to get through lab 12. The good thing is both of these labs are what we call, or what I call, show and tell labs. They're not impactful to what we're doing for our stations for this week. And the content that we derive from these labs aren't as impactful for the test as either. So let's go ahead and start lab 11, and then get into lab 12. Do as much as you can within the next 30 minutes or so, because about 4:30 is when I want to, if we can, get into graphics, because graphics is going to be taking the next largest amount of chunk of our time, and whatever we do not get through for graphics this evening will be extra work for this evening, and I want to limit that as much as possible for you guys, because I know y'all had quite a bit to do yesterday evening. So go ahead and start labs 11 and 12, and about 4:30 we're going to come back and do a quick little review. And if you don't finish all of it, that's okay. You'll have time to come back to that later at some point. We have some free time. So we'll reconvene at 4:30 Eastern. All right, guys, it's a little after 4:30. If you haven't finished Lab 11, that's fine. If you find some time later on and you want to go back and finish that, you're more than welcome to. And this is a good opportunity to kind of share with you guys that we show you all a lot more information and how to do things than is actually going to be on the test. So if at any point during this week so far you felt just completely overwhelmed by the amount of knowledge that we're throwing at you, um, just know that we only expect you to recreate or show us a fraction of what we've taught you so far this week, what we taught you this week. So tagging's being one of them. Tagging's is a very useful and can be a very powerful tool. Some people choose to completely just disregard tagging, and that's their choice. But it is throwing away quite the utility that could save you a lot of time. It's very useful in other aspects of Niagara4 Workbench, whether we're using it as a search tool, as our own little mini search engine inside of Niagara4, or if we're using it to create hierarchies, which we will see next week, or not next week, tomorrow. That's where you really kind of see the power of tagging, or one of the instances where you kind of see the power of tagging. If any of you ever make it to take the analytics class, then you really start seeing tags and work. Tags are kind of like the main event within the analytics course. It's really how you use metadata to your advantage. It's not just used for just a searching tool like we've seen in this past lab or so. So if you're going through this lab and you're like, oh man, this is kind of a waste of time, I'm not going to use this. I promise you, it has way more uses than just using it as a searching tool. And unfortunately, we just don't have enough time in this, accelerated, condensed certification course to really show you all the bells and whistles that you can do on the technician level. So we cram as much in here as we possibly can, show you the highlights as much as we can. We're always still refining the course, trying to make it better, more intuitive. So yeah, so you guys went through and looked at different ways to look up various tags, look at different namespaces, the difference between direct and implied tags, how Niagara how tag rules apply implied rules or tags to various objects or in components. And then lab 11, you created your own custom dictionary, which can be very useful. And you, if you got far enough into it, you could see how you could create tag rules and add other tags from other dictionaries into your custom tag dictionary to really use it in the way that you want. If you really sat down and spent some time and create your own tag dictionary, you could create something that you could carry with you, especially if you're a technician or if you're doing installation or anything like that. You could take it with you from project to project and upload it into your system that you're creating, and really streamline, especially if you take a lot of time to create various tag rules and keep things consistent when creating your project as far as like namespaces or how you go about applying and adding things to your system, to have your tag rules automatically apply those tags. Yeah. So without going too far into it, does anybody have any quick questions about tags? Because we will see some more about tagging later this week. So tomorrow and a little bit Thursday, and how we can use them in other systems within Niagara4. This lab and these two labs were really just showing you some of the basics, saying, hey, this is what tags are. This is kind of just a hint of what we can do with tags. Okay. So what we're going to do is we're going to go ahead and just keep on going. I know it's been a long day. Still got a lot more material to cover today. We're still doing okay on time. But I really want to jump into the next bit, because what I'm going to introduce to you is the probably more entertaining side of the class, which everybody tends to enjoy. It is the graphics lab. So if you've never created graphics on any sort of platform or Niagara itself, the workbench itself, you're in for a little bit of a treat. You can kind of let your creative side come out a little bit. Now, there's some things to keep in mind as far as graphics go. There's some rules in place. There's certain ways we have to do certain things to set up graphics. So we're going to go over some of those basics here in this slideshow coming up. And then I'm going to go through Lab 13 with you if you haven't already. It's pretty short. We're going to create a little header graphic that we're going to be able to insert into our other graphics when we create graphics for our heat pumps and our boiler and our air handlers. There's the next several labs that we're going to be doing for the rest of the evening up until tomorrow morning. And I will give you guys some time in the morning. Wednesday morning, we usually give you guys an extra hour in the morning. We actually start class about 10 o'clock. We give you some extra time to get the graphics because it is a lot of work. It's not hard work. It's just a lot of tedious work building these graphics, but it's fun work. So you won't complain as much as you did probably last night. So yeah, we give you an extra hour tomorrow morning to get through all this stuff. That's why I like to try to get to Lab 13 as soon as possible to give you guys the most efficient amount of time possible. So like I said, I'm going to go through Lab 13 with you all, and then I'm going to give you guys some tips and tricks before I let you guys take off if you haven't already. I know some of you guys had just started working on the header. That's fine. If you're comfortable with the system, you already kind of have an understanding of it. That's fine. Might ask you just to take a pause, get your attention for this little introduction, and then I'll call for your attention again at some point this afternoon to show you a few things that you need to keep in mind, because there's a couple pitfalls that I'm going to try to prevent you guys from falling into that tend to happen when working with graphics. So let me launch this little doodad right here. Make sure I'm recording. I am. All right, creating PX views. So the objectives. So upon completion of this session, you will have a general knowledge of creating a graphic file known as PX file. What is a presentation XML? That's what PX file stands for. Editing a PX file in Workbench. Understanding what is a PX view. Creating a PX file to be embedded in another PX file. That's what we're going to do when we create our header in Lab 13. It's going to be kind of like a title bar. We're going to embed that into other PX files. Understanding different panes, understanding palettes, understanding widgets, and understanding bound and unbound labels. That's one of a big kicker there in the graphics, understanding the difference between those two. So graphic basics. Graphics in Niagara 4 are referred to as PX. PX stands for Presentation XML. XML is a markup language. Niagara 4 has a graphic editing tool. No need to build graphics in another program, then bring them into Niagara. So if any of you have experience with other systems, I can say I have myself, and I remember using other systems or other third-party software to create my graphics and then embed or import those graphics that I created into the different engineering systems that I've worked with in the past. But there's no need for that in Niagara 4. We have an built-in graphic editing tool. Not only can we use the various graphic items that we have available to us in our palette, various different graphic palettes, but we can also import graphic items as well, individual graphic items or graphic files as well, to further expand our graphic library there. So it's very flexible. Can build one graphic and use it for many typical systems. We'll see that when we create our air handler graphics for this class. On a graphic, you can view information, override points, edit point information such as schedule, hyperlink, so create hyperlinks or buttons to other graphics, and many other options. So the graphic basics, several built-in sets of graphic images in palettes. So we've used palettes quite a bit so far when pretty much integrating, creating points, creating logic, and so forth. And we're going to continue in that fashion and use various different palettes, primarily two different palettes to add different graphic items. And there's going to be two major ways that we're going to extract these graphic items from our palettes. Not all of it's going to be drag and drop from the palette into our PX view. So some of these need to be added in a particular way, but we'll look at that. So we can use other images such as GIF or GIF, JPEGs, PNGs, SVGs, and so forth. So new to Niagara4 are the HTML5 graphics. Make graphics accessible via browser, tablet, smartphone, etc. So whatever PX views that we create and graphics whatsoever, what have you, we can view via a browser or smart tablet when we log into our system in one of those two methods, or various methods rather. Can also use graphic widgets that require plugins. Now, back in AX, we required plugins for various different types of graphics. We don't plugins aren't required any longer for Niagara4 graphics, or not required for Niagara4 graphics. But if for any reason you needed to use something that required a plugin, we can, that is also possible. That's kind of a niche use of whatever that might be. So what is PX? PX stands for Presentation XML. XML is a markup language, similar to something like HTML, CS, or what have you. So an XML-based file format used to define a Niagara presentation containing all the information, control parameters, and design attributes needed to display the graphic. So much like we've done with other elements from the palette, a lot of it is drag and drop. And the drag and drop items that we use actually have a file or multiple files tied to that item. And all of this XML-based format is all done in the background. It's already predefined, and any adjustments that we make to the object itself, the graphic item. So, for example, if we have a fan, a fan graphic that we added, it's going to have it's going to have an XML based file attached to it, and any adjustments that we make to that fan, whether it changes states or if we make it bigger, smaller, change any value within it, that's going to reflect in the XML file, and that will be done automatically in the file in the background. So there's no need for us to go through and edit the XML file itself. It'll be done by the software, and it'll reflect any changes that we do. Now, this is as a niche, a nice thing to have for any niche uses. So let's say, for example, this is also used for an entire graphic or PX that we create. So let's say that we added some graphics or we made some changes, and now something in our graphics don't work like it's supposed to. Maybe it's crashed, maybe nothing's working at all, but we know it had to do something with the last coil that we added to the graphics that we were creating, but we can't see the graphic anymore because it's crashed and it keeps crashing, and we can't get to it to delete that stupid coil that's preventing our graphics to show up. Here is where we can get a little bit more advanced, and if we need to, we can go dive into the file system of the software, find the XML file for that PX view, go into it, and if with a fine tooth comb we could go through and actually find maybe the image that represents the coil that we added, the block of code that is the coil that we added that's maybe corrupting our graphic item there, and we can delete that bit of code, save the file, exit out of it, and potentially load our PX view back up, and our graphic may or may not be working again. So that's a little thing that you could do if you ever run into that issue. So how to create a PX view and PX file. So a PX view is basically a shortcut assigned to a component that, when the component is double clicked, will open a PX file. To create a PX file, select the component, right click and select views, then new view. So that's what we're going to do. So as we've seen with some of the different components within our system, when we double click certain components, it has a default view. So for example, when we double click our points folder that we created for each of our devices, our default view is always the point manager view for the point folder, right? But if we assign a PX view to that folder, that points folder, the new default view will be the PX view, will be the graphic. So any component that you add a PX view to, the PX view becomes the new default view for that component. But when you create a PX view on a component, it not only creates the PX view for you to add, edit, and view the graphic itself in the file system or the file space within the station, which I'll show you in just a bit. It also creates a PX file, and this is where all this data is saved. So how to edit a PX file? So we would go into the PX editor view. Now this looks a little bit different because this is the lucid style of Workbench, but ultimately it's the same thing. So if we have the PX view added to, let's say, one of our points folders, we would double click the points folder after we've added the PX view to it, and it'll default to the PX view. Now there's two different modes to the PX view. There's the PX view mode, and then there's the PX editor mode. And there'll be an icon on the toolbar, which I'll show you in just a bit, that will enable us to go into the edit mode or go back into view mode. A little side note there, anytime we click that pencil to go from edit mode to view mode, it actually saves our graphics. That's how we save the graphics that we've been working on in the PX view. So yeah, so there more or less we're going to see more how to better do this, how to create graphics or edit a PX file when we actually get into the labs. It's kind of hard to explain, but more or less we can either drag certain items from our palette into our PX editor view, and that'll create a graphic item. Or if it's what's called a bound item, we can drag that out of one of our components, such as our driver. So let's say we're going to drag a fan component onto our graphic because we want to make a fan graphic, and so that therefore we're making a bound graphic. This is two ways. It depends on what we're trying to accomplish here. It's either dragging a component that we want to make a graphic item for, out of the nav tree into the PX editor, or if we're dragging some sort of static image or predefined graphic image out of the palette onto the PX editor. But in doing so, usually when we're dragging it out of the nav file or the nav tree system, we will have what's called a make widget wizard. So let's say I'd grab that fan point out of my air handler and dragged it into the PX editor view. When I drag and drop that into my PX editor view, I will be prompted with this make widget wizard, that little tongue twister box there. And from there, I have various different options. We'll see more in depth how each of these options will work for us. But for example, if we look at the top section of this Make Widget Wizard, we can see the From Palette option. And this will be key for when we're trying to bind an object in our nav tree within our system to an object that exists within a palette. So that goes ahead. It's a process of binding our data from that object to the or data from that component to the graphic object that we're tying it to. So for example, if we want our fan to animate anytime the fan status changes to on or the fan cuts on, we'd have to bind our fan to that graphic component or object in order to do that. So if we say from palette, we'll then be able to select which palette we're looking in and which item we want to tie that to. So what is the intended result of the lab exercise? For lab 13, this is ultimately what your header is going to look like, minus a few things, or it's neglecting to show a few things. One of the things that we're going to have here is a title of whatever PX view that this header is going to belong to. So we're going to preemptively, or not preemptively, but we're going to create some sort of like header title, and we're going to keep it what's called an open ordinance or open ord for it. open binding, so that every header that we add to an individual graphic that we create from this lab onward, it'll show which graphic we're looking at. So if we're looking at our heat pump graphic, our header is going to say heat pump IO. If we're looking at our boiler graphic, our title is going to say boiler control underscore IO, or whatever the title is for that. And then we have the log off button, and we have a little something that's going to show what the current user is logged in, which will be more beneficial later when we get into user and security and we create different users. We can see who's currently logged in and stuff like that. So lab exercise 13, we're going to do this one together. It's a lot of useful information that I'm going to throw out at you guys if you've never worked with graphics within Workbench before. A lot of it's going to be, some of it's going to be a little trivial for the more experienced. So if this is something that you already are familiar with, you're welcome to go ahead and move ahead. But I recommend that for the majority of you to work alongside with me so I can show you the important bits before releasing you to work on your own. So to start, make sure you get to your lab exercise book and open up lab number 13. And at the top of lab 13, you kind of get an idea. This shows you a little snapshot of what we're going to be creating here. So there's a little bit of setup that we need to do. So what we want to do is open up. So for me, I need to log back into my station. So I can do that by double clicking my station. It's going to prompt me to log in. Okay. So now that I'm logged back into my station, I'm going to expand my station. I'm going to expand config. And with my config module open, I need to right click my config module, and I'm going to create a new folder inside of it. So within your station, expand your station, expand config. So you should see services, drivers, apps just under config. We want to highlight config, and we want to right click it. And we want to, from the right click menu, go to the third option of new and select folder. So we're creating a new folder under config. And when we do that and we select OK, or we click it, it's going to prompt us to name the folder that we're creating. And what we're going to name this is header. So this is just going to be the folder that contains the header PX view that we're creating here. So go ahead and create the folder called header under config. And once you do that, you should see the header appear under the config. So we show at the very bottom of the config, just under apps. So now that we have a folder to attach a PX view to, we always need some sort of component to attach a PX view to. You can attach a PX view to almost just about anything. Whether you'd want to or not, it's completely up to what you're trying to accomplish there. But for this, so to create a new PX view, all we need to do is select our header folder that we just created under config. We want to right click our header folder. We want to come up to new, or views actually. Right click our header folder, go up to view, and there should be an option to select new view about 3/4 of the way down the list there. And creating a new view is how you create a new PX view. So select new view. You only need to do this once, per component that you're adding a PX view to. It is possible to add multiple PX views to a component. This gets to be tricky because sometimes your component doesn't know which PX view you want to look at, and we actually have to go in, and this can cause problems. We'll have to go in and delete the extra slots that were created for the PX view, the additional PX views that were added. So we only want to do this once per component we're adding a PX view to. So we right-clicked our header folder, we selected views, and then new view, and we have this little bit of information here, and the only thing that we really want to concern ourselves with is what we're going to name this PX view. And what we're going to name this PX view is header PX. So currently it says graphic, we want to change that to header px, just like that, in the view name. Okay. So header px. And once we have that, we're going to go ahead and just hit OK. Now it should redirect us to the new px view that we just created. So this is what's called the px editor view. We know that we're in the px editor view based by the grid in the background here. So this is how you can kind of tell between whether you're in view mode or edit mode. And bring your attention to the top here, the toolbar here. There's this what's this little pencil icon? It's called the toggle view. So toggle view in edit mode. What this does is it changes between edit mode and view mode. And if we go from edit mode to view mode, we save our PX view. This is the way that we save our PX file or view. So any changes that we've made is not saved until we change or until we hit this pencil icon to save it. Now there's another way to do it, but this is the only way that you really need to concern yourself about because this is the easiest. So switching between view mode and edit mode. So again, when we go from edit mode to view mode, it saves our work. Now, something to keep in mind here, and I just kind of want to throw this out here because this is important. Now, let's say I've got a fully designed graphic here, or I've gone and done a bunch of work here, and I saved it. And then I come back and I go to edit mode. And let's say I mixed a bunch of stuff around and deleted some stuff, and I didn't really like it, but I accidentally hit that view mode. Or before I hit the view mode or the save, any changes that I make within my PX editor view, I can select I can either do edit undo. What the heck that was? Something just fell in the classroom. So we can do an edit undo to any changes that we've made within our PX editor view. We can also, there's this undo button up here next to the pencil icon. We have an undo and a redo arrows. Oh, we're under attack by geese, apparently. One of them ran into the window outside. So yeah, so we have this edit, we have this undo and redo button up here. So as long as we stay in edit mode, we can undo and redo anything that just about anything that we can do up to an extent. So I think there's only so many undos or redos we can go back to. But if we deleted a huge section of our graphics or deleted something important, we could, as long as we don't switch the view or save the graphic, we can undo that change. Now, if I did a bunch of work and I deleted something or messed some stuff around and decided I didn't really like it, but I went ahead and saved it, went to view mode, I can no longer use the undo or redo function for what I just changed before I hit save. So if I do that, now keep that in mind. So if you're ever on an existing site and you're playing around with something that's already got graphics on it, finished graphics, and you're just like, oh, I'm just going to play around with it and see, what I can do with it. Keep in mind, anything you change can be undone. Just about anything you can do can be, undone until you hit save. Once you hit save, there's no undoing it. You're going to have to piece it back together yourself or recreate the graphics or revert to a backup that was created for the station. So keep that in mind. Keep that in mind while you're working. Also to save, because the PX editor view does not have an autosave. So we have to actually physically save our work every so often to make sure that we don't lose progress. Again, technology is finicky, computers are finicky. Every once in a while, something may happen. Your computer might crash, Workbench might crash, something might happen. You might lose your work. So get in the habit of saving every 15 to 30 minutes, especially when you're working on time, strenuous things like working on graphics, right? Put a lot of work and effort into it for an hour and a half or so. and you hadn't saved it quite yet. You get up for a minute and you come back and Workbench crashed and didn't save anything, and you just lost an hour and a half of work, right? So do the due diligence. Make sure you save every 15 or so, 15 to 30 minutes, right? Anytime you accomplish something new, something big and new on your graphic, a mile marker, go ahead and save it. All right. So we got that. And that's switching in and out of edit and view mode. That's how we save. That's how we can undo any mistakes that we make, as long as we do that before we save. So next, we've got the PX editor view. One more thing I want to show you, and I'll bring your attention again to it before the day's over, because this will happen to somebody. It always happens to somebody. So we created this PX view, right? And it also said that it creates a PX file, right? Well, where does that file exist? So if we look in our nav tree here, under config, it doesn't belong under config, but if we collapse config, we can see that we have a module called files. If we expand files, we can see that this folder called PX exists here. Now, before we created this PX view for the first time, no such folder existed. The files module existed, but nothing existed within the files module, at least that we can see at the current moment, until we created our first PX view. When doing this, a PX folder is created, and if we expand that PX folder, we can see our header PX file created into this PX folder. So any changes, so anything that we do within the PX editor, now we want to, a best practice, at least for this class, we want to work on being a good habit of working on our graphics within the PX view of the component that we added the PX view to. Now, it is possible to edit and work on our graphics within the PX file itself. Any changes and anything we do within our PX view saves back to the PX file. Now, this is where things get a little tricky, and it's not really going to make a whole lot of sense until we get further along after Lab 13. The first couple of steps of Lab 14 is usually where people slip up. So there's what's called open bindings. And these open bindings retrieve certain information that are privy to the component that it's housed into. So for example, what you'll find out is date and time, or a title for something, or what the current user is currently logged into our system, which we know is right now should be admin. All this information is contained within the config space, the config module. That information is not contained within our file module. So there will be some graphic items that we create that are open binding. They're very specific, looking for specific information that might not be contained within the file space if it doesn't have a direct binding. Now, some of this may sound confusing to you. It'll make more sense in just a bit, but maybe for more advanced people might understand this a little bit better. So if I make a binding to something, an open binding to something, this that it doesn't have a reference, that component or module doesn't have a reference to, it won't be able to retrieve that information. So therefore our graphic will show up as blank. Our graphic item will show up as blank. So we're going to go through this whole header process, and some of these items that we're going to add to our header are going to be open bound, or open, like the or it's going to be, I'll describe it better in a little bit. So it's going to ask to retrieve information that's contained within the configs module, such as the time and date, what the current user is, and which current space we're currently in. We'll see that in the PX view of the component that we added the PX view to, which is our header folder. But if we came into the header PX file, some of that information is not contained within the file system. Now, the file path to that information is still saved within the PX file, so we'll be able to see it within the PX view, but we won't necessarily be able to see it in the PX file because it doesn't have that information within the file system. So this will make sense a little bit. So what that means is there will be a time at somebody, now keep this part in mind, there'll be a time where somebody goes to the PX file, especially the header, and they're going to say, hey, my header lost all of its information. I don't see the title, I don't see the time and date, I don't see the current user. all that information's gone on my header. My header's broken. It's probably because you're looking at your header in the PX file. Now, how people usually get mixed up with this is because one of the first steps of the next lab is saying, hey, go to your PX or your header PX file and drag it into the new PX view that you created for your hot water pump system. And what people tend to do after that is to continue to work into their PX file of whatever graphic they're working on after that. And then they notice, hey, my title's not there, my date and time's not there, and blah, 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 blah. They think their graphic's broken. They'll send an email out to me and Damon in the middle of the night saying, hey, I don't know what's going on. Or it's going to cause you a lot of headache and you're just going to wait until tomorrow morning to figure out, oh, hey, I was just in the wrong spot. So if you, this will make more sense as we go along. So if you run into that, check where you're working, use the locator bar. You might be working in your PX file. So long rant, but it's gonna save you some time, I promise you. All right. So we've got this new PX view, right? It belongs to our header folder. I want to make sure that I'm actually working my header folder. I can see that by my locator bar here. I want to make sure that I'm in the edit mode, which we know this by this grid system here. Now, there's a few things that we need to rework here. So since I'm making a header, if we look over here in the widget tree, we can see we have this thing called a scroll pane. Now you can imagine what a scroll pane does. It allows us to scroll through the graphic, right? But I'm making a header. I want something, this header is going to belong at the top of the screen, and I don't necessarily want it to follow as I scroll down through another graphic. So let's say I'm trying to view a graphic on an iPhone or a smart tablet or something. And when I scroll further down into the graphic to see all the image, I don't want that header to chase me and still take up a bunch of my view, right? So we don't want it to have the scroll ability. So there's something that we need to do in order to fix that issue. And this only applies to creating something that you don't want it to be scrollable, or for this instance, making a header. This isn't something you're going to do for every PX view that you create. This is something that we're only going to do for the header itself because we don't want it to be scrollable. Because when we add it to other PX views, we don't want it to scroll along with the rest of the graphic. So to do that, what we need to do is over in the widget tree on the right side here, I need you to hit the drop down arrow next to scroll pane. And what we're going to do here, after we do that, we can see that we have this canvas pane. That's this. This is what we want to keep. We want to keep this canvas pane because that's where we want to work, because this is where we're going to see our graphics. But we don't want the scroll pane. And unfortunately, this canvas pane is contained within the scroll pane. So, simple fix. What we're going to do is we're going to right click our canvas pane in the widget tree and we're going to cut it, or Control X. It's the same thing as making a copy, but we're making a copy of it and then we're deleting it pretty much. That's what a cut does. And when we do that, we see that we have this this thing here, this object here called content. And it's got a little square and an X, meaning there's nothing, on that content, but this is the root of our graphic here. So after we cut our canvas pane, the next thing we want to do is select our scroll pane and delete it. So we can right click it and delete it, or we can select it and hit the delete button. So all we should have now is this root, the root of our PX view. Now you can take a wild guess and say what we do next, now that we got rid of that scroll pane, and you'd be right if you say we're going to copy, or we're going to paste our canvas onto this root. So what we're going to do is we're going to right click our root in the widget tree. We're going to select paste. Now we can see that we have our canvas pane back. Now the root, it belongs to the canvas pane and not that scroll pane that we got rid of. So one step further to start adding things to the graphics, but there's a few things that we need to do. So we're making a header, so we need to limit the height of this thing, as we don't want it to be this tall. This is just like a banner that we're adding to each of our graphics that we're creating, and we want it to, be kind of narrow, or short rather. So we need to change some properties of the canvas pane itself. So to do that, what we need to do is double click in the middle of your canvas pane. So double click anywhere within this canvas section, the grid section of your canvas pane. So double click that. And what that will do is will bring up the properties of the canvas pane itself. Now, if you did this on top of a graphic item, if you double click on a graphic item, you're going to get the properties for that graphic item that's in the, but since we just clicked on the canvas pane, empty spot in the canvas pane, we get the properties of the canvas pane itself. So there's a few things we're going to change here. One, we're going to change the size of the canvas pane itself. We're also going to assign a background color. Now the lab says to assign a certain color, and I'm going to let you guys choose which color works best for you. And the reason I say that is because the particular shade of blue for me, because color deficiency, right? I can't see the canvas or the grid in the canvas when I assign a certain shade of blue or a certain shade of a color. And it might be the same for you, and it might be the same for you, especially because you're logged in remotely. Your pixels are a little off when you're looking at the screen through the remote view. So you might not see the canvas either. And it's important for us to see the canvas, the grid, because anything we place on the grid is what's visible. So the next step, what we're going to do is we're going to change the view size first. So at the second to last option on the bottom of the property sheet here, we see view size, and it should say 1000 by 800. We're going to change that. So to change that, we can simply click this field here where it says 1008, 1000 by 800. So we can click that, and we're going to get this little view size box that's going to prompt up, and it's going to say, it's currently set to 1000 wide by 800 high, right? We want to set it to 900 wide by 100 high. So we're going to set the width to 900. We're going to set the height to 100. Actually, I might be changing the width, keeping the width at 1000. I know the canvas pane just got a little bit bigger with the 411 version. So let's go ahead and hit OK. We might be coming back to that and changing that width to 1000, or we can keep it at 900, whatever. But next we want to change the background color. So to do that, if we look at the top of our property sheet, we see the background section, and we see that it's currently set to default, and that little grid pattern there saying that there's no color assigned. There's nothing assigned to the background. So if we click within that space here, either within the space or this drop down, or no, we don't want to hit that drop down. We want to hit within the space here where it says default. And when we do that, the color chooser window opens up, and we have a couple different ways that we can choose the color that we want to set our background. So we have a color picker in the top left over here with predefined colors. We can use the color sliders over here, along with the color slider on this side. We can adjust the hue, saturation, brightness. We can adjust the alpha, which is like the visibility of it, whether something is more prominent or more faded. We can also do hexadecimal color codes if you're familiar with that, and that's what the lab wants us to do. And I'm going to go ahead and do that color just to show you, and maybe it will be hard for you to see as well. But I'm just going to show you why I chose to change the color, and why you might need to find a color that best suits you. So we'll go ahead and set that. So we're going to go set it to a hex color of hashtag 4040FF. Now you can go ahead and choose a different color if you wish. Go ahead. But I'm going to go ahead and show you what that looks like. So I don't know how it looks for you, but for me, it's kind of hard for me to see the grid. So depending on your eyesight, obviously, and your color preference, feel free to change the color to whatever color that suits you for now. So I'm going to go back by double clicking within an empty space here, and I'm just going to pick something like cyan. Also, you have a color drop-down box here in the bottom right of the color chooser, and you can cycle through named colors if you're looking for something specific. But I'm going to choose cyan. It's an easy color for me to use and for me to see the grid. And this is important because when I drag items into my PX view here, it has to be within the grid system itself. Because if I add a PX item or graphic item and I place it outside the grid, that graphic item is actually not going to show up. You'll be able to see the resizing handles for it, but it's just not going to show up. So anything that's we want to be visible has to be within the grid itself. So that's why it's important to be able to see the grid. Something to keep in mind also, if we want to zoom in or zoom out of our PX view, we also have these magnifying glasses in the toolbar at the top here. So we have the zoom in and zoom out. You can use that as you wish, and you can resize these, these widget trees or the nav, the sidebars to make things easier for you to see your entire page. So go ahead and set your view size from 900 to 900 pixels by 100 pixels. And go ahead and set your background color to something that suits you. And once you do that, press OK. And we're going to look at our header. And what we're going to do is we're going to toggle view modes so that we can go ahead and save what we've done so far. So if you're at this point, go ahead and hit that pencil icon on our toolbar at the top. That's going to save our graphic. Now notice when we hit that view mode, our canvas disappears, but our entire screen still shows blue. That's just because we've limited the view size of the graphic, and that will display when we add this header to other PX views. Right now, it's just going to show the entire screen blue, but really what we're going to see in other graphics is whatever's contained within this canvas section here. And just kind of something to keep in mind, a header is not something we're going to have you guys do for test day. This is just kind of like a nice little introduction to graphics, something easy to kind of sink your teeth into before you start jumping into something a little bit more complex, like creating a heat pump graphics, right? So this isn't something that you're going to be doing Friday. This is just an introductory lab. So if you haven't already, go ahead and hit that pencil icon at the top to save your work. Once you've done that, hit the pencil icon again at the toolbar to go back into edit mode. You know you're in edit mode when you see this canvas here, right? Once you do that, then we can go and start section C, and we're going to add a log off widget to the canvas, and that's going to be in one of our palette windows or one of our palette libraries. And this is an example of a pre-configured functional graphic that has functionality to it. We don't need to assign it to anything. It's already got a file attached to it that gives it functionality when it's clicked. So a nice, easy tool to use. So what we're going to do here is we're going to look for a palette. So we need to go to our palette window. We know where that is. It's bottom left of our screen. And we're going to go to that open palette button because we have never opened this palette before. So that folder icon and the palette window. So just click that, and then the filter section, what we're going to type in is kit px. So lowercase k, uppercase p, x. So kit px, and I think you can just type in kit as well, and it'll show up as one of the options. So we're looking at kit px. When you find that, press OK. And within the kit px palette, we have an array of buttons, graphical buttons that we can add to our graphics. Some of them need to be set up. Some of them are self-contained functions. For example, something like an action button, hyperlink button would be something that you need to set up further once you add it in. You have to go to its properties and set that up further. Whereas something like a save button or a log off button is a pre-configured button. We don't need to do any additional setup for it. We add the graphic button to our PX view, and that's that, plug and play. It'll log off. When we click it, it'll log off whatever current user is currently logged into the station. So what we want to go ahead and do, one of the few cases where we actually drag an item from our palette into the PX view is right now. So we're going to take our log off button from our palette and drag it into a part of within the canvas of our PX view here. Now I'm going to go ahead and do it and show you what it looks like off the canvas. If I drop it outside of the canvas, look what's going to happen. The button's not actually going to show up, but I still see the sizing handle. So it's there. I just can't see it. So to remedy that, I can easily move it to the canvas pane. And actually, when I try to move it, it's automatically going to snap into the canvas pane section. So I'm going to try to move it and see it's already going to go to try to snap down in the canvas pane. And actually, after I do that, I can't move it outside of the canvas pane after that. So we're going to add the log off button to our canvas. Again, this is a pre-configured button with a function that we don't have to, or doesn't require any further setup. So we're going to position this to the top right of our canvas here. That's where that's going to live. And after we do that, we're going to see our first instance of what the difference between a bound label and an unbound label. So to create a bound label or even a bound graphic, the process is much the same. So we need to open up our BACnet network. So we need to open up our expand our station, expand config, expand drivers. We want to expand our BACnet network. We need to expand our MSTP heating system device, expand its point module, and we need to expand the heat pump IO points folder that we have. And what we're looking for is our outside air temperature sensor point. It should be at the top of the list. Hopefully it's at the top of the list for you, under your points folder. And what we're going to do, this is the first step when you, for almost any time that you're trying to make a graphic bound to an object or a component within your system. And then this way we can take real-time data from that component and have a graphic representation or view that data within the graphic itself. But in order to do that, it has to be bound. So what we're going to do here is we're going to take our outside air temperature sensor and we're going to drag it onto our canvas. So drag your outside air temperature sensor, your point from under that's contained within the heat pump IO point folder, and drag it onto your canvas. Now when that happens, we get that make widget wizard that we saw in the slideshow. And we have different options here. So by default, it might show that the option is from palette. And we see that we have the kit PX palette as the palette of choice right now. Now we can change that to any kit, to any palette that we're looking for in particular. But for this instance, we are actually going to use the bound label option, which is the top option here. So we're going to bind this label. We're making a bound label. So we're making a label that's going to be bound to our outside air temperature sensor. Okay. So we're not done just yet. So now that we changed it to bound label, our window here changes a little bit. And if we look at the instructions in the lab book, we need to adjust some things. So in the format text, it's currently reading %.%. Now we could leave it %.%, and it would give us some sort of data back from the point itself, but it's not going to be refined data that we might be looking for, or the specific data that we're actually looking for. So what we want to do is we just want to show its out value. Whatever the value in the out slot of that component or that point is, that's what we want to display. So within the format text, leave that %.%, but within the percent signs and before the period, we want to type in out. And then on the other side of that, that period there, we want to say, or that dot, we want to say value. Now, if it's easier for you, you can go ahead and just delete all of that and then type in a % out dot value %, if you wish. But this is what that looks like, the format text. Okay. And we're not done just yet. We need one more option. And what we need to do is we want to make this bound label, but we also want to make an unbound label along with it that we're going to use as the name for the label. So we're making a bound label that's going to display the current value of our outside air temperature sensor, but maybe we also want to make an unbound label that just labels that value tag that says, hey, this is the outside air temperature sensor, or the outside air temp. So we also want to select this checkbox down here at the bottom called Make Display Name Label. I'll zoom in on that. Okay. And when we have the Make Display Name Label checked as well, we should be good to go ahead and press OK. And that's going to create two different labels for us. The one on the left that says outside air temp underscore sensor, that is your unbound label. All that's doing is taking the name from the point that we added. This is not bound to any particular item. This is strictly a naming convention label. And then we have this other label here, which is the bound label on the right side that has 0.0 degrees Fahrenheit, because remember our outside air temperature sensor is actually not working or reading anything. It's in fault because it's offline. So we're not actually going to have a reading in here, but there's something cool that we can see here when we dive into the properties of this bound label. So okay, so what we want to do first is we can reorganize these in a sense if you want to, or you're going to be here in just a bit, but what we want to do first is the label, the unbound label, the one that says outside air temp sensor. We want to click that, highlight it. We want to double click that. So we want to double click the label that says OAT temp or OA temp underscore sensor. And this will take us to the properties page for this label. And we're just going to change some format and text for it to just make it a little bit cleaner. So what we're going to do is at the top, we have an option for background color within the property sheet. So we were to click that, the background color. And we're going to set this to black. So we can use the color picker, swatch up here in the top left of the color chooser and just pick this top right box here, which is black. We'll press OK. Now, the next thing we're going to do is change the font. And this takes a couple of steps, but what we're going to do here is this little box that says default next to font. We're going to click that, or rather, we click the ellipsis button at the far end. Oh, there we go. I was going to say it should work both ways. Mine took a little bit of time to open up, but you can double click the field that says default. Mine, for some reason, took about 10 seconds to launch it. So it's set to a current default font, but we want to override that and set it to something a little bit more custom. So to do that, we need to uncheck this null checkbox. And when we do that, we see that we have options available to us now. The first thing we want to set is the font style. And we want to change, or the font rather, and we're going to change the font from sans serif. We're going to drop open that drop down menu, scroll all the way to the top, and we're going to select Arial or Arial. So drop down menu, scroll all the way to the top of that drop down menu, select Arial. And once you do that, we're going to leave it at size 12, and we're going to set the font style to bold. Okay, so Arial font style bold, font size 12. Once you have that, we're going to go ahead and press OK. And then we need to change the foreground color, which is the field just under font. And what the foreground color is actually the text color, the color of the text. So if we click in the field, the default field here next to foreground, we're just going to change this to white, which should be the bottom right option in your color picker palette up here. Once you've selected white, just go ahead and press OK. So we're changing the foreground color to white, or the text color to white. And the last thing we need to change, if we go a little bit further down the property sheet here, we'll find a section called text. And the text currently says OA temp _ sensor. We want to make this something a little bit more legible, easily understandable for more of the novice user. So let's just change it to OA space, put a space between OA and temp. This is one of the few times that we actually put a space between words, and spell out the word sensor, just like that. Okay. So there's one more thing that we need to do real quick, and that is to change the H alignment, or the height alignment, and it's currently set to left. So what that means is the text is going to be aligned to the left side of our box here, of the label. We don't want that. We don't want it to be aligned to the left. We actually want to align it to the center so that our text is in the center of our label box here. So click where it says left under H align, or next to H align, just under foreground. And we're going to change that to center. And from there, we're going to just, after we set the alignment, we're going to press OK. We can see how the label has changed. Our font's bigger. It's now white. It's different font size, or font style now. The background color is black. You might want to grab one of the handle on the right side or left side and drag it out maybe 1 or 2 notches with it in comparison to the canvas to make it a little bit wider so that we can see the entire label. And we probably want to do that to match it for the bound label just under it. If you haven't done that yet, you can go ahead and do that now as well. Move these 2 labels to the top left of our header here. And then move your bound label just under the outside air temperature sensor label, and scale it to the same size. So now that we have our unbound label set up, now we're going to set up our bound label. So to do that, just like we did with the other label, we just double click the unbound label. So that's the label that has the 0.0 degrees Fahrenheit. Let's double click that. And we're going to set up slightly similar with some variations. The first thing we're going to do is just change the font. We're not actually going to mess with the background color at all. So we're going to select font. So within the properties, we're in a bound label based off its title up here. There's a few other things that are worth noting for bound labels in comparison to the properties of the unbound label that we were working on. If you look at towards the bottom of the screen here, we see that we have a section called bound label binding, and there's this slot called ORD. And what this ORD slot is almost like a file structure link back to our outside air temperature sensor. So this is the binding. This is the binding path back to our outside air temperature sensor. This is where it knows. This is the path of how it gets its information from our point, our outside air temperature sensor point. This is how it feeds it its information to show you what its current value is. This is important because this is how we're also going to open our ORD binding to retrieve certain information that's contained within the config space, such as date and time and current user. But we don't need that quite yet. What we need to do is change the font. So back towards the top of our properties page here for our bound label, we want you to locate the font section. And we want to click that default right next to the right of font. We want to uncheck null. We're going to change the font to Arial. Pretty much everything that we change font for in these graphic labs is going to be Arial. So if you want to know the pattern ahead of time, just about every font's going to be changed to Arial. But we're not going to change the font style or size here. We're just changing it to Arial. We'll press OK. Now, the next thing we're going to do is the last step for the bound label is towards the bottom, I believe, under the bound label binding. So, the bottom section here, the bound label binding section, there's a section or a property called status effect. And we can use this to show what the current status is for the point. So if the point's under normal conditions, it's not going to have a color. It's just going to be a white background or whatever. Since we're using a transparent background, it'll actually be the background color of whatever our header is. So for my case, it'll be a cyan blue color in the background of the label if I don't have any current status flags on the point itself. But we do have a fault status on our outside air temperature sensor that we know of. So you can assume that we're probably going to have an orange status light currently on our outside air temperature bound label that we've just added. Now we have an option to set the color. There's also this option to color and blink. What that's going to do is it's going to blink orange or whatever status color it is back and forth between that and its background color. But I'm just going to use the status effect color, and that's all we're going to change here. So again, that's the status effect at the bottom of the screen under bound label binding. And we're going to change that from none to color. We're going to select OK, and we can, once we press OK, we can see that the status color has overridden our bound label, and we can see an orange status. So this would be kind of handy if you set up a graphic on a site or within a system, and you want to have information like that. So you have a list of, you know, temperature sensors or what have you, and something's currently in alarm or in fault. At a glance, you can see something's not right before even seeing an alarm for it. So imagine if you had something like this on a home page, right? Okay. So we have this, and there's so the next thing we're going to do is we're going to add a border to these two. So to do that, and there's a trick to getting rid of a border because it's going to cause an issue. So the first thing I'm going to tell you here is make sure that you have, if you're going to add a border to anything, make sure it's in the location that you want it to be, and the border is the last thing you want to add because the border makes things a bit difficult to move things around that you want to be grouped. So we'll go ahead and click and drag and select both of these labels here. And then you can just right click in within any of these two. Right click it, and towards the bottom here, we have an option for border, and we can add a border to it. What that's going to do is it's going to add a black border around the two labels, makes it look a little bit neater. Now, this is where the issue kind of comes into play. So once I've added a border to it and I decided I want to move it or rearrange it, I can select both of them. But when I go to try to move them, for whatever reason, what happens is only one moves, whichever one I'm clicking on to move. Kind of makes things a little aggravating when you're trying to reorganize things, especially something you've added a border to. And if you select both of them and you right click, notice that it deselects the one you didn't right click on. That's a little frustrating, isn't it? And you can go to the border, and all that's going to do is have you the option to add the border. We see that we have an option to remove border, but we can't get to it with both of them selected. Now we could, and we don't even have the option to remove the border just by selecting one of them. So here's the trick. We need to select the two items that have a border around it. And what you want to do is hover your mouse over one of the handles. And you know you're hovering over one of the handles when you see the arrow change, your cursor arrow change to a resizing handle. Now I know there's some issues that some people run into when working with your remote computer, that sometimes when you move your arrow, your cursor over a resize handle, the cursor doesn't always change. So do your best, if that's the case for you, do your best to just kind of position your cursor over the sizing handle. And what you're going to do is right click over the sizing handle. And now you have the option to hover over border and remove the border. And when you remove the border, now you can group them, select them together again and move them. It's a little tedious to have to do that. I couldn't tell you why you have to do that. I think it's a bit of a bug, but there's the workaround for that issue. So again, to remove a border from something, you need to select the items that have a border on it. You need to right click on a handle of on one of these objects, which is the resizing handles. That's these little squares here that are around it. So right-clicking on one of these resizing handles, then you can go to border and remove border if there's one. And then to add a border background, it just select both of them and go to border and add a border again. So we're going to create another bound label. And in the same manner, we're going to drag our outside air temp point to our graphics. And that's this point here within our heat pump IO. That's the numeric writable that we dragged in, and we have both our outside air temp sensor and our ramp, our outside air temp simulator feeding into this. So we know it's actually going to have some sort of value that's going to fluctuate inside of it. So in the same manner, let's take our outside air temp point from our point list or our point folder here. So outside air temp, and drag it onto the canvas pane. Most of this is already set up from the last time that we did it. It should be. We're gonna make sure that we have bound labels selected. The format text should still say %out.value, out.value %. And the make display label checkbox is still checked. Now remember, this box is checked only when we want to make an additional label for a bound label that we're creating. So it'll make one bound label that has the data, and it's going to make an unbound label that's not bound to anything. It's just used for naming conventions, making labels for those data labels that we're creating here. So we're going to press OK when we do that. And just like we did in the same order previously, we're going to set the properties for the unbound label first. So select the outside air temp label, unbound label, double click it, and it's going to be set up in the same way that the last one was. So we're going to go to the top, change the background color to black. So go to the top, find background, select the box where it says default, click it, select black from the color chooser. And then after you set the background color to black, we're going to go to font. So find the font section, click on default to the right of it. Remember, we need to uncheck the null box, the null/default box. We're going to change the font from sans serif. We're going to click that drop down box. We're going to grab the slider handle and go all the way to the top of the list. We're going to pick Arial. We're going to keep it at size 12, but we're going to give it a font size or font style of bold. So Arial bold size 12. We're going to press OK. And just under that, we have the property to change the foreground color. Now remember, that's the text color. We're going to select the foreground, and we're going to change that to white. And press OK. And then after we change the foreground color to white, we're going to change the alignment, the horizontal alignment, and we're going to change that from left to center, and that's located just under foreground color. Okay, and then lastly, what we're going to do is a couple spaces down in the property sheet, we're going to look for the text section, and it should just say OA temp, but we want to change this to, we want to put a space between OA and temp. And after temp, we want to put a space and then type out value. So it should look something like this. Okay. So once you have all that set up, let's go ahead and press OK. We can reposition this unbound label just under outside air temperature sensor, maybe a space between the two. We definitely want to use the sizing handle to the right of it, at least to make it the same width as the previous labels. And if we want, we can go ahead and take our bound label, which is the one with the value, the fluctuating value here. You can actually see real-time data within this bound label, which is kind of neat, right? So we can take that and position it under our outside air temp value label and expand it to match the size. And once we do that, all we're going to do is change the properties of that bound label, the one that's currently reading actual data. We're going to double click it to go to its property sheet. And the only thing we're going to change, the only two things we're going to change is the font. So, locate the font section under the properties. And after that, we're going to change the status effect to color. So locate font under the bound label settings. Select that box that says default. We got to uncheck that null/default box from the drop-down menu. Grab that the handle, scroll all the way to the top and select Arial. So we're going to select Arial and then we're going to press OK. And then at the very bottom of our property sheet here, we're going to select the status effect and we're going to change it from none to color, just like we did with the previous bound label. Okay, so now that we have that done, we're going to press OK, and we can see that we don't have any current status flags for this point, so therefore the background color is still transparent. We can see the blue in the background. If you look in the lab book, background color might show white, but since we did not set a background color for this, this is going to stay transparent for us. Once you have it positioned in the where you want it to, select both the outside air temp value label and the outside air temp bound label. So these two that we just added, select both of them. We're going to add a border to it. So select both of them, right click within one of them, go down to border and add border to it. Okay, once you do that, we want to go ahead and make sure that we save our work. So we need to go up to the top of our screen to the toolbar here. We're going to select that pencil icon to switch to view mode, which is also going to save our graphic. Once we do that, we're going to hit the pencil mode to go back into edit view or edit mode. We know we're in edit mode when we see the canvas here. And then what we're going to do is we're going to add a widget to show what the current user, who the current user is, or what the current user is logged into. You get what I'm saying. Who the current user is logged in. So what we need to do is go to drawing a bound label from the palette onto the canvas. So from the Kit PX palette, you might need to expand it here. Actually, it's at the top. So we've seen how we can create a bound label by dragging the actual object we want to bind it to from our navigation bar, our navigation tree, into our graphic window or PX view. That's one way of creating a bound label. Another way to do it, so let's say we're going to bind this label to whoever's currently logged in. We want to get that information. Well, that might not necessarily be something that we can find within our nav tree or easily find within our nav tree. So one way we can do this is just create a bound label from the Kit PX file or Kit PX palette. And then we can bind it to something after we've dragged it into our canvas. So if we take the bound label from our palette here in the Kit PX, which should be the top option here, it's got this little icon with an A with a box around it. So we're going to drag our bound label onto our canvas, and it's just going to show up as a blank, empty label here. And what we need to do is we need to go into the property sheet to actually bind it to something, and we're going to go ahead and change the font and so on. So let's go ahead and double click our bound label that we just added to our canvas. We're going to change the font. So we're going to leave the background color and the foreground color to default. We're going to change the font. So find the font section. We're going to click that default. Remember, we need to uncheck the null default box. We're we're going to hit the drop down menu. We're going to scroll all the way top, select Arial, and this time we're going to change the font size from 12 to 14. So font Arial size 14. Once you've done that, go ahead and press OK. We're going to change the horizontal alignment to center. So find the H alignment, H align. It's already currently set to center, so make sure that it is set to center if it's not. And then down in the text section, if we go a little bit farther down, it's got a yellow box and it currently says null. It's because we've created a bound label, but we currently don't have any text in it, so it currently says null and it's not bound to anything, so this is what we get. So we need to, what we're going to do here in the text section is actually make a statement saying this is the type of information that we want to be displayed here. So within the text section, if we click that yellow box there, this text box will pop up and it's going to ask us object to string format. So what we're going to input here based off the lab is we're going to type out current user. So current space user. This is static text that's going to show up. This current user text is going to show up. And then here next is formatted text. We're going to put in a colon and then a backslash, not a forward slash, backslash. That's the button under backspace on your keyboard. So current user colon backslash the letter N percent user left and right parentheses percent sign. So it should look something like this. So what that's going to say is within the text field of the label that we've just created, it's going to show current user and then colon, and that little formatted text that we put there, the in percent user parentheses percent. What that's going to do is it's going to retrieve whatever the current user is logged into the station. This is the beginning process of creating one of those open bindings. And so this is the type of information that's not going to show up if you double click your PX file under files, because the PX file, the file system doesn't have this information. Now, this string of text that we're putting in here is going to be saved to the file system, but it's not going to have the current user information within that file system to retrieve, to return any sort of data for us. So this is one of those instances, if we're looking at our PX graphic through the PX file view, we're going to see some blanks. Okay. So current user colon backslash in percent user parentheses percent sign. Okay. So we're going to press OK. Now the text is still going to show up as null because it's currently trying to output some sort of data that ties back to a binding that we don't currently have set up right now. But if we were to select on the yellow box again to bring up the text editor again, we can see that we still have our current user text string that we added there. So don't be alarmed that you don't see your text string within the text box here. So the last thing we need to do is come down to the bound label binding section, which is the bottom quarter of this property sheet. And the top option is ORD. So this is the binding section. This is the ORD, or the path to bind it to something. And this is going to be a open slot binding. So all we're going to do here is we're actually going to click where it says null. And we're going to type out slot and then colon. And what that's saying is we want to retrieve this information. Where do we want to bind this information? And it's currently wherever this graphic is residing, or wherever we're currently residing. And this information like this is contained within the config space. So where this graphic is viewed anywhere in the config space, we'll be able to see this binding. Again, if we were to look at this in the PX file view, in the file version, we won't see this information because this information can't be found in that section. So we're gonna press OK. So just slot colon. And when we press OK, we should see our label populate. And we're gonna have to expand our label here a little bit. So I'm gonna move mine 2 notches to the right and at least 2 notches tall so that I can see the entire label. And we can see that our current user text is showing up, and it is showing the current user is admin. So that's the type of information that our our formatted string text is retrieving for us with the open binding there. So after that, we can go ahead and move that under our log off button. That's where that's going to live. Okay. Now, for any reason that you've gone through all those steps and you do not have a current user information, it might return null. It might return a string of text or something within that bound label. Go ahead and let us know. It's probably just a simple typo.
Yeah, I don't see on mine says the current user admin.
Okay, which workstation you at?
15.
15? All right, we'll take a quick look at it,
Yes.
Demons. It's probably just a... You're in the PX file space. So remember, our file space, so you got to look at your locator bar. So if you look at your locator bar right now, that dark gray bar at the top of our workbench here, just under the toolbar, if you follow it far enough to the right, you'll see that you're actually in the file space. And remember, since this is an open binding, this is asking for information that is contained within the config space. The file space doesn't have what the current user is currently logged in. So if you go back to your your header folder here under config, you should see it. So go ahead and just make sure that you save it, just in case. So hit your pencil icon to save your graphic, and then I promise you, if you go up to your header folder, double click your header folder under the config space, that current user is going to show up. So that's what I was trying to warn you guys about. If you get it's easy to get mixed up if you start working in the file space. Anytime you have some sort of open binding, that information is not going to show up within the file space. Now you might ask me, why am I even going through the process of doing open bindings? There probably is a way that I could do a direct binding back to whatever the current user is logged in as. The reason we're showing you some of this stuff is if you're trying to make a graphic for multiple pieces of equipment, and we're going to see that in one of the graphic labs that you're going to do this evening or tomorrow morning. You're going to make one PX view for your air handler, and then you're going to make pretty much a copy of that graphic for your other air handler. And the way we're going to do that is open bindings, just like we've done here. And that can be useful when you're making a PX view for multiple pieces of equipment that are very similar, such as air handling units or fan coil units, VAVs, and so forth. So that's the reason. So definitely want to check where we're working when we're working with graphics. So if anybody comes to an instance where they don't see bits of information, it might be because you're working in the file space. And that's only it's only an issue when you're working with open bindings. You can work on your PX view or within your PX file itself. It's just you might not have all the information depending on what you're doing. So let's go back to our header folder, make sure that we're working within our header folder here under the config space. Let's go back to the edit mode. If you haven't saved, go ahead and save now. There's a few other things that we're going to add here before I let you guys go. So we're going to make a label, a display label that's going to show which graphic we're currently in. So when we're done with this, it's going to display header. It's going to show the title of our folder. So when we add this PX file to our boiler control IO PXV that we're going to create later, the header is going to change and say boiler control _IO. Okay, so we're going to drag out another bound label from our palette. Just like we had done for the current user admin, let's make sure that we're working within our PX view of our header folder here, because we're still working with open bindings. So grab that bound label from your palette and drag it onto the middle of your canvas. Okay. And I'm going to go ahead and take an extra step. So once I have this dragged onto my canvas, I know my display, label display, is going to take up pretty much the remainder or most of the remainder of my header space here. So I'm going to go ahead and drag it to, and I'm going to leave at least one column of space between to my display name and my other items here. I'm going to do the same thing for the top and the bottom. So that way I go ahead and expand this display label. So when I change the font size to something large like 36, it's it's going to show when I'm all done. So after you resize your new bound label that we dragged in, double click inside of it to get to its property sheet. Okay. And what we're going to do is we are going to change the font. So we go to the font section, we click on the default to the right of it. Oh, that was color. Click font. And remember, we have to uncheck that null/default box. Drop down menu. Take a wild guess. And if you picked Arial, you would be correct. And this time we're going to change the size from 12 to 36. And we're going to have a font style of bold. Okay, so Arial, bold, size 36. You're going to select OK. We want to make sure that our H or horizontal alignment is set to center. So that's right under foreground. We just want to make sure that it's set to center. If it's not, hit that drop down box and select center. Which I believe by default, the bound labels from the palette, the H alignment is center. So we don't have to worry about it too much. And then we need to go down to the text. Remember, it's that section with the yellow box around it, and it currently says null. We need to enter some format text, a format string. And this one's going to say %display name %. So let's click that yellow box in the text field. I'm just going to overwrite what's already there. I'm going to type out %. I'm going to type in display. And then I'm going to type in name with a capital N, all one line. And I'm going to end it with a %sign. So it'll look something like this. Okay. So after that, I'm going to press OK. And now I need to change the ORD binding. So currently it's set to null. So if we go to the bottom of our screen here, or the bottom of the property screen, remember this is the ORD binding, the bound label binding section. The ORD is the binding section for our label or any of our graphics items that can be bound. So this is the ORD slot. So let's go ahead and select the box that says null. And we're going to change it from null to slot : to make an open binding. And what this is going to do, it's going to show the display name of whatever graphic this header is going to be embedded into. So again, if we make a graphics for our chiller or our air handlers, when we embed this header into this graphics, the display name is going to change and show air handler or chiller or whatever, or wherever we're located, right? Let's go. Once we do that, let's press OK, and our text changed to header. Now, obviously, this will change when we assign this header PX file to another PX view. We'll look at that here in just a minute. Okay, so we have our display title, our display name. And if you haven't done,
kind of missed that. What did you do on the ORD?
we're just typing in. I'll show you. So on the ORD, we want to select where it says null, that box next to the right of ord, and we just want to type in slot : okay. All right. So once we have that, when you press OK, if you haven't already, you need to resize your display label to go ahead and make sure that it takes up majority of your canvas, but leave a little space at the bottom, at least one line of space at the bottom here. So we want to go and make sure that it's big so that when we have a long display name, such as, heat pump IO or something like that, that we have enough space to display the entire display name. Okay. So once we have all that set up, let's go ahead and hit that save button. So that the pencil icon at the top, we have 1 or 2 more steps before we're done with this. So we're gonna hit the pencil icon to go to view mode. It's gonna save our graphics, our PX view. Hit the pencil icon again in the toolbar to go back to edit mode. All right. And the last thing where we're going to add to our header is a label to show the time and date. So this could be useful information, right? Okay, so again, same process. Drag a bound label from our palette, just like we've done a couple times now. Drag it onto the bottom center of our header here. And I kind of position it as close to the center of the bottom as I can, using header as kind of like the header title as like a center mark. We'll have to reposition it again once we expand this to show the date and time. But once we have this in, we need to double click on to the space for the bound label that we just added. And again, this is kind of just a rinse and repeat kind of exercise here. So again, we're going to start off, once we get to the property sheet, we're going to start with the font. We're going to click the default box next to it, or the box that says default next to font. Uncheck that null/default box. Hit the drop down menu for the font. We're obviously going to pick Arial. And we're going to change it to a font style of italic, and change the size to 14. Okay, so Arial, size 14, the italic style. We're going to press OK. It should, but just to make sure our H line is set to center. And then we're going to come down to that yellow box that says null right next to text. And we're going to click that yellow box. And within that yellow box, we're going to type out %, time, left and right parentheses, %. I'll zoom in on that for you guys. Okay. So once we've done that, so %, left and right parentheses, %. We'll press OK, and then we just need to set the ORD binding. And again, all we're doing is coming down to the bound label binding, since we're making it an open slot binding. We are changing the ordinance from null, so we're going to click null, and all we're typing is slot : So what this is saying is retrieve this information that I'm looking for, where the current time is within the current slot that I exist in. And that might be within the boiler IO, it might be within our header folder. Either way, all of these things are contained within our config space, our config module. And the config module houses various information like the current user, the date and time. What current display are we looking at? That's what we're doing here, saying, hey, look within the space that we're currently residing in and get this information if it exists. So once we have all that set up, again, we're just changing the font to italic Arial, size 14, changing the text to %, time, left and right parentheses, %. And then we're changing the ordinance, or the ord binding, to slot colon. Okay. And then we're going to press OK. And when we do that, we can see that it is populated with the current date and time. So we might need to, we'll probably need to resize this a little bit to see the entire date and time field. And if you need to reposition it, you reposition it to make it more centered, you can. But this pretty much concludes the Lab 13 to make the header. Now you will see later on in the air handler graphic where we're really going to use open bindings, and it's going to explain it to you within the lab of how to set it up and what to type into the ord binding, right? So we're not going to, you're not going to have to go back and try to figure out what it is. We give you step by step of how to do it. So after you've done that, we want to go ahead and save our header. And I'm going to go ahead and show you what you need to do to add this header into another PX file or another PX view, because this is where it can get a little tricky. And this is how people tend to accidentally work within the file space, which it's okay to work in the file space, but as soon as you start working with open slots or open ordnance or certain items like that that are looking for specific information that might not be contained within the file space, that information or that graphic item is not going to show up. Okay, so that could be the bit of a caveat there with working in the file space. So I like to say it's best to just work within the PX view. Whatever you added the PX view to, whether that be a points folder or whatever, that's where you probably should be working on your graphic itself. So try to get in the habit of that, but I don't like to tell people that you can't work in the file space, because you absolutely can. It's just, it can be a little confusing if you look at it and see certain pieces might be missing or not showing up, and you think that it's actually missing, but it's there. You just might not be able to see it. So if you ever find yourself seeing your graphic and something is clearly missing that should be there, double check where you're working in and use that locator bar at the top there. If within this locator bar it says file anywhere in it, or .px, probably in the file space. But we still need to use the file space for things. So just to show you, now don't try to follow along with me, I just want to show you this because it's getting late and I want to go ahead and brush on a couple things with you real quick that you're going to run into, because there is going to be a handful of labs that you need to do this evening, and I'm going to give you time to work on them tomorrow. At the minimum, you'll have an hour tomorrow. So we'll actually pick up and start class at 10 a.m. Eastern. So you'll log in regular time, whether you want to log in early or log in whenever. Continue to work on your graphic labs. I'm going to tell you which graphic labs to work on in just a second, because we're going to exclude some of the graphic labs. So one of the first steps that we're going to be doing here in the next lab that you'll be doing this evening is you're going to be adding your header graphic that you just created and then embed it into another PX view. So to do that, I'm just going to do it, and I want you just to watch me, not try to follow along with me, because I want to do this kind of quickly because there's a couple other things I need to show you guys. So I'm going to create a new PX view on my heat pump IO point folder. That's going to be the next thing you end up doing in the next lab. Again, just watch me. I'm going to right click it. I'm going to go to views. I'm going to go to new view. It's going to ask me what I want to name it. I don't exactly remember exactly what we're naming it, but I'm just going to say heat pump PX. I don't name it whatever the lab tells you to name it, but I'm just trying to show you. Right. So I created a new PX view. This PX view belongs to the heat pump IO points folder. So This is where I go to typically work on it. Now, what's going to ask you to do is just going to ask you to open up the files module under your station. And then you're going to open the PX file. And this is where we see our PX files, right? We can see that a new PX file is created for our heat pump PX that we just created, right? Now, see, this is where it gets tricky. So in the lab, it's going to say, hey, go to the file system, grab your header PX, the one you just created, grab the PX file of it, and drag it onto the PX view of your heat pump IO. You need to drag it onto your heat pump IO PX view. So with the heat pump PX view opened and the edit mode opened, come down to the file system, click on your header PX file, drag it into the PX view, reposition it, and notice how it says heat pump or heating pump underscore IO. It got the display name from my points folder that I added the PX view to. Now I'm going to save it and I'm going to show you what it looks like if I went to my heat pump PX file. So I'm going to double click my heat pump PX file. Look, I lost my display name, I've lost the date and time, and I've lost the current user. Okay. The header is a good indicator if you're in the wrong spot to be working in. So keep that in mind. So to save you a lot of headache, something's missing. You're probably working in the file system. Go back to where you added the PX view to. So if I go back to my heat pump IO, double click it, because the PX view is the new default view for my points folder. It's going to show me my heat pump PX view or my heat pump graphic. And it's going to actually populate with my display name, the current time and date, and the current user. Okay. So that's how you do that for the next step. You're going to drag the PX file into the new PX view that you create. And then once you're done with that, close file, collapse files. So you don't accidentally, it's easy to find yourself in the PX files. It's not necessarily a bad thing. It's just, it's easy to misjudge missing information there. All right, so there's that. And then there's one other thing that I want to show you guys, and it's important. It's going to really help you for the next one. So we saw how we made bound labels now, but how do I make a bound object, right? So I know I've got a pump that I need to add to my graphics. So again, just watch me. Don't follow along with me. Just watch me, because this is just a lot of information that I'm trying to just give you as quickly as possible so you guys have plenty of time to work. So I need to make a graphic for my pump, but it's a bound graphic. So I want this pump to animate or turn colors anytime my pump changes state or does something, right? So in order to do that, I know that it is contained within a certain palette, the pump that I want. So give me 1 second while I look up which, I'm pretty sure I know which palette I'm looking at here. Okay, so I'm going to find my HWP1 underscore control, because that's going to represent my pump, right? And what I need to do, because I'm making it a bound graphic, I'm going to drag it into my canvas here. And then I'm going to get the Make Widget Wizard window. This is where I look for something that is contained within a palette. So I'm going to select the From Palette option here in the Make Widget Wizard. And then I need to look for the specific kit, the palette that I'm looking for. And this one is called Kit PX N4 SVG. And this, again, this is all written out in the lab, the first few steps of the lab. So it's going to show you where to go to find all these things and exactly what to tie it to. Right, okay, so I'm going to open up my kit PX N4 SVG within the Make Widget Wizard. Now I'm going to look for my pumps. So I'm going to look for this folder called pumps here. I'm going to expand it. And what I'm looking for is pumps in line. And now again, the lab tells you which one to look for. With this selected, then I can press OK. And it should create a pump for me, or graphic item to represent my pump. There it is. Now, if I go to, I'm just going to show you the wrong way to do it. So if I go to the Kit PX N4 SVG palette window in the bottom left of my screen here, and I scroll down into pumps here. So I go to my pumps folder, I find the exact same pump that I just added. But if I drag it out of my palette window here, drag it onto my canvas, guess what? It's blank. Because there's some graphic items that are meant to be bound to something, and if it's not bound to something to give it data or a current state, it doesn't know which image to show you. And I'll show you what I mean by that. So if I double click this, I'm trying to find the exact portion of this. The image here. So see this yellow box called image, or the yellow box that says null next to image. If I click on this, look, it's looking for a true value and a false value. But it doesn't know if it's true or false because the current status is null. So it doesn't know which image to show you. So therefore it shows no image. So there's certain items, or there's a lot of graphic items that are meant to be bound to an actual point. And if you don't bind it to a point, it's not going to show an image. So there will be a time that you'll be working, you might forget this little bit of information, where you're going to try to drag in a coil or a fan for your air handler, and you drag it in, it doesn't show up, and then you keep trying, and it's not going to show up. Again, certain graphic items are meant to be bound. Now I can go back and bind this back to my hot water pump control after I've already added in. But it's just as fast too. Let's just go back and drag in the exact point that I want to bind it to into my graphics, select from palette, select the palette that I'm looking in, find the item I want to link it to, and do it that way. You can go to the object that you dragged in from the palette that needs to be bound. You can go to this ORD binding here, and you can select this file icon here and drill into, you gotta get like component chooser, and you gotta really drill into and find the exact component that you're trying to tie it to. So that's why I say it's possible. It's just way easier to drag that item or that point from our nav tree in here and then link it to the palette from the Make Widget Wizard. Now, there's one last thing I want to show you guys, because this can be a little confusing too, especially if you just kind of brush through some of the instructions here. All right, so for example, I'm going to open up because this is where you'll see it. I'm going to open up my air handler real quick. I'm going to open the points. And so remember our cooling coil and our heating coil here. We set these as Boolean points. Now, typically, if it's a DX cooling or electric heat, that'd probably be something that's binary or Boolean. Or if we have modulating cooling coils or heating, these would typically be numeric, right? So we have two different data types. Just like we have two different data types, we might have different styles of graphics that are meant for certain data types. So if I take my cooling coil, which we know is Boolean or binary, it's one of two states, on or off. If I drag this on here and I go to coils, I'm going to go to DX one stage. So one stage DX cooling. I know this is binary. And so I select OK, and I will get a coil that pops up. But if I take the cooling point and I drag it and I try to attach it to something that's going to be numeric, that's supposed to be numeric, and I'll show you how you can check after you dragged it in to tell between the two. And you can also tell within the image slot here within the Make Widget Wizard. So I'll just show you this way first since it's here. If I pick this, look how when I hit that button next to the ORD on the image section, look how I have modulation ranges from minus infinity to 20, 20 to 40, 40 to 60, 60 to 80, 80 plus, right? I have images, states of the image or the graphic assigned to different numeric values. Okay. So if I add a Boolean or a binary type to a numeric type, it's not going to meet any of those numeric values, so therefore it's not going to show anything. So again, I added the cooling coil, which is binary or Boolean, to an item that's meant, a graphic item that's meant to be numeric. So that's how you can tell. So if you try to do that, you're like, I'm doing it the right way. I'm adding it from the nav tree. I'm adding it to my graphics. I'm picking a coil or I'm picking a fan or something, and it's just not showing up. The next thing to do is check the data type. And again, you can easily do that either by the Make Widget Wizard and look at the image. And it's going to show the different transition states of the image and what constitutes which image is going to be showing. So again, I showed you the numeric. I'll show you the binary again. So image shows right here. If I click within here, I see that I've got a true value and a false value and an image to represent either of those values. So I know that's binary or Boolean, one of two states. And then we have numeric. Double click the image or the graphic image, even though it's not showing anything. Go to this property page, click on the image, which is typically a yellow box, and we can see that we have numeric values. And if I look over here, my point here, this little icon next to it is telling me that it's a binary or Boolean point. So this isn't going to work for this. So that's a little, that's a in-depth heads up to when you get to that portion of creating certain graphic items. It's best to just pull it from the nav tree. Sometimes you have to double check the point type that you're adding. Now the lab does a pretty good job of telling you exactly what you're going to be adding from the palette, from the Make Widget Wizard. But sometimes it's easy to kind of skim through it and misread something, and that's how typically people accidentally add just the cooling coil instead of reading that they need to add the cooling DX stage 1, right? Okay, so that's the basics of what you're going to be accomplishing here this evening and tomorrow morning. Again, we're going to start at 10 a.m. Eastern. If it looks like people are still struggling to kind of get things done, I might add an extra half hour on there, but don't hold your breath on that. It really depends on how far along as the class is moving as a whole. The main thing is to get as much of the graphics done as you can. Now, I said that there's only going to be certain labs that we're actually going to be doing. So let me go ahead and show you which ones we're going to be doing here tonight for homework. So we have done labs 13. That was creating a PX file. That was creating the header, right? So we're going to be doing labs 14, which is creating heat pump graphic. We're going to do labs 15, which is creating a boiler graphic. And then we're doing labs 16 to create an air handler unit. And then we're doing lab 17, which is creating a dashboard PX. I haven't showed you much on that, but you should be able to figure it out based on the lab instructions. And if anybody has any issues with it, we'll go over that tomorrow morning. So again, we're doing labs 14 through 17. So if you need to write that down, go ahead and write that down. And it should say in the lab book now. It used to not, but it should say in the lab book now that labs 18 through 18 and 19 are optional. So if you get really far ahead and you got some extra time to play around, you're more than welcome to do the power meter and the chiller graphics. But the main thing I want you guys to focus on is 14, 15, and 16. And if you get to if you just don't quite get to 17, that's okay. It is part of the test where we do that, and I will show you guys in depth of how to do the dashboards. But the main takeaway from doing all these graphic labs is looking at the different ways that we can create graphical items and the different methods of creating them. So some of this is going to be rinse repeat. So before we close off, does anybody have any questions?
I'm good, sir.
Okay. I know there's a lot to take in, but I'll leave the floor open while I'm packing up. If anybody has any questions before I close the meeting out for the evening.
Is there a list of like all the Niagara functions, like the time and accessing the user name and stuff like that? Is there like
I know some of that can be found in the help document. Exactly where to find it, I couldn't tell you off the top of my head. That's a Damon question. He's not here at the moment. So bookmark that question. I'll try to remember. I can't promise I'll remember it, but bookmark that question. Ask me tomorrow.
Okay.
We'll see if Damon's got an answer for that.
Thank you.
How do I have a question, quick.
Sure.
How do I get that unit Fahrenheit on the graphics? I just see numbers, but not another.
Okay, so you probably have to check the value text or the text. So, for example, if I go up to here, I am actually gonna have to notice how all these are contained within this graphic now. I can't actually select them. So if I go to my header, yeah, we're gonna save that. It will be check the text here. So %out.value%. And then if that's correct and it's still not showing, double check your facet on that point. Make sure it's actually assigned the Fahrenheit facet. Because I'll show you. If you don't have this %.value% on there, and we put it back to its default, which is %.%, it'll still give us information, but it's going to look like that. But I don't think that's the issue you're having. So I would double check your text. And if your text string looks fine within the properties of the label, I'd go back to that point and double check your facet for it.
Okay. Thank you.
Mm-hmm. And if that still doesn't fix it, don't spend too much time on it. It's not a big deal. But if it still doesn't fix it, we'll look at it in the morning. All right, guys, if nobody has any other further questions, I'm going to go ahead and end this call, and I will see you guys in the morning.
All right. See you in the morning.